getting a microphone to it, I think. Oh, goodness. I'm just hearing the background, like.
take the notes here. Hello, good morning. Hello. I thought there were more people here yesterday. Come on! That's a bit better. That will also invite other people from outside to, ooh, things are starting here. Might as well get in. Stop having coffee and tea. And I'm going to leave more time for people to come around. Who went for a run this morning and therefore fully awake? I'm the only one. Who went to the gym and the gym was closed because they only open at 8? Yes, I see those. These are like blurry-eyed people. All right. So, few announcements before leaving the floor here. First announcement, we'll have a group photo here at 11. So at 11, wherever you are, come back here and we'll do all sorts of awesome pictures with absolutely every one of you and someone going on a forklift, I was told. And I'm personally coming just to see the guy on a forklift to see what could happen there. Tonight, we have evening events with game nights, 9 to 11 in room beta. So if you haven't understood how the rooms work here, it kind of follows a fucked up alphabetical order, which is someone who didn't really understand letters in Greek, but decided to name the rooms in Greek with Greek letters. So alpha is the furthest away, omega is here, and in the middle, it's not always following the order entirely correctly. But already, that gives you a bit of a sense of directions. And there's robotic water sports from 9:30 to 10:30. So that is, if you don't know what that is and you feel like, ooh, that sounds exciting, well, that's exactly what it's supposed to be. I have no idea what it's like, but robotics and water sports, that can only be good. Electricity and water, yes, great. I was told, though, that no one would actually be put in the water at the same time. So if you're interested in any of those, come over, beta rooms, that's say 9 to 11. On this note, I found out recently that in a parallel universe where the USSR dominates the world rather than the US, we would probably be in Silicon Valley, because this is where the USSR started building silicon chips in Riga. And therefore, that gives me a great introduction to talk about hardware. And Daniel, floor is yours.
Okay, good morning, everyone. I'm here to talk about what it's like to build an open and repairable laptop. Yes, who am I? I am Daniel Schäfer. I'm a system software engineer at Framework. I'm German and I live in Taiwan. And what is Framework? We are a new computer company, barely 4 years old, and we're still a very small team, just over 40 people. Located in the US, in Taiwan, and one person in Canada. And we are trying to make good laptops and trying to change the industry by doing so, by being a good example. Yes, we try to have more repairable, open, sustainable, user-owned and customizable laptops. Currently, we have two laptops, basically. The one I'm currently using, the one they were using for the keynote yesterday, the Framework 13. And we're coming out this year, end of this year, or it will ship early next year with a bigger version, the Framework 16. And I brought a prototype today, so later you can come check it out. It's still an early version, so some things are not super smooth, but we're getting it ready. We actually have more products than two, but basically two sizes that each are their own series. Repairable. Why do we want to have a repairable laptop? Or what does that mean even? It means that it can be repaired. Users can repair it. They can figure out what's wrong. They can diagnose the issues, and they are able to fix it themselves. Or if they don't have the skill, they can have somebody else who has more experience with it help them fix it. And if you repair it, then you don't have to throw away your computer that's still good, and you can avoid e-waste. By doing so, you can keep it for longer, and you can maintain it. This is especially great for big organizations who have a ton of laptops, and when something breaks, they want to keep the value of what's still there and just fix the piece that's broken. Yeah, so you can end up saving money and saving the planet. Then how do we make a laptop repairable? First of all, if there's an issue, you need to, like I said before, you need to figure it out, and you need to be able to solve it. To do so, we have published lots of guides for repairing pretty much every piece of the laptop. And to find the guides, you can look at the piece that's broken, and we have a QR code and everything. And if you scan it, it will link to a guide online that helps you fix it. In addition to that, if you can't figure it out, we have good support. We do answer every support request that comes in. And if that's not enough, or if you have something that you want to ask other framework owners, we have a community forum where you can discuss with each other. Yes, so all parts are user serviceable. If there's anything wrong, you can exchange it. For example, recently I wanted to change my keyboard layout to a different language, and you could change the entire front plate of the laptop. You can easily take it off. But then I realized I did this, and the fingerprint reader has the fingerprint stored inside it. So if I change this, I have to re-enroll my fingers. So I just unscrewed the fingerprint reader, put it in the new cover, and yeah. Right, not only are all parts serviceable, but if something's broken or you lost something, you can buy every part from us. Big things like the mainboard, the display, the keyboard, and even little things. If you lost a screw, if your hinges broke, or if you lost a small cable while disassembling, maybe you disassembled on the train and lost the internal cable to the display, you can get everything from us. And we do have full schematic available, not to everyone because of NDAs with partners, but if you're a repair shop, we can sign an NDA with you and you can get a full schematic to do all kinds of board-level repairs. Right, how do you design a repairable system? Many products, they're glued shut, or some pieces are glued, but we don't do that. We avoid it. And I have to be honest, there's one part, the Wi-Fi antenna is stuck to the back of the lid, but you don't really need to apply it and put it back. So if you just get a new antenna, you stick it and it's fine. For everything else, we have screws, and if you buy the laptop, it will come with a screwdriver. So you're ready to go, and we do want you to open it. Right, so we have just 2 screw heads. You can flip it around here, and there's no special type of screws. If you lose a screw, we have 3 screws in the case as a backup. And many of the screws, they are captive, they don't fall out. So right now I have my laptop unscrewed, but the screws, they are still stuck in place. And to hold things together while you're taking it apart, or some things, they don't need screws, they're just stuck together with a magnet. So for example, the display bezel is just stuck together with a magnet. While you're taking it apart, you're going to disconnect things and reconnect things. So oftentimes you might break the connectors. That's why we made sure to use connectors that can handle unplugging and replugging. sometimes internally we have competitions at the office to see who can swap a mainboard the fastest. So they can really take a beating. And to make it repairable, you don't want to have to exchange like a giant part that has many subcomponents. If only one of them is broken, you want to exchange only the one component. So for example, for the audio port, it's on a separate breakout board, which you can exchange separately from the main board. And the ports on the sides, HDMI and so on, they're on separate expansion cards that you can hot swap. Right, and even more other parts are also socketed, which many modern laptops don't do anymore, like the Wi-Fi card, the RAM and SSD. You can just buy off-the-shelf parts and upgrade them, replace them. So what if you upgrade a part? If you buy a new mainboard, what do you do with the old one? We don't want you to throw it away. If you just upgrade and the old one is perfectly fine, you can reuse it. For example, the motherboard, you can put it in a case. You can just use the motherboard on its own. Either on its own, or you 3D print a case. We have the design online, or you can buy a case from us made by a Cooler Master and use it as a computer, basically. To do that, there's a power button directly on the mainboard, which you can use to power down. And the community has taken this very far. They have put it in many enclosures. They have built an all-in-one computer, like a computer with a built-in screen where you just plug in the power and you can use it like this. Or somebody took a touch screen and 3D printed a case and basically made a tablet out of it. Used all of the other components that we have, just exchanged the screen and case. Or even a cyber deck where somebody has just a mechanical keyboard in a box and the mainboard inside. Yeah, lots of other things, like you can use the screen by itself. You can get an adapter to connect it to any other computer, or the keyboard also. Somebody made an adapter that makes it usable as a USB keyboard. Here, this is the case that you can use for your mainboard if you want to use it standalone. You just plug in a USB-C power adapter and Ethernet or keyboard, a screen. Okay, so when trying to make it repairable, there are some troubles. It's not the average design. Because we have so many magnets, magnets and electricity, they sometimes don't interact well with each other. With high frequency, they can make parts vibrate and cause audible noise, which is not nice. So sometimes we have to tweak the design or tweak the firmware to change some frequencies to avoid annoying noises. And because we want to make sure that you can keep upgrading year after year, we have to be really careful when making changes, when making improvements, that everything still fits. If you, for example, use a new mainboard in an old chassis or an old mainboard in a new chassis, we are making it compatible both ways. Right, so we have to make sure the connectors are the same. They stay in the same place. They have the same pin out. And the shape, of course, has to be the same and fit. Because we have so many parts to the laptop that we sell individually, it's a big challenge logistically, instead of just selling one laptop, but lots of small parts. And while repairable sounds great and excites lots of people, especially in this room, but if I go to a regular person and say, look how easy it is to take apart the laptop, like I just did, you lift off the cover. Many people, they get scared. They're like, I don't want to open my laptop. I'm afraid I will break it. Even if I tell them that it's super easy and you won't break anything, it scares them. So it's best to tell most people it's just a regular laptop. Don't worry about it. Just keep it shut. Yeah, because our mainboard you can use by itself. You don't have to use it in the chassis. This is a special design. Most mainboards can't do this, so we have to have some firmware and WE changes to make this work. Especially because it can run without a battery. And one thing in the firmware we have to change is if the PD controller is the power delivery controller. We have one on each side for the 2 ports on each side, and they have firmware. And when you update them, but you run the board from that port, like the board is powered from this port, but you're trying to update the firmware of the component that powers the board. How do you do it? Well, you can't. But because we have 2 sides, we have a mechanism that tells the user first update the one that is not powering the board, and then you have to plug it in the other side, and then we can update the other one. Okay. Like I said, we have forwards and backwards compatibility. Now, with the new 16-inch, we have basically 2 lines that are compatible within each other. And our 13.5-inch has already had 5 different mainboards with full compatibility. So the chassis I have here, there's 5 different mainboards that you can put inside, and that work perfectly fine. The only exception is we have a Chromebook variant, and some of the components like the touchpad and the camera, they have slightly different firmware. But you can change the firmware to make them work. So if you bought a laptop that we sold in 2021, you can keep your old chassis, keep your old battery, screen, and so on. And it supports every update that we have released so far. For example, we have released a new screen that is matte instead of glossy. We have released stronger hinges, because some people complained the screen wobbles too much. Lots of new mainboards. A battery that has better chemistry, so it is the same size, but it supports higher capacity. Speakers that are also the same shape, of course, same connector, but they are a little bit louder. And the screen bezel, you can change very easily, just magnet. And we have different colors for that. All right, tons of upgrades, the ones I listed. And like I said, also different keyboard languages. For example, recently we started selling in Taiwan. If you want a keyboard with traditional Chinese, you can change it now. We also released more expansion cards. If you're not familiar, those are the ones on the side, the ports. The main board just has USB-C, but if you need HDMI, DisplayPort, microSD, and so on, you use expansion cards. And we have released upgraded versions that use less power, and we have released more expansion cards, like Ethernet expansion cards, and they're compatible with all systems. On top of that, there are many potential upgrades that we might or might not do. So there could be displays with different refresh rates or resolutions, maybe a better camera, different kind of touchpad, RGB keyboard perhaps. Lots of people are asking for like a ThinkPad nub instead of a touchpad, or in addition. I can't say what we're working on right now, but some of these things are coming. Right, second one is open. We want to be open in every sense of the word. We sell hardware, and after you buy it, it's your hardware. You should be able to do whatever you want with it. You can run any operating system you like. We support Linux and we support Windows. Other operating systems also probably work too. Yeah, so not just you can do whatever you want, but to know what you can do, we published a lot of documentation about what the hardware can do, how it works, and we published source code for a lot of the firmware. And we encourage you to tinker with the laptop, to take it apart, or to even make your own modules. Okay, what have we published so far? We have published the interface specifications of the mainboard, of the connectors, of all of the modules. So if you want to reuse any module, like the display, you can make your own adapter, make your own 3D printed case. For some, we have sample 3D print CAD files, like for the mainboard case or for the display. And for the 16-inch, we have some electrical sample designs for replacing the keyboard. And firmware, we have some open source firmware, like the embedded controller, which is the one that controls the keyboard, the power management, and the backlight. It is already open source, and it's based on Chromebook's EC firmware, which is already really mature. So we got a lot for free, and we are very grateful to the Chromebook team. On the new 16-inch, you can, let me go back to the picture. Bad idea. You can hot swap the keyboard and the touchpad. So basically everything on top is a USB device. The keyboard is basically just a regular USB keyboard. And that means it needs to run its own firmware. And the firmware for this and for other modules we made is fully open source and already published. Right. Specifically about the firmware, 2 weeks ago I gave a talk about all of the open firmware and customizations you can make at the Open Source Firmware Conference. So if you're interested in that, you can check it out. That's especially interesting because it's a good way to get started with firmware. Firmware is quite intimidating, but if you want to get started, you can do it with the keyboard, and there's really nothing you can break that can go wrong. You can always recover from it. The embedded controller would be very scary to get started with, because if there's something that you do wrong with the power management, you could damage things or break your laptop. What kind of troubles have we had making it open? Lots of vendors, they choose one Linux or Windows, but we want and we need to support both, and it's almost double the effort. And a lot of partners or vendors, they're focused on Windows, and to make them support Linux, it takes some pushing, and some things we have to do ourselves. The expansion cards, they are basically adapters, like what we've got hanging around here, and operating systems don't expect adapters to be plugged in always, and mainboard designs. So we had to make some changes to make them use less power than they would usually. For example, the audio expansion card, it detects if there's a cable plugged in, and if there isn't, it will just not be powered at all. So even the operating system can't see there's anything. For the DisplayPort expansion card, we changed the firmware to do a similar thing, to detect if there's a cable, and then change the behavior to actually not to make the card use less power, but to use the mainboard less power. Similar with the HDMI card, there's also firmware update, but it needs some hardware changes. So you can either buy a new card from us, or we published a guide to rework it, but it needs some tiny soldering. So if you're comfortable, you can do that. If not, you can find a friend that can do it, or you can just buy the improved card from us. On top of that, the PD controller that I mentioned earlier, we made some changes in that firmware to detect which expansion card is connected and if there's something connected to the card, and to make it turn off some components in the mainboard and to make them use less power. Right, the framework 16, because it's so modular, because you can just take off some modules like the keyboard and the touchpad, it's a lot of moving parts, so it's quite a mechanical challenge to make it sturdy, not flimsy, especially with the speaker, because if there's any flimsy part, the speaker is going to make it vibrate, and that's going to cause annoying noises or bad sound quality. And because the keyboard is a USB keyboard, which is not normal. Usually USB keyboards, they're attached from the outside. And operating systems and their drivers, they don't expect a USB keyboard to be built into the laptop. So I'm still currently trying to figure out what the Windows driver is doing and why it doesn't enable some power savings. Linux compatibility. It's not that difficult to make a laptop that has all components work well on Linux. You just need to choose components that already have support. For example, many laptops, the fingerprint reader doesn't work on Linux, but if you just choose one that has driver support already, it's fine. Okay, I don't have much more time. Let's go through these quickly. The silicon vendor helps us fix a lot of bugs. We had to make some hardware workarounds because there's a bug in the Linux kernel. We have some extra BIOS options for Linux. We released firmware on LVFS. For some components, we had to port some LVFS drivers. We have some custom software to control the laptop. And yeah, we support the user to run whatever distribution they want. We have support for the users. We have a dedicated Linux support person who helps users install and figure out issues with the Linux installation. And we have installation guides for many distributions because each of them may have separate ways to install the fingerprint software. And we do some internal Linux QA. Yeah, why do we do all this? We care. We care about the users. We care about the environment and technology. We want to make awesome technology because it's fun and it makes us proud. And like I said in the beginning, we want to set a good example for the industry and hope they can make similar designs in the future. And of course, it's also a bit selfish. If people can repair and upgrade, they will keep buying from us. If you can just upgrade your mainboard, you don't have to switch to a different laptop. Right, there's some things that we can do better. We have to make sure that we keep compatibility. We want to be even more open source firmware. Right. And some questions like, should we pre-install Linux? Which some people might want, but me personally, I think if I want Linux, I'm just going to install it myself. Yeah, if there's anything else, you can let me know. You can find me afterwards. I'd love to hear your feedback. All right.
Brilliant, thank you. So, I was going to say, for timekeeping reason and because the other sessions are going to start, we won't have time for questions, but Everyone can find Daniel at any time, especially I'm sure there will be loads of questions around the Linux side of things. So feel free to chat with Daniel otherwise. Craig from Microsoft is going to be presenting in as quickly as we can. And otherwise, have a great session. See you all here at 11 again for the pictures, yeah? Good morning. The floor is yours. To avoid this, I'll give you a 5-minute warning. You will have the time at the bottom, but I will also give you a 5-minute warning. The broadcast is not. You good to go? Awesome. We're going to get started. If you're ready to talk about where most people nowadays, frankly, experience Ubuntu for the first time, Craig, the floor is yours.
Awesome. Good morning. Hello. So hi, my name is Craig Lowen. I'm a product manager at Microsoft, and I'm here today to talk to you about why Windows is an awesome place to run a Linux environment, which is a weird talk to give. And my favorite part about giving this talk is the why part at the beginning, because it's strange. I work for the Windows operating system. I work on the Windows operating system team. Why am I telling you to use Linux on Windows? And you are all Linux users and Linux enthusiasts. Why would you ever want to use Linux on the Windows operating system? And that's really the goal of today, is to show you what that's all about, why we do this on the Microsoft team, and kind of our goals and some fun demos. And so specifically, I work on the developers for Windows team. And our goal is to make the Windows operating system as awesome as we can for developers, to make it as fun to use, as interesting to use, and as powerful to use as possible. And I think for some people, you know, the image on the screen is Windows on the left, Linux on the right, and our goal is to bring them together as much as possible to make the Windows subsystem for Linux. So that's why we actually created this. And if you haven't tried out the Windows subsystem for Linux or WSL, what that allows you to do is run a full Linux environment directly on the Windows operating system. It's true actual Linux. We have an open source Linux kernel. We run actual Linux binaries provided by the distro maintainers themselves, like Canonical, with Ubuntu being our most popular distro. And it is run by millions of users. And Yesterday, Mark Shuttleworth, when he introduced this conference, talked about 3 groups of people who are here. And one of those, the third one, was corporations like Microsoft who are here and supporting open source software. And yes, that can be for selfish reasons, but I can actually break down for you why we do that. So on my team, the key result that we have every year that we look at is how many users are using the Windows operating system, and that's my department. And on my team specifically, I look at how many people are using Linux workflows on Windows, because our goal is to make it as easy as possible to use these different workflows on the Windows OS. And where that applies for you is you are either developing open source software for people to use or using it yourself. And if you're developing it, WSL existing improves the reach of what that can go to different users. I'll give Moonray as an example. Yesterday, there was an awesome talk by the Moonray team about how they open sourced their ray tracing technology and put it online as open source software. They are an entirely Linux shop. They don't run Windows, but that's not the case in the ecosystem. And so when they open sourced, they wanted people to be able to go use it right away, and they didn't want to port directly to Windows because they don't have a need to do that, and that takes a lot of development time. WSL existing allows all the users who are in the open source world who like using Windows to immediately be able to use that and contribute to your project. So there's already a direct benefit if you're developing software. And then if you're using open source software, Microsoft developing and supporting the open source ecosystem benefits you. As well, if you're forced to use a Windows computer, you have Linux available to you as well. So you can try it and use Bash as you want. And these are actually, I really only have 4 slides in this deck because I want to show you a lot of demos today of what that looks like in action. So we're going to hop out of my deck, and we're going to go to my desktop. And I have some different demos of cool stuff that I want to show you about how you can use WSL and some of the latest innovations that we've done at Microsoft to improve Linux workflows. And so here I have Windows Terminal, I have Ubuntu, and I'm just going to make sure that I'm running Docker. Great, I am. And we can go and run this project. So I'm going to run code, and I run VS Code. And I can go and open this project up just by running code-insiders. And what you'll notice is even though I'm running this in a Linux context, so I can go to pwd, you can see that this is actual Linux that I'm running. It's all running on the Windows UI and Windows stack. And so the ethos of WSL is very apparent of it all feels exactly like the same machine. And I'm going to just reopen this inside of a container. And why that is because Windows, we work with GitHub. Microsoft works with GitHub a lot. And we have dev container definitions, which allow you to specify a Docker container to control your project, to control the state of your project, which I've done here. And it works great for especially difficult projects, which is what we're going to be running today. We're actually going to be running a large language model and image generation locally on this laptop. And so the scenario that I'm going to describe is put yourself in the shoes of a game developer. You want to supercharge your game with AI. And one of the ways that you want to do that is you want to automatically generate character portraits for a character and have it generate multiple portraits in different environments for the same character. So what we're going to do is I'm going to start the project early because it takes a while to load these libraries. And we're going to take a look at the code because we're a technical audience. And you can see we're actually loading the Llama 7B model. And so Llama is a large language model that's developed by Meta. And this was actually open sourced in collaboration with Microsoft. So you can go to github.com/Microsoft/Llama2 or Llama2 if you are have more of an American accent. And you can go and download an entire large language model. Large language models, or LLMs, power things like ChatGPT online, and they give really intelligent answers to complicated questions. So you can actually download this model and run it locally, which is incredibly powerful. And why that's cool is because these models are run 7B, stands for 7 billion parameters. Usually these run in the cloud because they are so resource intensive. And we're actually going to be running that today locally on this laptop. And so what are we going to ask this incredibly powerful machine? We're going to say, hey, please input an animal that you would like to generate game portraits for. And then we're going to ask it to fill in the blanks. So we will be asking it to play Mad Libs for us. And we're going to say, please fill in the blanks of a character that's a certain color, wearing an accessory, doing an action. So standing, sitting, jumping. And the LLM is going to choose that for us. So in this case, we're going to choose an animal. I'm going to pick Pomeranian, because they're one of my favorite animals. And we're actually going to start running this on the GPU. And so this is all happening locally on this machine, and it's going to start generating an output for us. So a blue Pomeranian, ... And while this is running, I actually wanted to stress this machine a little more. And this comes into the second point that I made earlier of we integrate with Microsoft. You can get some of the best benefits that Microsoft has while running this as well. Because this machine actually has a neural processing unit on it that's separate to the GPU. So we're running this workflow on the GPU, so a blue Pomeranian wearing a sparkly collar, sitting on a fluffy cloud, and panting with excitement, which is pretty cool. And while we're going to be generating the images for that, I am going to go ahead and run an AI workflow on this neural processing unit. So I have a photo of myself. I can go to Studio Effects, and this is a workflow that's detecting my face, and it's automatically panning the camera to look at me. And it's also adjusting my eyes. So right now, I'm looking directly at the screen itself, but it's moving my eyes up towards the camera. All of that work is being done by a neural processing unit on this machine. And so, speaking to a Linux audience, that's cool. That's a neat demo that this all works, and I could go use that with Zoom or Teams tomorrow. I want to go try that out. This is a Microsoft Surface laptop that was announced recently, which is why it has some cool cutting-edge tech in it. You can go try that out, and you wouldn't be abandoning Linux at all. Everything that we're running here today is a Linux workflow that's open source. You can have the freedom to choose and use a different operating system while still being able to be super connected with the Linux ecosystem. And so at this point in the setup for this demo, it's generated these images, and then it's going to be opening them up for us. And so we're going to be able to see 2 different images. And where that gets generated is down here. We are using Stable Diffusion. And we have asked it, hey, to create a character portrait in both the woods and a city view. And this done a pretty good job. We have a blue Pomeranian dog wearing a sparkly collar. The cloud part, it didn't really get so much, but it is both in the woods and in a city view. And so in this way, this was an example of, this is an open source project, and one that's the code's available online. All of the tools that I've used are open source. And we got a really cool advanced AI workflow happening right here locally on the machine. And last thing I'll point out is, you might notice, for those of you with sharp eyes, that this is a GDK tiling up here. And so this is actually a Linux GUI app that is running directly on this machine, which is very cool because it even shows up here in my task manager. It's directly integrated with Windows. And again, that's the goal of, and the beauty of the Windows subsystem for Linux. All of those work seamlessly together. And so it's actually somewhat difficult to tell that I'm running a Linux app and a Linux workflow here. And that's why we actually put that little penguin tux on the bottom right of those taskbar icons to help you differentiate. I want to show you some other demos as well. And we're going to flip over machines to do that. So this ran locally on this device. What I'm actually going to do is jump to another device. And so one of the other cool things that we do at Microsoft is we have this project called Microsoft DevBox. And so you can run, let me go to devbox.com. Actually, that's more fun. You can go and access a machine anywhere in the world and run the same machine inside of the cloud. So I have a dev box that I actually use when I'm traveling to do all of my work. It exists here in the cloud, and all I can do is go connect to it, and then I can go and open this and interact with this wherever I am. And that's cool. Some of you in the audience might go, okay, like why does that matter for Linux? And the obvious answer there is because it is powered and works great with the Windows subsystem for Linux. So even though this is an entirely Windows product, it was entirely Windows focused, we made sure on the Windows subsystem for Linux team that this whole workflow works great with WSL. And now, as a Linux user, and I do almost all of my development work directly in Linux, I can get access to this awesome feature directly. And so I can go use this DevBox tool and access this, and it's all supported by my organization, Microsoft. And I can go use these Linux tools wherever I am in the world, which is pretty awesome. And in that, we're going to go and run some other demos. And I wanted to show you some other cool AI stuff because Microsoft is doing a lot with AI these days, and our goal is to make sure that that works great with Linux workflows as well. So here I am inside of this dev box, and it is, again, running on the internet, and it is an entirely different machine. You can even see that I'm running a different version of Windows down here. And in this case, we're going to take a look at another project. This is an open source project that's a pet project of mine that I use for demos as well. It's called Auto Task Calendar. I'll show you what it looks like. So you can go to autotaskcalendar.azurewebsites.net, and then I'm just going to log in with a test account. And you can go in here, and you have a calendar that just automatically slots in tasks for you. That's it. So very, very simple thing. This is what I actually use to schedule my work during the day. So whatever task that I need, I type it in and make it work here. And that is open source. And I have the project here. And I'm running it inside of this VS Code project here. And let's actually take a look at the source, because we're going to make a live change to it today. So I can go to github.com, auto task calendar, and here's where all the code is. And what I want to show you is some of the ways that the investments that Microsoft are making can help apply to an actual Linux workflow. So we're going to go ahead and make a change to this website. So all I need to do is go and hit Control tilde. That's going to open up my terminal. I am running Linux in here, of course, and I'm going to run npm run dev. And so this is going to start up my server. I have a database running locally on this machine. I also have the website running locally. And I could just go to localhost 8080. I click that, and that opens up in my Microsoft Edge browser on Windows. Even though that's running in Linux, everything is automatically forwarded over. And I have my test account, and you'll notice that it looks entirely different than the one I just showed you online, because this is a local database. So I'm not going to go mess with production while I'm doing any changes. And speaking of that, let's make some changes. So I have this about page, which is super simple. Let's go change it, and let's change it super quickly. So this is the page where I am defining that. It uses Vue, a web framework, and you can just see the HTML here. And what I want to introduce is GitHub Copilot Chat. So I'm using Code Insiders because this is an insider and still somewhat new technology. But it allows you to incredibly quickly code with AI. And so in this case, we're going to describe what kind of change we want to make to the code that I've highlighted. And you can ask it tons of things, like how to fix my code, summarize my code, etc. In this case, we're going to say, change this to 3 columns and include ubuntu.png. I think that's what it was called. Let's make sure. Yep. So ubuntu.png. So I just typed that in, and you can see it uses a reference here. And so my team as well works on tools for bringing AI to developer workflows. And one of the key core aspects of Microsoft in doing this is we want to make sure that we're as open and responsible with AI as possible. And part of that is including what reference we show. And so you can see from what I've highlighted, it's showing this is where I referenced it. And if you used Bing Chat also shows you references of how it gives answers. Why is this important? Because AI can say unpredictable things, and it's really our goal to make it as clear as possible of how we're giving you these answers, etc. And you can see that it's actually written this code for me, which is awesome, because I'm just going to hit enter, apply it, save, and we're going to regenerate the website automatically, and it's added this here. So it's able to code that immediately for me, just from natural language. And actually, I don't like the order of that, so let's change it again. Let's move, please put the Ubuntu picture on the left, and change the text to say hello, Ubuntu conference in Latvian, for example. And so now we'll rewrite this for us, and we go, OK, that looks awesome. We're just going to slot it in, and there we go. So it's moved over the Ubuntu image to the left, and it's put in some Latvian text for us on the right. Obviously, it's gotten rid of our friend Octocat, which is fine, an unintended consequence. And again, AI is somewhat unpredictable, and I would just need to go back and explain it here and say, hey, please put Octocat back in. I didn't ask you to do that part. And so this part of the talk is saying, hey, there are tons of investments here that you can take part of and apply directly to your Linux workflow. And then just for completeness sake, let's actually go push this to main, because why not? And so I'm just going to go and commit this, and we're going to call it Ubuntu commit, and we're going to push it right to main. And while this is going up to main, we can go take a look at the code for it. And I've hooked this up to a GitHub action. And so all I do is push to main, and it will build my website. It will test it online using an online Linux VM. And then it pushes it onto my Azure website, which is also powered by Linux. And so in this case, when I've run this workflow, it does all my testing, it does all of my hosting, and all of my production is all done in Linux. And so, of course, I am testing and running a Linux environment while I'm developing this. And so after about 14 minutes, you'll be able to go online and see these changes as well, which is awesome. And without me having to go do anything with the website. So we have continuous integration and continuous deployment. And with the few amount of time that I have left, I want to show you one more really fun demo to this crowd, because this is a demo I really can't show anywhere else. We're going to do some weird stuff with WSL and kind of break the environment a little bit. And so I can go here inside of Linux, and I can go run Nautilus, which is a workflow I'm sure that's familiar to a lot of you. And I can go to other locations on my computer, and I can even go to Mount C. And now I'm in my C drive on Windows, and I can go to a folder, like I have a folder called temp here. Here we are. And I can even go and let's open my logs folder. I have some logs here, like an MSI logs.txt. I can go and open that with a text editor like gedit. And you can see this is all running on this is a Windows file. So I can actually navigate to where that is here on my machine. But I can go and open this entirely within Linux. And so it's as open as possible, right, one way or the other. I can go and access all of my Linux files directly I can access my Windows files directly from Linux. So this is the exact same file here that I can open in Notepad. But we can also do it the other way around. And let's have some fun with that. Because I can go to PowerShell, okay, and I'm going to go to CD users and clear this. And I can go to WSL localhost, and then I can navigate to Ubuntu. And so I can actually go to my Ubuntu root directory from within PowerShell. And from there, I can even run things like start dot, And I can open up Windows File Explorer to the Ubuntu location. So I can go to, let's go to Home, and I can run start dot, and there we go. So I'm able to open that up. You'll notice this Linux integration here. This is me accessing these files inside of Windows as well. So it's open the other way. And then where it gets really fun and kind of hilarious is we can do things like TTY here, which will tell me my communication to this prompt. It's at dev PTS 0. OK, so let's go there on Windows and see what happens. So we're going to go to dev PTS. And then we're going to run start dot from PowerShell. So now we're looking at the dev folder of our Linux system. And I'm going to open the TTY0 with Notepad from Windows. And we're going to see what happens when we save that. And so if I go here and I write hello world, and I save from Notepad, it will actually write to my TTY inside of Linux. And you're the only audience that enjoys this demo, by the way. So it's my favorite to give. And then while I have just 1 minute left, I'm actually going to close off with the slides that I have. And we're going to chat about basically the architecture in 30 seconds. It's really simple. It's a virtual machine. And we have a virtual machine running. We have a real Linux kernel. The actual distros themselves provide the binaries. And the magic is all done in that arrow in the top in the middle. We have tons and tons of integration to allow GUI apps, GPU integration, file integration, and more. But at the end of the day, we are virtualized with tons of added bonuses that we've made to make it all feel like the same machine. And then lastly, what are we working on next? We have performance improvements for networking, memory usage, and disk usage, improved enterprise support, and improved tools for managing WSL distributions coming. And if you want to learn more or have any questions, you can reach out to me on Twitter or X at Craig A. Lowen. And you can also check out our documentation, install WSL, and the issue repository, links on screen. Thank you very much for your time today.
Thank you. And once again, I don't think we'll have time for questions, unfortunately. So as you said, Twitter or X or anywhere in here. We'll have the next session in about 3 minutes by Adrian. So in the meantime, just feel free to just shake out. And then thanks a lot.
Thank you.
Bring your own clicker. Yes. Everyone could just sit down, and I'm going to try to pronounce Adrien properly with a French accent here. That was well done. All right, I think we have everyone. Adrien, the floor is yours.
Thank you. Good morning, everyone. My name is Adrien Pellerbe, but some of you might know me as Papiel Gringo. I've been a software developer for a decade, but I like to introduce myself as a digital craftsman. My goal is to tinker some ergonomic interfaces and delightful user's experience. Today, I'm going to introduce you to Material Shell, a project that aims at providing a more ergonomic way to navigate and organize your digital environment. So first, let's see what we can improve. Currently, all the mainstream computer interfaces are based on the desktop metaphor, which treats your screen as if it was the top of a writing desk, and where you put application on it like it was a piece of paper, a piece of document. And it was a great metaphor back in 1970 when you need, in order to introduce new users to computers, especially the professional ones. But nowadays, we use our digital devices for everything, obviously for working, but also for browsing internet, communicating with each other, watching media, playing video games. And navigating among all those applications can become a bit difficult, like searching a document inside a pile of paper laying on your desk. And switching from activities can be a bit tedious. That's why in Material Shell, we want to help you organize your use case by grouping your applications by any use case that may fit you, either by thematics, project, or activity. And to do so, we made an innovative workflow that seamlessly aligns with your natural sense of direction. And we will see how we can transpose the ability that allows us to navigate and explore the physical world into improving our experience of the digital ones. So first, let's analyze what is the natural sense of direction. Because in reality, it's a combination of two different mental mechanisms. The first one, the spatial memory, is the ability that allows us to remember the layout of a space and all objects within it. For example, in our homes, we already organize our rooms by thematics, by the bedroom, the kitchen, the bathroom, with different purpose. And we all know where they are in the layout of our house. And the next thing is to navigate through it. So that's the second mechanism, the mental mapping. The mental mapping is the ability that allows us to mentally visualize the layout of the space and allow us to find routes to navigate through it. For example, if you are at midnight in your bed and you want a midnight snacks, you can find a route to your kitchen, even in the dark, to find something to eat. And that's thanks to the mental mapping. And in order to be able to use these two mechanisms inside a digital environment, it needs to fulfill some requirements. The first one, in order to be able to benefit from the spatial memory, we need to have a digital environment that is stable and predictable. In Material Shell, every time you interact with the layout, it's automatically saved and it will persist across session. When you create a new workspace or you open a new Windows within it, it will be remembered. So if you shut down your computer and start a new session, you will retrieve everything you left. The good thing about it is that you can configure your system just by using it. When you move stuff around, like you will do in your house, you retrieve it. The second requirement is that the environment needs to be spatially organized. That means where everything is relatively positioned to each other. In Material Shell, we've made the decision to organize it in a two-dimensional grid where rows represent workspaces and column applications. When you create a new workspace, it's automatically open at the last row, at the bottom of the grid. And when you open a new window within it, it's automatically added at the far right, which is very predictable. And the last requirement that we need to fulfill is the digital environment needs to be navigable. That means you need to navigate in it by moving yourself, moving your context, using displacement. In Material Shell, we use a sliding transition in cardinal direction to navigate around, switching from application and from workspaces. And let's see how it looks like. So this is Material Shell. In addition of providing an innovative workflow, we also provide a dedicated interfaces that serve two different purposes. The first one, like a map in a physical world, it gives an at-glance view of the current state of the layout. As you can see, we have two different panels, one vertical and one horizontal. They both represent the two axes of our digital grid. In the vertical one, you will be able to see all the workspace currently open, and in the horizontal one, all the windows currently open within it. Also, the second purpose of this interface is to offer a way to interact with the digital environment by using your mouse inputs or touch inputs. And that's why you can see we have two plus buttons inside each panel. Each one allows us to open a new windows, either in a new workspace using the vertical panel or in the current workspace using the horizontal panel. So, as you can see, currently we have only one workspace with a single Windows open, which is Firefox. For the demo, we will create some new one. So, in order to create a new workspace, I have to navigate downside. So let's do that. So I'm currently below the first workspace, and I found a new application launcher that allows me to start any applications. So I will, for the demo, create a development project. So I will first open a terminal. Then I want to add a new application, so I will navigate on my right or click on the plus button, and I will be able to open a new Windows, for example, my IDE. And then if I can create a new workspace again by navigating below again and dedicate this one for my communication. So I will open my favorite communication applications, for example, Telegram. And I navigate on the right, open a new one, for example, Discord. And that's it. I just configured my environment. If I shut down my computer and start a new session, I will retrieve all the applications not opened, obviously, because we don't like to be resource intensive when you light your computer. But you will find some placeholder for your applications that you just have to click on it, and it will reopen them for you at the same place. So you can, like this, benefit from your natural sense of direction. So if I want to get back to my presentation, which is the first workspace, from there I need to navigate 2 times up, and I'm back. So let's continue. I'm very proud of the work accomplished in Material Shell, notably on the workflow, because it feels very simple and natural to use. And 4 years ago, I made the choice to make it available as a GNOME shell extension because it was the most popular environment available, and I wanted to be able part of this big family. But honestly, making such overhaul of such a system using the extension capabilities was quite a challenge. And features after features, it became very hard to maintain. So I made a decision recently, and I'm really happy to share it with you today. But it's the birth of a new project, a project called V-Shell. V-Shell is a standalone Wayland compositor tailored for the material shell workflow. It will be powered by Flutter with Rust compositor. It will allow us to unlock the full potential of the workflow, because currently it works mainly on monkey patch of GNOME shell, which unfortunately lead to some issues in stability. It will also allow us to provide a first-class development experience for our contributors, because right now, working on compositors is not the best experience you could have. And thanks to Flutter hot reloading and also because of the Rust experience, it will allow us to provide a much better experience. But also, we have plans for more features that we are currently able to provide, notably a first-class support of ultra-wide monitors, because those monitors are more and more popular, and using floating Windows Manager in them, in my opinion, is not the best idea. And I have planned I have good plans for them. It will also, in material shell, we do love material design, obviously, and with the Flutter material toolkit, it will allow us to provide the best, again, the best experience possible in terms of material design, notably because currently all the widgets are homemade using an old technology for GNOME. So it will also allow us to provide a secondary workflow called the ephemeral workflow, because one of the drawbacks of material shell and its persistency is that when you want to open an application which, sorry, okay, it's maybe a bit loud now. So one of the drawbacks, I said, with the persistency, is when you want to use an application for only a quick time, like open the settings to tweak the volume or anything, having it to persist is not what you really want. So in order to fix that, I think the best way to do it is to introduce a secondary workflow used by different inputs. And currently it was very difficult to do with GNOME shell, and having the capability to do things in our own will allow us to do much more, like providing workspace for external monitors, something that a lot of people are asking us to implement, but it's not possible in GNOME shell, in GNOME. And hopefully, I hope, it will also provide us easier maintenance, because we will have to handle only our code base. So in order for the success of this project, obviously, I need some support, either by providing contribution directly to the project available on GitHub. I would like to thank Alex Roshka, which is a student that spent a whole year working on the prototype that we are based on V-Shell. And I will also offer a way to help me spend more time on this project. We created an open collective where you can sponsor the project and my time working on it. So, yeah, I think I'm the first one really in advance this morning because I already finished my presentation, but I guess we have time for questions if you have some. Thank you.
Over there, and you go there. This is where the morning run was helpful.
Thank you. First of all, fantastic work. This feels sort of like you designed a desktop environment specifically for how I use my computer. So good job to you and the team. Could you elaborate a little bit more on what your thoughts are on like how you're thinking about designing the multi-monitor support for this?
The multi-monitor, the idea is to provide different use cases, different possibilities, notably by the work that we want to make on the ultra-wide monitor support. It's to be able to divide monitors in different virtual screens and to be able to choose if these screens behave like a standalone screen or if you want to have workspace on them or if you want to have spread workspace for all of that. So you can customize in virtual screen by virtual screen, so either a full monitor or either a splitted large ultra-wide monitor. Not sure if it answers your question.
That's perfect, thank you. I'm looking forward to it.
Thank you.
Very cool. One question is regarding the Flutter and Rust underlying software. Are you going to be producing your own settings applications, or will you be using like GNOME or some other components for that?
There are different projects aiming at providing some already awesome application for tweaking your systems. Also in Flutters, for example, Dahlia OS, or I know there are other projects working on Flutter applications. I want to be compatible with external application because I want to have the less work to. I want to be focused first in our mission, which is the workflow experience. But I think for some settings, we will be forced to make our own application, like for the display settings and such. I don't know the full list yet, but maybe also inputs to manage your keyboard or mouse. So we may be forced to make the settings apps, for example, and I will try to contribute with other projects for that.
Thank you. I'd be interested in that.
Thanks.
Over here. And so, like,
Sorry.
first of all, this is loud. Great idea. I love the intuition of the space and like having these virtual rooms that you can move around like an RPG character. That's what I in my head. Like I've tried similar, like not in the context of a desktop, of course, but whenever there is spatial movement and like having to remember, having to know where the rooms are and having to navigate these kind of virtual spaces, I often have the problem that I forget where I am at the beginning when I'm learning to use the system or when I'm learning, how the layout of the house is. And I find that frustrating, and so often I drop out.
Sorry.
Like what I think really helps in those situations is to have like a minimap or some sort of feature to help you learn the layout. And I was thinking, do you have something like that feature or?
Yeah, like I said, the interface itself is like your minimap because as you can see, there is some indicators in the panels. Maybe you don't see them properly because it's a bit washed off, but you have some indicator, and it's funny that you talk about video game because we got inspired by them to provide dedicated shortcuts that allow me to navigate using a single hand, which allow me to keep my right on my mouse. But if first, since it's a persistent environment, since everything will stay in place, and you are supposed to be the one configuring it, you will retrieve what you have left. So it will help you to find things back. And the indicators and the icon on both panels are supposed to be the minimap you wanted to have.
Yeah, so like I see the one on top. That
Yeah,
is
there is a blue line
windows.
on the side panel, but maybe cropped. I think it's cropped.
But where is the vertical dimension?
There is one, trust me.
Okay.
There is a blue one. I think it's cut off by the side of the screen.
Looks like a follow-on discussion there, so that you can see a full demo on the screen.
Are you building on top of an existing Rust Wayland compositor, or are you building a new one?
So our plan, obviously, is to use some Wayland toolkit. The first prototype was based on wroots. The new one is based on Smithy, a toolkit built in Rust. But we could also use Mir, for example. We are currently at the prototype phase. Our contributors wanted to work on Rust, so we tried to use Smithy. But our goal was to provide a proof of concept of how Flutter could work as a renderer with Wayland compositor in the back. So for the Wayland part, we can use any toolkit. But in the end, we want to make it. We want to provide our own features, because we want to provide some features that doesn't exist anywhere else. So we can't just take an existing window manager, and also because our needs is pretty small, because since it's a very simple window workflow, we don't need to have such complex features that are provided by other window manager, and keeping it small will help us to provide and to maintain it, obviously.
Thank you.
Any last question?
So I think like traditional tiling window managers often have a data type like a tree. So like you have a tree and each node can contain other nodes, and so you can model windows in that way. So for example, i3 allows you to create these kind of like shell-like structures. Your data structure, underlying data structure seems to be a list of lists. Did you consider using a different data type, or is there something maybe I'm not understanding about that?
Currently, we do have different layouts possible. For example, you have the split layout where you can navigate side by side, and we have also the layout you used to see using tiling window manager. But I'm not sure I want to implement them. This one, for example, with V-shell. Maybe I will, maybe we won't, just because it doesn't really follow the workflow ideology, because it breaks a bit the grid vision. The split layout is perfect, but we have to. If it won't be so difficult to add if it's needed, but it seems that most of the material shell users currently, the ones that are fighting against the crash and the bugs, and they're still here today. They're mostly interested in the main workflow, the main ideology. The one looking for a tiling window manager, you usually find better experience elsewhere. If you want tiling window manager, there is plenty of them already. But implementing a layout similar, it won't be such a big deal.
Awesome. Well, thanks a lot, Adrian.
Thank you very much. I would like to thank, Canonical, obviously, and the Ubuntu community for their warm welcoming. Thank you very much.
Next presentation in 3 minutes, as you can see. Hello. Okay. So.
On my knees, I clutch my
Right, we're going to get started in a few seconds. If you want to get sitting, yeah, there's someone who's interested in the presentation who's just running back in. Brilliant. So for no on the official presentation, it's just Jamie, but for the price of one, we have two people, Jamie and Felipe, on stage today. The floor is yours.
Right. Thank you. So my name is Jaime. This is my colleague Felipe. We are engineers at OmniVector. And today we're going to be talking about HPC with containers on Ubuntu. This is the agenda for today. Basically, we want to give some introduction to containers and how we can use them on HPC environments. We want to show a small example on how to use them. And I would like to highlight that this is part of the initiative to expand Ubuntu's adoption on HPC environments. As you might know, traditionally, HPC clusters are deployed on enterprise Linux, like CentOS, for example. We have a lack of support from some applications to run on Ubuntu. I believe it's also because of that. And I would like to mention that I'm part of the Ubuntu's HPC team, and we've been doing a lot of effort to stimulate the use of Ubuntu also for HPC. Oh, and just a quick reminder, tomorrow we have a talk, we have a panel, and we are going to discuss things related to Ubuntu, HPC, and how we can improve it. So please attend to that tomorrow also. Okay, for this presentation we have some key technologies. First, we have Slurm. I don't know if you have heard about Slurm yet, but it's basically an open source cluster management and job scheduling system for Linux. With Slurm, you can Slurm takes care of the job scheduling and resource allocation in the cluster. There are other similar tools for that, like PBS, LSF, but Slurm is the most used one in supercomputers. Of course, we have containers. This talk is about containers. Containers are lightweight, portable, and self-sufficient units that encapsulates everything you need to run your job. Basically, you have a whole operating system, you have your applications, and all dependencies the application needs. Of course, we have Ubuntu, right? This is the Ubuntu Summit. We're here to talk about it also. And Ubuntu is a key, it has a key role in this presentation because we want to stimulate the use of Ubuntu, right? So we can either use Ubuntu as the host system or the container system for this. And we have another tool. It's called Vantage. Basically, it is a workbench that enables us to create clusters on either on-premise or on cloud. It creates cloud-based clusters. And with Vantage, we can easily submit jobs using the web browser, for example. I would like to mention something. It's not in this presentation, but it's the Slurm charms. I'm one of the maintainers of the Slurm charms. This is also from the HPC team. You can check it out in the charmed HPC organization. We have a lot of Slurm charms, so you can easily deploy your Slurm cluster on your local machine with LXD or in any cloud you have, AWS, vSphere, MES, and so on. For this presentation, we are going to be using Vantage just to show a quick example on how to create a cluster locally, a demo cluster locally, and start testing your applications with containers. So you might know the benefits of containers. Containers have been around for a long time now. It is widely used, especially in cloud environments, to pack and deploy applications. But HPC can also benefit from them. So we have lots of good things with containers. The first one, I'd say, it's isolation. So containers can provide everything you need to run your application on a single software unit, for example. Especially in HPC clusters, this is a good thing because usually we have lots of users, lots of different applications. It's hard to maintain this. Usually we have modules. So for each of the applications and its dependencies, we need to create specific modules for those. And we can create, I'd say, lean clusters. So we can use containers just to run each application, and everything that application needs is inside the container and isolated. It won't conflict with the host. It won't conflict with other containers. Also, we have portability. This is really important because we can easily reproduce the simulations, for example. We can run a single image on any system you have, either a cloud or a HPC cluster. So it's easy to replicate your setup in different environments. Scalability. In a cluster, we have, like I said, lots of users. It's a multi-user environment. So we must be able to easily meet those demands because we have lots of users submitting distributed jobs that require a lot of computational power. So containers can easily be used in such environment because they scale. And efficiency. So it's good to have all of this I just mentioned, but we cannot have performance loss. So with containers, we can achieve performance close to the. Basically, we have the same performance as bare metal because, like I mentioned, they are lightweight. So we heard about the benefits of containers. Now I want to talk a little bit about a few containers technologies. So I have a few here, specific design for HPC environments. You might wonder, where is Docker in all of this? Yeah, unfortunately, Docker is not suitable for HPC environments because Docker has some privilege escalation issues. So here we are on an environment with lots of users, and traditionally, Docker has not been a good choice for such environments. But we have a lot of options, right? Starting from Singularity/Aptainer. Basically, initially we had Singularity. It's a project from Scilabs. But eventually, this project was split in two. So today we have Singularity CE from Community Edition. That one is hosted by Scilabs. Both of them are open source, right? Just Singularity Community Edition and Aptenia. They are open source, but they are different branches now. So Singularity Community Edition is sponsored by Scilabs, and Aptenia is hosted by Linux Foundation. But they have the same proposal. They are still compatible, so we can either use one or another. They are basically the same, right? And they are meant to easy of use on HPC environments. So they work really well with the workload manager. They work really well with Slurm, with distributed file systems, and all of those things we have on HPC clusters. Next, we have Ceros. It has the same proposal. So it's an OCI-compatible container engine for HPC. All of them are OCI-compatible. OCI stands for Open Container Initiative. Yeah. So it's basically defined some standards on how to run container images. So we can have a single image. It could be a Docker image, for example, and you can run on different container runtimes with no problem, because they define the specs and the standards for it. And all of those can easily run Docker images if you want to. Charlie Cloud is another option you have. I haven't used it yet, but it has the same proposal as the other ones. And it's worth mentioning that all of them intend to run unprivileged containers. So basically, the user inside the container is the same user from the host, which is not true for Docker. For example, I can run root on Docker and be just a regular user in the host. And that's why the escalation, the privilege escalation issues comes. But they has this idea of unprivileged execution. And last but not least, we have Enroute and Pixis. Those both are from NVIDIA. So Enroute, it's a tool to basically get a Docker image and turns that image into a sandbox to run in the cluster. And Pixis is a little bit different from the other ones because Pixis is a Slurm plugin for containers. It runs on top of Enroute, so it has Enroute as an underlying tool. And basically, it will create more Slurm, more options that you can use in your job script. Okay, these are just a few examples. Of course, there are more. Including for Docker, there are some projects to run rootless Docker. So I recommend you to take a look at this documentation from Slurm. It has a whole list of containers, container types that Slurm supports, how you can install them, links for the specific documentations, how you can configure them to use with Slurm. Nowadays, we have this option on Slurm -- container where you can configure. You have a specific file oci.conf, and you can configure each one of those containers to call them and run them directly on your job script. But you can also, with specific commands from each one of those technologies, you can run them inside the job. In the example, we're going to have a quick demo. We're going to use the simplest way, which is using the comments from Singularity in the example. But you can also check it out for more options in the Slurm documentation. Okay, so what about workloads? I mean, we have a lot of workloads. So a wide range of workloads from academia to industry run on HPC clusters, right? Applications from different fields. We can say, for example, energy, things like fluid dynamics, finite difference, finite elements, industries like oil and gas exploration. A lot of those applications needs computational power to run. Also, aerospace, automotive engineering, medical, pharmaceutical, of course, AI, everything today is about AI, right? And to train neural network for deep learning, we need computational power. So the list just goes on. And those applications can also benefit from containers, especially when they have complex workflows. So containers can make someone's life a lot easier, right? All right, so now I'm gonna let Felipe talk. He's gonna give us some, he's gonna show us how to use Vantage to create a demo cluster and submit a job. Right? Felipe?
Thank you, Jaime, for this overview. I'm taking over to present a quick demo here. Starting with the Vantage platform for HPC, we've chosen it because it's the project our team has been working on, and also we have the chance to provide some practical experience for anyone interested and want to talk more details with us after this talk. It's an HPC platform that can combine both cloud and on-prem clusters in a single user interface. We can use a web interface to interact with it. And yeah, it all starts with the sign in this page. Also inside, we have this cluster section where we can, of course, add both cloud and on-prem clusters, but the main goal here in the demo is that we can prepare a demo cluster. So this we spin up on our local system, and the platform can connect it with it. We can launch a few jobs and play with the system. When we click there on prepare cluster, we get this script. We can copy and paste on our local terminal. It has a helper script that uses multipass to start a virtual machine. Then we use Cloud init to install all the dependencies the cluster needs, like Slurm itself, Slurm DBD, Slurm RISC-V, to allow us to use remote job submissions, and so on. All right, with the cluster in place, we can change to the jobs section. I have to say, under the hood here, we run an open source called JobBrigade that I happen to be the core maintainer. It's available on GitHub, and I'm happy to talk about it after this call as well. We can start creating the job script. We provide a name and a description, so we can search, we can share, and we can reuse the resources, and also share with team members. And finally, we have the chance to drag and drop the script file itself there, so it will be available for submission. The file we are using in this demo is this bash script. As you can see, we can set some bash parameters up there to control how Slurm will treat and allocate resources for this job. that on line 11, we are building the singular image file from Docker. We have some logic to cache it locally, so we don't need to build it every time we run the job. We can reuse it if it's available on the file system. And on line 16, we use singular exec, so that command, hello world, will run inside the container effectively. Just for demonstration, we are using the base Ubuntu image, but of course, the great goal here is that each application can build custom layers on top of the base image and take advantage of the containers. That's the main goal. All right, with the job script in place, we can submit it to the cluster. Again, we can provide some metadata for the submission, like a custom name, description. We choose the demo cluster that we just spin up on our machine, the execution directory, and a few other things. So we can remote submit it and execute on our cluster. And yeah, finally the submission is done. We can see here the status is created. It will eventually be processed by the system, be submitted. Job aggregate will use Slurm RISC-V to submit to Slurm, so the status will change to submitted. We'll have a Slurm job ID, so we can keep track of this as well. And it will be queued on Slurm. We'll eventually run and complete. We can keep track of the status in the entire process here. And yeah, that's what we can do with Vantage using containers. So to summarize our talk so far, containers enable an efficient, easily and maintainable, scalable workflows on HPC clusters. That's the ultimate goal. Many alternatives are available on HPC ecosystem to integrate with Slurm, as we have seen. And yeah, we demonstrate a user case using Vantage and all the technologies we discussed. Thank you very much for your attention. I think we have some time to take any questions.
Any questions?
So I guess maybe not HPC specific real quick, but I just wanted to know, did you use like Canva to make these slides? Because they look really good, so.
Oh, it's beautiful AI.
Oh, really?
It's a nice tool, yeah.
Oh, sweet, cool.
AI is taking over everything, right?
All right, but yeah, so thank you for giving the presentation. I know that we, see each other pretty much every week, but one thing I kind of wanted to know is with Vantage specifically and like JavaScript, the HPC work that we've done on Slurm, are you kind of looking into using, say, like Slurm's SC run utility that it has for running OCI images? Is that something you're looking to like enable? So there's kind of more seamless container integration, or you could maybe argue like, okay, you don't have to kind of have analysis paralysis where you're looking at all these separate container runtimes and you can just, pick SC run because it does the job.
Yeah. That's like, we would like to be agnostic in terms of container technology specifics. For this, we just like to give an overview and open the discussion. Which should be the best option, I'd say the simple answer is whichever suits you better. And in our case, for example, for the Slurm charms, we started talking about it, thinking about it. So I'd say this presentation is just the kickoff. So from now on, we can start discussing it. We should for sure test all of those, see the pros and cons of each one of those, and maybe provide at least one of those by default in our Slurm charms or in the demo cluster or in any other way anyone here uses to deploy a Slurm cluster. Yeah. I'm not sure if I answered you.
No, that was great. Thank you.
Okay, thank you.
Any other questions? Was everyone dying for the group picture? And,
Yeah.
keeping your cool for the good for the team group leader.
I'll ask another question. So in Vantage, when you're like provisioning the clusters, are you using Juju in the backend to set it up, or are you using kind of some other provisioner? Because I guess that was one thing that I was a little curious about, because I think it's cool if like, you know, you kind of have that front end that kind of provides a on Rails like experience for Juju, and more or less like the operator sees it, but you know, the user who's setting up the workflows isn't.
Yes, I see. For the demo cluster, specifically, we are not using Juju, just multipass. So basically, we create a VM and install all Slurm services into that VM just for a small test. But for Vantage, we can also deploy it, not deploy it, but we can have already our cluster deployed with Juju, for example. And we have cases where we have deployed a considerably large cluster with Juju and using the Slurm charms. And we have an agent running in there connected to Vantage, for example. So Vantage enables us to either create our own cluster, demo cluster, or use one on-premise cluster. Yeah. But for the demo cluster, it's just multipass.
Yeah, it makes sense.
Yeah.
Brilliant, Jamie, Felipe, it was great. Thanks a lot for the chat. Oh, one more question.
Yeah, thank you so much for the talk. My question would be, how responsive is this Vantage thing? So, for instance, can I drop a bunch of tasks and perform it almost real time, or it's really for some batch work in the background? Thank you.
Yeah, it's very responsive. As James said, we have an agent running on the cluster, so all it takes is the agent to do one cycle and pull the pending jobs, submit, and keep track, keep feeding back with updating stats. Yeah.
Hey, it's just an addition. You can check it later. You can sign up to it, create your demo cluster. Just like I said, you just need a multipass on your system. It will generate the script. You're going to run the script, and you can test it and let us know if you have any questions. After that, please reach out to us. Yeah.
Brilliant. I think we're on time, and there must be gazillion people like queuing out there for the picture. So brilliant. Thanks a lot. Big round of applause. And I'm sure you'll be available for demos out there if anyone wants. Perfect. So I'm going to ask everyone not to leave, because we're going to do the pictures now. So if you could stay in the room. I know it's hard. There's coffee and tea and the good smell of it and so on and so forth. If you could all stay in the room just so that we can get started with the picture. And are you going to come on stage? Or do you want to wait for 1 minute or two? That's what I was waiting for. So we're all climbing on top of this. Where's the picture taken from? No one can stand on the stage.
So you don't see a yellow forklift in most events that you go to, especially not for a group photo. So as we fill up, I just want to introduce myself. My name is Ahmed. I'm part of Canonical's communications team. As we get ready for our upcoming group photo, I want to mention a couple of things first. So we've been here now together for like what, a day and a half. One of the things that I want to highlight is the quality of the speakers that we've had, the amazing conversations that we as a team and as attendees have been having. I think a second thing I want to point out before we proceed with this is there's there's a powerful force here present with us, which is the people around you that are making you look good. There's the lovely stream that's happening and attendees online. There's the amazing photography and videography team. I think you see them right there. And we have, okay guys, part of the videography and photography team, can you raise your hands? That's one. Over there. And there we go. So all of these people are working to make everyone look really, really good. I would just like us to put our hands together and give them a round of applause because they are. So thank you so much for your professionalism, your creativity, and for making this summit look amazing and capturing some really, really, amazing times together. I want to remind you as well one last thing, seeing as we have 1 more minute before this room fills up. If you are an avid user of social media, Canonical/Ubuntu has presence on all major social media platforms. So feel free to use hashtag Ubuntu Summit or Ubuntu Summit 2023 as per the email. We're on Mastodon, X/Twitter, Facebook, Instagram, YouTube, LinkedIn, and many more, including Instagram. So I think we are starting to fill up. If we can, this is where the camera is going to be. So we are going to queue up around here. Some of these chairs, we'll start pushing them. And once we are in position, we will start asking you to do certain poses. Is that okay with everyone in attendance? I think it's a good time to start. So we only want to push the chairs in the front. If you're not in the front yet, just make way as we push them. We are going to be almost 200, 300 people standing here. I will say this, it is advisable, highly advisable, not to stand on the stage. As you can imagine, a large number over this kind of surface area is not ideal. So everyone helping move the chairs, thank you so much for your contribution. Just want to move a bit there because we want to stand here. Here we're facing the wooden walls. Let me see if I can. Guys, if we can continue moving inwards here, we don't have to bunch up at the first exit you see. There's exits everywhere. There's no risk of us being trapped. Guys, one last reminder, we cannot stand on the stage during the photo due to the large number of lovely people around here. Once again, thanks to everyone for your cooperation, contribution, and your patience. We are almost at a full house, and look at the amazing variety. I see some people standing behind the stage rather than on top of it, so smart thinking over there. I see Michael. Okay, we're waiting for Mark. But don't worry, there's 100 pictures being taken right now. So if you would like to just wait a moment, we would be very grateful for your patience. Yeah, guys, we're gonna be getting a couple of shots. We'll take one when Mark arrives and a couple as well. So we're going to start posing. I think these are special poses. This is the Ubuntu Summit. This is the open source community. So we do things a little differently over here. If you were here last year, then you know what this is about. I'm also posing with you. So do you know what was the last or most recent desktop edition code name was? Minotaur, really good. So for the Minotaur, we're going to pose like we were going down into the labyrinth to face the Minotaur. So pose like you're a brave warrior descending into the labyrinth. Okay, we're gonna start doing now. Mentally prepare your poses. How would that look like? If you're a brave warrior preparing into your adventure, would you be holding up a sword? Would you be proud? How would it look like? A laptop helps. Thank you, Philip. Okay, so let's try this, right? 3, 2, 1, and on go we strike the pose, and we get our first picture. Are you guys ready? So 3, 2, 1, go. One more. Oh no, we're not halfway done. Actually, we are. So the second one, the horns of the Minotaur. Can you do the horns of the Minotaur? However you... Beautiful. Okay, I see a lot of Minotaurs in the crowd. Okay, 3, 2, 1. Okay, so okay, as we said, there's like one more pose we'd like you to do. What is the last LTS version that has been released by Ubuntu? So for this pose, take it easy, want you to jam out and just be chill with it, right? We've been sitting in like constricted positions, our muscles are tightening. There's uric acid, I think, that goes into muscles everywhere now. So just be chill, loosen up, right? Just like a jellyfish. And here's what's different. At the count of like go, we would like to all together just yell out jammy jellyfish. Does that sound good? Thank you for your cooperation. So 3, 2, 1, go. Jammy jellyfish! Woo! Mark has arrived. Woo! Okay, so for this last one, we want to celebrate that we're finally taking the photo and that we're all here. So express your enthusiasm, raise your hands in the air at the count of go, all right? So are you ready? 3, 2, 1, go! Woo! Woo-hoo-hoo! Ow! Thank you guys, this was amazing! Give a round of applause to yourself and big round of applause as well to the photographers, videographer team, and to your aching muscles. You can go out now, get a drink, stay hydrated, and thank you so much. We'll see you in a short while. Have a lovely rest of the summit for day 2. Next session is 11:30, so be here or be in your respective sessions in the different tracks. Thank you so much, guys.
Awesome job. right. We're going to get started. So if you see anyone who's just out there waiting, time to get in. And now probably the reason why our YouTube channel has been banned overnight. So maybe it's going to be banned again today. Randy, do you want to come on stage?
Yes.
Just mention it. No, this is all legal material here?
Yes, it's all legal material. Sorry about that. Got killed. I understand it's back up now. I won't be showing any shorts today, and my presentation is going to be a little bit shorter today, so hopefully all copacetic. Let me go ahead and get started. So I'm Randy Packer. I am a senior manager at DreamWorks, and I want to thank you for coming to this talk on the RISC computation framework. I mentioned this in my talk yesterday. This presentation was supposed to be actually a colleague of mine, Mark, who unfortunately couldn't make it, so I'm going to give it. I'm not exactly as well advanced as he is on RISC, but I am pretty comfortable with it, so I'm happy to be talking with you today. So RISC, by the way, I'll just mention, is part of the technology that we open sourced with Moonray, and is available at openmoonray.org. All right, so I want to take the opportunity to acquaint you with the amount of compute or rendering that goes into making an animated film. First, I'm going to change my glasses so I can read. Along with the artist's hours. So this level of compute and complexity that we face poses some challenges that we address explicitly with RISC. And let's briefly touch on what it means to render ray-traced images. So modern ray-traced rendering can take many hours to complete for a single frame. Adding more power to this issue means faster images, and thus the opportunity for more artistic iterations. And with a very scalable renderer like Moonray in combination with RISC, we can grab more cores and therefore get faster renders back. So what is our challenge? Essentially is how do we get more cores than are available on a single workstation so that we can render faster? And of course the answer is with RISC. What exactly is RISC? First of all, it stands for Animation and Rendering as a Service. So I mentioned that this is not the Moonray computational framework. This is the RISC computational framework. So we use it to run a variety of computations, rendering of which is one of them, animation is another. In terms of scalability, we've used RISC on hundreds of machines and thousands of cores. We've integrated into a number of the most prominent digital content creation tools, or DCCs for short, like Maya and Katana and Houdini, etc. And it's a bit like having a 1,500 core workstation in your hands. Awesome power. So let's get into it. Let's start first without RISC, where the user has a DCC, like Maya or Katana, and a renderer happening on a single box. In this example, with 36 cores available and shared, there are 36 cores available and shared between the DCC and the renderer. I don't know if that clicked through. Okay. Now when using RISC, each client application makes use of it through a client library. To obtain a rendering session, the client makes an HTTP request to the coordinator service, which then tries to allocate available resources in the RISC pool. If allocation is successful, the coordinator responds with a network address of one of the nodes allocated to the session, called the entry node, and from that point on, the client only talks to the entry node, which communicates with all other nodes allocated to that particular session. This makes RISC scalable to the total number of active sessions. And notice that with RISC plus 3 render computations, we increase the render speed by 3x. Multiple RISC clients can connect to the RISC core services and use nodes in the available RISC pool. And any given single RISC node can run multiple computations for the same or different clients. Here's another illustration of the power of ARIS to show the speed gain. And I want to note that this is definitely not a logical diagram of coordination and communication between the nodes, but simply very naively demonstrating the speed gains that we achieve. Local in this case means that there is a local ARIS session running on the same box, and there are 36 cores shared between the DCC and Moonray. In this example, the image takes about 5 minutes to render. However, crank up an ARIS session, grab 12 hosts with 36 cores each, and you get to 432 cores. The merge and distribution is done on the local box, and in this example, rendering the image takes less than a second. In fact, it's a little bit closer to half a second. Let's talk about the need for ARIS in a little bit more detail, or how we use it at DreamWorks. So an artist works on keyframes, and as they make adjustments, they quickly see their results as they rapidly iterate, thus saving the artist time, which translates into a higher quality overall for the movie. Walk-bys are when a CG or a VFX supervisor literally walks by an artist's workstation to see a shot or make a suggestion. At that point, artists can grab more nodes from ARIS so they can iterate even more quickly when pairing up with supervisors. I'd like to call this pair painting, but nobody at DreamWorks calls it that. That's just me. It's common for artists, particularly leads, to have multiple instances of the same application running. An artist may run 2 or even 3 Maya sessions at the same time so that they can play and experiment with different versions of the same frame. In the past, they may sometimes ask for a second, expensive workstation to run the applications. ARIS can save that effort by moving the rendering off of the artist box and saving considerable resources. In this example, a single artist has 2 instances of a DCC running, each with its own ARIS session, and thus rendering 2 different scenes. This avoids the common need for artists to launch applications multiple times and switch back and forth. In this final workflow, we're going to look at multi-context rendering with ARIS. And with this workflow, the artist can see the effect of every edit on multiple lighting setups or multiple shots in a sequence. I'm going to show a few demos here. This next one, if you were at the Moonray session yesterday, I also showed. And in this video, we're showing asset development under multiple lighting conditions in a single session using ARIS. So it can take several seconds to transfer the scene and asset data to the back end and distribute to the nodes. However, once we get going, we get fast delta updates as we pan the camera around and we change radiance values. And the artist can see and manipulate the asset under 4 lighting conditions at once. Daylight, in this example, it's daylight, overcast, dusk, and night, to ensure that the asset, the van, looks good under all lighting conditions. So to further illustrate that, the user wants to see 4 live renders, but their machine doesn't have the compute power to do that. Using ARIS, they can offload the work to multiple pull machines, making the workflow possible. So let's show some more examples. In this first example, we're going to see the artist in a lighting session with just Moonray and not connected to ARIS. There are 95 virtual cores shared between the lighting tool and the Moonray renderer, and the artist is manipulating light position and radiance values in the scene. So this is 1 renderer, 1 session, 95 virtual cores. In this second example, the artist is now connected to the ARIS pool and is running 1 context, in other words, 1 frame, being served by 11 render computations with a total of 1,045 virtual cores for rendering. The artist is again manipulating light position and radiance values in the scene, and this is obviously quite much faster. So 1 context, 11 computations, 1,045 virtual cores. In this third example, the artist is again connected to the ARIS pool, but this time is running 6 contexts, in this case 6 viewpoints of the same frame, with each context being served by 2 render computations for a total of 1,140 virtual cores for rendering. The artist, again, is manipulating camera position, material properties, and light radiance values on all as well as some of the contexts. So 6 contexts, 2 computations per context, 1,140 virtual cores. We've developed and run Eris as a local cloud service and ran it on major cloud providers as needed to punch through our on-prem capacity in order to meet key deliverables. In order to minimize packet size and reduce latency to the cloud, we do a couple of key items. 1, we use a highly delta-encoded codec that we developed called progressive frame message. And 2, we process a partial image at each user-defined frame per second rather than processing the entire image at once. The messaging protocols are also designed so that higher message latencies cause greater delay between making a change and seeing the result, but don't result in a breakdown of the system, which would occur if they had not been designed to be fully asynchronous. Eris can receive notifications from the cloud provider that a node will shortly be withdrawn from our allocation, in other words, a spot interruption, which can happen in lower cost cloud plans. Eris will then shut off the affected node and shut it down gracefully and can checkpoint the frame in progress to be resumed later rather than waiting for a node to fail. We've tested our scale up to 6,000 cores, and we saw linear speed up with the increased core count in all of our tests. In this 4th example, the artist is connected to an off-prem Paris pool running in the cloud, running 9 contexts in the Azure US West region. Each context is rendering a different shot or a different frame within the same film sequence. And each context is being served by 11 render computations for a total of 6,237 virtual cores for rendering. The artist is manipulating the environment light of the sequence and the light radiance values. Again, 9 Oregon contexts, 11 renders per context, 6,237 cores. As we've shown, Moonray multi-machine rendering with Eris is powerful and scalable. In our pursuit of better efficiency, optimization is very important for us. However, it can be difficult to find bottlenecks in multi-machine environments, and it's also hard to simply debug parallelized multi-machine rendering. To ease that burden, we provide a few solutions. InfoCodec, which we developed, provides a mechanism of sending string-based information between nodes in a heavily delta-encoded way, and this minimizes packet size and latency. Shared memory footmark provides a solution to save the structured string-based information to the shared memory in order to keep the runtime debug information from unexpected segmentation faults with minimum runtime timing overhead. And the telemetry overlay provides a real-time visualization of the progress of distributed rendering, along with key information on network I/O and CPU memory utilization to make it easy to see what's happening on different machines. And I'm going to demo that right now. So here, at first, we see that the client, Pearl Diva on the left, is locally reading in the data from a large scene called ALAB, open source by Animal Logic. And this scene data is 2.6 gigabytes, quite large. Then the client starts sending the locally read data to a dispatch node called Teal Pond. We speed up the video 4 times as the data transfer can take some time. Now that the client has finished sending the data to the dispatch node, and therefore the dispatcher starts sending data to each of the MCRT nodes, of which there are 4 on the right, as seen on the right. Note that 3 of the nodes are receiving the data very fast. However, one of the nodes, the second one from the top, Ruby Minute, is on much older hardware and is receiving the data quite a bit slower. The blue graph indicates 1 gigabyte per second speed, and the gray graph indicates 100 megabytes per second, so 10x slower. Again, we speed up the video 8x, as the video data transfer can take some time. And now that the data has been fully dispatched to each node, and each node is doing the render prep stage, which comes before casting rays into the scene. This stage involves reading the scene data, tessellating the geometry, and constructing the BVH, which is a tree structure of all the geometry in memory. After finishing the render prep, we start immediately sending the image back to the client. I think I'm a little bit ahead. There we go. And we are now in the MCRT phase of tracing rays. It starts off noisy and refines as more samples are returned and pixels are converged. During this MCRT phase, the gray bar is showing very heavy texture accessing on disk. Each node requires 100 gigabytes of texture cache for this size of a scene. Again, we speed the video up by 4x to move it along a little bit. And I want to note that we've implemented what we call multiplex pixel sampling here so that we are not dependent on all nodes performing well or even being up. Whoops, I don't want to go there. I wanted to stop that. Let me get back to this. The multiplex pixel sampling, we're not dependent on all nodes performing well or even being up in order to complete the image. If a node or a nodes goes down, the picture will still resolve, but at a slower pace, as the remaining nodes will need to take up the extra samples to be calculated. Because of this strategy, we do not see a checkerboard effect that would happen if we sent specific tiles to nodes. Let's see if I can pause it. Oh, it's going to come here in a second. Pause it there. So we have several different telemetry overlay panels already, and more are going to be added in the future. Here you see another panel, and this one is a view of the core utilization per node. And you got a little bit of a preview, but that is my presentation. I'd like to thank you for your time today and allowing me to show a few of the key advantages and utilities that demonstrate the scale and the power of the ARISC computational framework and how we use that, in our case, to accelerate our rendering and create new workflows for animated feature film production. And we're excited to see how others in the community can leverage this kind of computational framework for even greater things. Thank you very much. Thanks, Canonical.
Any questions for Randy? Put your hand up.
I will do my best to answer the questions, but as I took this over from my colleague, softballs are always appreciated.
Hello, thank you for this. My question is in terms of workflow. You showed the demos that you showed. From what I understood, they are about an artist actually developing a frame and seeing what's best, etc.
Yes.
And that is using ARISC. Do you also use ARISC for the final render?
Yes, we have used ARISC for the final render to basically scale up the speed to get frames back. I'll give you a clear example. We have to render posters for our movies, and we had a poster. I think it took about 6 hours to render. And the marketing team decided it needed a little change, and they needed to do it fast, so they threw it up to ARISC and got it back in an hour. I think they just scaled up the machines by 3x.
Hello. My question is whether the individual nodes communicate between them to know which pixels to render. Is that how you don't end up with like unrendered pieces in the image if some node is down?
I don't believe that the nodes communicate to each other in that way. I think the dispatcher sends it back off. And if it's not receiving the samples, or if a node it doesn't hear from it, it just distributes the samples again elsewhere.
Thank you.
Mm-hmm.
More questions anywhere?
I do want to know that we use the ARISC computational framework not just for rendering, but also for animation, and it was developed originally to handle any kind of computation. So it's a pretty beefy system.
Hello, and you obviously have your server farm, and you are using cloud services as well. What is the percentage of the job you can do on your own server farm, and when you have to resolve to cloud services?
As much as possible, we do it on-prem. So we have 50,000 cores on-prem, and we have a number of, at any given time, we have about 4 productions in progress, and they somewhat stack each other over the course of the production. A single production takes about 4 years to complete. You know, if there's some massive push maybe for a trailer to get done and we don't have the capacity because the farm's already fully utilized with all the other productions, that's when we go into the cloud.
Hi, me again. Is there some sort of quota mechanism to avoid one developer from taking over all the cores that are available? How do you control that?
I'm sorry, can you repeat?
Is there some sort of quota mechanism to avoid one workstation or one developer or one team from taking over all the cores you have?
Yes, yeah, we have a scheduler that sets the size of the pool given who it is that's actually using it. So a junior artist that just, or an intern that just comes in cannot take over our entire farm with nodes, no.
Hi. I assume when you refer to virtual cores, you refer to CPU cores. So I was asking if there is a specific reason not to use GPU for
Yes, we don't have GPUs on our farm.
Okay, thank you.
For like different capacity nodes, how does like the dispatcher measures what kind of computation workload it can send for that node to not like offset the speed of the whole render?
That's a good question to ask on our discussion forum to our engineers. I don't know the exact answer to that question. I assume that it doesn't do a whole lot of trying to guess what the capacity of the machine is. It just sends off the workload and gets it back. Whatever it gets back, it uses. Whatever it doesn't get back, it can, you know, shuffle off to other machines.
Okay. Excuse me. Is there any scrutiny related to what is chosen for the next project? Because you said it takes 4 years. Is there any scrutiny related to the technical issues of what a project might require to choose which one you pick?
The scrutiny, I believe, is really on the story, the kind of story that they want to tell. And when a project does get greenlit, then the production does go into a mode of a little bit of research and development and figure out, okay, do we have the technical tools that's going to help us achieve this look? Or do we need to develop something? Or do we actually purchase something? So there is a whole phase at the beginning of a show that actually is called look development, which is a lot of experimentation of like, okay, this is the story we want to tell, this is the look direction that we've been given, and this is the technology needs of the show. So each show could have slightly different technology needs.
Any last question? I have one. Why not purchase GPUs? Too expensive?
I'm sorry?
Why not purchase GPUs?
Why not purchase?
Yes, GPUs.
Purchase, our artist workstations do have GPUs, and Moonray itself runs as a GPU solution, so I can access and process some rays on the GPU. For the farm, our scenes are very, very large. I mentioned that you know, if for a production level scene, you have about 100 gigabytes of texture cache that you'd have to stick onto the VRAM. You have the scene itself, not just the textures, but the scene itself is about 200 gigabytes large. That level of CPU would be pretty cost prohibitive to make a movie. Maybe someday they'll get there. Everybody's excited about that, I know.
I have a question. Like, do you have some kind of caching mechanism in case some pixels do not, the values do not change after changing the light position or something, or does RISC do the computation for every pixel in every frame?
I think we send out the pixels to all the machines and get them back as they come. We do some caching, for instance, on the textures. If we're doing multiple frames, we'll try to load them up in order on the same machine, so we have hot caches going on there. Yeah. Read the scene data, get it into a hot cache for sure.
Okay, and I think it's the end of the session, except if there's any. Probably have time for one last question.
Well, these are great questions. I really appreciate it.
Soft enough?
Oh yeah, no, that was fine. That was fine. I can cover that.
Awesome. In that case, I'll let you off the stage. Thanks a lot for your presentation.
Thank you, everybody. Thank you.
And in 5 minutes, Frank will start his presentation. I think he's finished with his slides. Just about. So 5 minutes, we'll get started again. All right, we're going to get started in about 30 seconds, 1 minute. So if you want to attend this session, now it's time to either come in. If you don't want to, but there's a big mistake, you should really stay here. And I was going to say, oh, sorry, I'm totally irresponsible for talking and at the same time the music. Next on, we're going to have Frank. Frank is #1 an amazing photographer, even though he won't necessarily talk about this today. Yes, you are an amazing photographer. He's an entrepreneur, well known for Nextcloud, and he's going to talk to us about AI today. So new talents that are discovered today, Frank. Big round of applause, and let's get it started.
Thanks a lot. Thanks a lot. It's really great to be here. I really love this event, I have to say. It's really great people, great community, and it's really an honor to be here. So yeah, I will not talk about photography, indeed, but about the hot topic, which is AI, obviously, and what it means for all of us. A little bit about me. Some people might know me. I'm doing open source for 25 years. Also, all kinds of different projects. I was part of the KDE community forever, and doing other things like working with the W3C, helping a little bit with lobbying for open source at the European Commission, helping the United Nations with their open source strategy, but I'm probably invited here as the founder and CEO of Nextcloud. So I want to talk first a little bit about Nextcloud. It should not be an advertising presentation, but I think it's important for the context to just describe a little bit what it is, to give you the right setting for that. After that, I want to talk about our ethical AI framework that we developed earlier this year, then about our actual AI features, the Nextcloud Assistant, and at the end, there's this question about what this actually means to be open source in the AI world. So first, a little bit about Nextcloud. I started this whole journey long time ago when it was clear that we have a huge power concentration in the IT world, that basically just a few companies, big companies, they're storing all data, they're processing all data, they have all the communication of every human on the planet, and this is a dystopia that I don't really like. So as an open source person, I thought, okay, we need to have a decentralized alternative. We want to have an alternative to all these companies, to these features, but it should be completely open source, and you should be able to host it and run it yourself. From a positioning perspective, this looks a little bit like that. I always call the file server our grandpa. This is like from the 80s and 90s. After that came file sync and share. That's basically the idea that you can like sync your files to your phone, have a web interface, send out a share link, have versioning, encryption, and so on. But of course, nowadays, what we're really talking about is collaboration software. So that's software that is somewhere accessible on the internet, and people use it to communicate and collaborate together. So also a bit of products associated to that. Of course, file servers, Novell, Windows, Samba, and stuff like that. Then Dropbox and OneDrive. But at the end, the collaboration space is what's really personally for me also very interesting, is that we talk about Google Workspace and Microsoft 365 as the two proprietary giants here. And Nextcloud Hub, we see ourselves as the open source alternative to that. This is also why Nextcloud is structured in that way. So we have four big core products, I would say. There's the file part for file sync and share. There is Talk for chat and video conferencing. There's Groupware for mail, calendar, and contacts, and Office for editing documents together. All of that under the umbrella Nextcloud Hub. Right? And obviously the key differentiator is, as I said before, is everything we do is 100% open source and can 100% be self-hosted. So a lot of people, maybe some here in the room, run it on something like a Raspberry Pi at home. It works. I mean, I don't know if I would recommend it. It's a very weak computer, but it works. Yeah, just a few users, it's fine. But you can really scale it up in a big way. And the biggest installation that we're working with has 20 million users. So 20 million users, and it's basically the same source code, which is, I think, quite interesting. So this is a differentiator. Similar functionalities to big tech companies, but completely under your control. So this is what we do. Like now a little bit into the products. It will be quick, I promise. This is the interface for the file sync and share part. It's basically a file manager. You can upload, download your files, tag them, search them, and so on. There are mobile apps, also completely open source, for iOS and for Android. You can access all your files from the go, also with most of the features like sharing, viewing, and so on. And there's also a desktop client for Mac, Windows, and Linux that can synchronize your files between your desktop and your server works obviously great with Ubuntu, of course. Then there are some interesting features, I think, that you can define policies, who can access which file from where. So you can basically, as an administrator, you can say files that are tagged with secure can only be like viewed by people in the family LDAP group from an IP address from Europe on a Saturday from a certified device or something like that. So you can really model these interesting policies, which I think are quite interesting. Then there's, of course, end-to-end encryption. So we have a quite powerful end-to-end encryption with a public-private key system, also including sharing with other people. So basically, if the system administrator wants to, the system administrator has no way to look into your data. Also, if the server is hacked or something, there's absolutely no way that the data can leak because everything is controlled on the clients. Then a little bit about the second part, Nextcloud Talk. This is the chat and video conferencing part. It has this usual chat interface that you know from, I don't know, Slack or Microsoft Teams or something like that. Can do the usual chat operations. You can post all kinds of objects like maps and polls and documents like that. You can edit them then together. Obviously, you can do video calls. Again, we also have clients here. So we have additional separate clients for Nextcloud Talk, where you can, like a messenger, chat with your people. You get call notification if someone calls you. Basically, everything you expect from a modern communication tool. But again, everything happens on your server. No data is leaking anywhere else. Super easy to self-host. Yeah. And a new feature that we are launching, like next week, I think, is a desktop client. So we also have a dedicated desktop client. Obviously runs on Linux very nicely. The next part is the groupware part. There we have a nice calendar, also with sharing calendars with others. There we have cool features like connecting to an Exchange server. So if your organization still has an Exchange server, you can connect all of that to the existing backend if you want. There's also a mail client where you can access your mails in a similar way like Gmail, for example, or other solutions. And the fourth part is the Nextcloud Office. This is a quite nice and powerful integrated office in the browser. This is using LibreOffice in the backend, so it has very nice compatibility with all kinds of document formats. And you can also do this collaboratively in the browser, of course. We can different people with different cursors working on the same document at the same time. There's a spreadsheet application, obviously also available, also collaboratively working, and presentation application too. And something that we are really proud of specifically is that we integrated all the components very nicely together. For example, what you can do, you can have a collaborative editing session where several people working on the same document while having a video call with the people, while chatting with the people at the same time. So this is very, very nicely integrated. So to summarize it, I think we have a quite nice, or I would say the leading open source alternative to these Microsoft and Google tools. This is what we developed the last 7 years, and we are quite happy with it, and life is good, and users are happy, and everything is great. This was end of last year, and then came AI. So this is interesting for us, because to be totally honest, I think end of last year, maybe I got a little bit of a depression or something, because I thought, okay, we have these very powerful new tools now that people will like. People will use these AI tools because they help them with productivity, but there's no way the open source community can compete with that. This is something where only big tech, only Microsoft, Google, and all the others, they have the resources, they have the engineers, they have the servers, they have the training data, they have all the things that's needed. And we, as a small little open source community project, have absolutely no way to compete with that. So this is what I thought, December last year. And luckily enough, we found out that there is actually a way for the open source community to compete. I'll talk about this in a second. First, I want to talk about the ethical part of this whole AI revolution. So obviously, or for me it was directly obvious, that these AI features are very powerful and useful, right? And like the same way computers help us being more productive, right? There's like a productivity amplifier computers, and I think AI has the same way. It helps us with creating text and images and summarizing things and getting notifications about the right things and so on. So it has the opportunity, like this picture wants to illustrate, that it can be the nice helper, the nice robot, the nice assistant who helps us to make our life better. But obviously, very fast it became clear that there's also a dark side of AI. It also comes with a lot of problems. And I will talk a little bit about this in a second. So a lot of people are skeptical about the challenges of the AI, and I think rightfully so. And not only people, not only open source people like us, also other organizations. For example, if you follow the press, then you know that organizations like Samsung or Apple or Goldman Sachs or others, they're banning ChatGPT already. It's not possible to use it if you work for these companies, and many others the same. So why is that? Because they're really concerned about the problems that come with it. It comes from false information. It's like making something up. It comes with biases. And the big problem around data leakage, of course. Because we have to realize that this is like worse than normal cloud computing, right? In the normal cloud computing world, you just only give your data to someone else and trust them that they protect your data. But here you have the challenge that these companies also work with your data. So they use your data as training for the model of the future. Right? And this might then have the effect that you as a company, you're interacting with ChatGPT, for example, and you, I don't know, work on some construction plans or some documents on some strategy, I don't know. And then this data, or similar to this data, might be presented to your competitor later, because it goes into the model, it's used for training, and then it actually might end up in the hands of your competitor. So there's a whole level of privacy problems that comes with it. So then basically, beginning of the year, as Nextcloud, we had this challenge. First, if the challenge, can we do it at all? And then also, can we do it right? Can we do it in an ethical way? Because as I described earlier, the mission of Nextcloud is to give everybody control over their data, their privacy, and they can look into the source code and check in there's no backdoor in it, and so on, give you all these freedoms. And is it possible to also use the good side of AI without the negative parts? And then we thought, okay, we cannot just implement something. We really want to put this into the perspective and give our users the choice what they actually do with it. So we developed this ethical AI framework, because ethical is a big word, obviously, so what is this in the first place? So what we did, we talked with experts and looked into the press. It was not so hard. Everybody was talking about AI, about the potential problems of that. So one problem that everybody was talking about is obviously the discrimination part. Right? As you know, there's training data used going into these models, and based on that, it's giving you answers. Right? If you ask Stable Diffusion to create a photo of a doctor, it's most likely a white man. Right? So obviously there's bias in there, and with text generation, the same. And this is, of course, a problem. Second problem of the AI revolution is the CO2 footprint. And as you know, for creating these large language models, you need like a lot of power, lots of GPUs, using a lot of electricity, creating a lot of CO2 emissions. So this is a problem that we want to be aware of. We want to inform our users about what this means and what they're actually doing there. And then the next one is the privacy respecting part. As I said earlier, do I really want to send all my data to some other organization? Do I know what's happening with them? And is it used as a training data or not? So can I keep my stuff under control? In the same way, we as open source community like to keep our stuff local and on-premise and under control. Is it the same here or not? And then last point is, of course, what is the cost of that? Is this even freely available for everybody? Can also people in developing countries also use this, or they need to pay tons of money to Microsoft to use it? So is this even possible to have it really freely available? So these are like core challenges of the AI revolution that we identified. what we then did is we created this traffic light system. So we have 3 requirements, and based on how the 3 requirements are fulfilled, we give like this traffic light rating to all the different features. The first requirement for ethical AI is open source. I don't think I need to convince a lot of people here in this room why this is important, but it is, and let me explain why it is, because if the code, and with code I mean the code that's used to train a model, and also the code that's used to use a model, to interfere with it, this needs to be open source. Why is that? Because only then you can run it locally, you can look inside, and you can also optimize it over time. First of all, only then you can actually measure, for example, the electricity usage, right? Because if you use Google or Microsoft or someone else, they don't even tell you, right? It's not transparent. Only here you can actually measure it, and you can optimize it as you optimize other software too. So open source is important. Second is the model needs to be freely available. Why is this important? Because then you can run it locally. Right? Something like GPT-4 obviously is not freely available, only exists on the service of OpenAI, which is a problem, all these reasons I mentioned earlier. And if it's freely available, you can run it on your local machine. That's a good thing. And the third requirement is that the training data is freely available, because then you can actually look inside and you can check if there's a bias in there or not. And if there's a bias in the training data, you can improve it and fix it, retrain it, and then have a better model, which is more balanced and better. So from our perspective, these 3 things are requirements for an ethical AI system. And we created like this rating, as I said, green if all 3 are checked, red is none of it is checked. What we then also did is for all the AI features we have in Nextcloud, we give the users a choice. So this is an example from the configuration interface. For example, here you have different AI features listed. The first one is a translation system. So we have a built-in translation. I will show it to you in a second. And there you can choose, hey, do I want to use the OpenAI ChatGPT translation service for that? Or do I want to use a local running open source model? It's, for example, here the Opus model coming from the Helsinki University, which runs completely on-premise and is fully open source and runs completely local. If you install these apps, you see then this rating system in the App Store configuration. So as an admin, you can decide, do I want to use something that is green or yellow or red? And I have the full choice. And this is for every feature. Right here, the speech-to-text, for example, again, you can say, hey, I want to use the Whisper service, or I want to have actually a locally running Whisper implementation that we have nicely packaged and can be run with one click. And the same for all the other services too. So that's our strategy, that we make it transparent. How is it working? Is it transparent or not? Is it open source or not? And give the users a choice and give the rating, and you can decide what you do. But obviously, I mean, we have these integrations in all these commercial AI systems on the internet, but obviously our focus as a real open source organization, our focus is on the local and open source AI systems. So we have a full dedicated team now, because as I said earlier, luckily, beginning of the year, it became clear that we can compete with these big tech companies. Obviously not alone. We do this in a very nice open source way where we collaborate and work together with a big community. And there is a big open source community around AI now. And we have a dedicated team now to develop like the ethical AI features. And I want to show you some of them now. So a month ago, we launched the latest iteration of it. That is the Nextcloud Assistant, and this is a fully local running LLM system which can do all kinds of things, and I will show it to you in a second. We are quite on a run here with the releases. So we had a release in February, then in April, then in September, and there's actually another one planned in December. And with every release, like this year, we improve this AI feature, same as the rest of Nextcloud, obviously, but we improve all these AI features more and more, and there's really a lot that we can do. So, Nextcloud Assistant. This is a large language model. This is 100% open source. and this can be fully self-hosted. So this also runs on a relatively weak machine. I mean, it depends what you do, how many users you have. If you run it on a Raspberry Pi, which is possible, then it's possible that some operations actually take some time. That, I don't know, if you ask a question, the answer takes maybe a minute or something. Obviously, if you have a faster server or even a GPU in it, which is optional, then it's obviously a lot faster and same speed as proprietary systems. So what can the assistant do? So here are a bunch of basic features, and I will go deeper into a little bit more in a second. It can do face recognition, for example, in your photos, or if you upload your photos, it can detect faces and can detect objects. You can then search for bicycle and find all the photos with bicycle in it. There's a smart inbox in mail, so you have a priority inbox that the important mails are on top. It can recommend shares and recommend files to you. There's a translation system and many other things. I will show you some more interesting ones now directly. So what you can do is you can, on the top of the Nextcloud menu bar, there's a button for the assistant, and you can click on it any time, and you get an overview where at any time you can ask questions and do all kinds of things you know from ChatGPT. But really interesting is, of course, the way we integrate it into the applications themselves. So, for example, if you write an email, you can say, hey, I don't really want to write an email, I don't know how to say it or something. There's a button, and then you can say, hey, generate this birthday invitation for me, and then it generates the email for you, and you can just directly edit it and send it. So this is very nicely integrated. Then in any other place in Nextcloud where you're working with a text, and this is our collaborative Markdown editor, for example, but also works in Office documents. At any time there's a text, you can click on the side on the button and say, hey, make this text longer or shorter, or translate it, or reformulate it or something, and that's obviously very, very helpful for everybody who works with text. In Nextcloud Office, it's the same. Let me see, there's an animation. Yeah, you click the button, you say, hey, I want to generate some text. This here says ChatGPT, but it's the same with the local one, and it generates like a contract proposal, for example, for you. So you don't really need to copy-paste from one website to another. It's basically directly integrated into all the applications. Then let's say you're in a chat conversation. Maybe you're in, I don't know, your marketing team, and you discuss some brainstorming or some visuals, I don't know, that you can say, hey, I want to visualize something. I want to have a photo of some bracelet, I don't know. And then it generates a photo and posts it directly into the chat, and everybody can see it and talk about it. So this is also, it's very, very useful to have it directly in the application. Then there is, of course, a way for dictation. So some people like to dictate their mail or their texts or whatever, and there's the Whisper service obviously integrated, so in any time, in any place in Nextcloud, you can just dictate something and have it in there. And that's the same system we also use for the transcription service for video calls. So let's say you do a video call, you automatically get a transcript of the video call afterwards that everybody can use. And this can also be combined with the summarization feature I showed earlier. So you can also get, like in the end of the call, a nice summary of everything. Then the Nextcloud assistant can also act like a person. So in any conversation, any chat conversation you are, at any time you can say, hey, assistant, and ask any questions. Hey, maybe you're planning an event like that here. Say, hey, assistant, what are the most important things to organize a trade show? And then the assistant answers in the chat directly as a person. This obviously can also be very helpful if you just need any additional information. And I can also tell you a secret a little bit, like a pre-announcement that we usually don't do, but we're also working on a way where the assistant can work with your own local data. So in the future, you can ask your assistant questions about, hey, how happy is this customer? And they look into your emails and gets you the answer. Or you can say, hey, what is the biggest sales numbers? If you look into the sales folder, and can look into PDFs and gives you answers like that. So this assistant is quite useful. It's also integrated in mail. For example, maybe you have a very, very long mail thread. I think we open source people sometimes tend to have, at least in the past, super long mail conversations about everything. This Nextcloud Mail can summarize a mail thread for you and just show you the summary on top of that. Then we also have some more technical features. For example, there's also a locally running neural network that is analyzing the login behavior of the people into your service. And if someone who is usually not logging in the middle of the night from a different continent, something like that happens, it can, for example, trigger two-factor authentication or log the account or write something in a log file, different options. And then the last feature I want to show you here is document classification. So there's also a way where we can analyze the content of all kinds of documents, and we can detect, like, I don't know, credit card numbers, social security numbers, and other things. Then the documents can be tagged with that, with this attribute. And the feature I showed you at the beginning, that we can block access to documents based on different conditions, can be combined. So we can say, if there's in the organization, if there's a document with some, I don't know, confidential data, then no one really can share it to external people or something. So we can really build that. I want to show you now a bit of a video that summarizes all the features that we have today in the AI area. Let's see if this works.
Meet Christine, a project manager whose curiosity in AI-driven collaboration has led her to explore various articles on the subject. She reads that the use of AI can be risky, especially when handling sensitive company and customer data. But with Nextcloud Hub, those hindrances are no longer a concern for her. She knows that all data is strictly handled on the Nextcloud server and is not leaking or being used by another company to train their AI platforms. Let's see how these features play out in Christine's daily work. Yesterday, Christine received an email from Margot, which included a detailed document outlining observations and metrics of quality issues within the company. In that same email, Margot asks Christine to create an outline for a project aimed at addressing these challenges and to discuss this project approach in a call the next day. Her team also received that mail from Margot, and members sent in suggestions. Really great to see that many ideas, but the mail thread is far too lengthy to read. Christine definitely wants to use the suggestions from her team. She asks the assistant to compile and summarize these insights from her team. Then she goes back to the document from her manager. Christine wants to tap into the collective brainpower of her team and the AI, and with the summarized insights in hand, Christine directs the assistant to create a project outline. The on-premises AI capabilities of Nextcloud Hub enable her to craft an efficient plan for Margot. The assistant completes the project outline, and Christine shares it in a Nextcloud talk room with her manager. Christine asks Margot if she can record it, so she can have the transcript of the conversation to share with her team. An engaging meeting ensues. After the conversation, the call summary bot summarizes the meeting and shares tasks from the conversation. Christine incorporates this task list and the transcript of the conversation into the project outline for her and her team. After the meeting, Christine notices that a couple of tasks need to be delegated to Zarina from the German team. She selects the whole task list and uses Nextcloud Translate to get a German version. Now this can easily be put in a task for our German team, directly from text. Nextcloud Hub's built-in AI capabilities helped Christine to tackle this challenge within her organization much more quickly and efficiently as otherwise would have been possible. And she did not have to worry about any of this data leaking to a third party, neither the translation, nor the new project plan, nor the content of the call transcript that was created by AI. Christine feels in control and she stays informed without feeling overwhelmed. Nextcloud Hub helps Christine to digest key information for this meeting and other tasks and projects. Explore how Nextcloud Hub can help you redefine your organization's collaboration, offering trustworthy AI for smart productivity and robust security.
Okay, so this is basically what we developed in the last 10 months, and I'm really happy that it's actually possible for the open source community to do this stuff and to compete and have it run locally. Now I want to talk about like the last topic, which is the whole discussion about open source and NI. What does it actually mean? I mean, for us, open source is mostly about open source software, and open source software is obviously very clearly defined by the OSI and the FSF. But obviously, open source as a term is also used by a lot of other people for other things. So nowadays, there's open source books and open source cars. I don't know what this is. It's not really clearly defined. And everybody's also talking about open source AI. It's also not completely clear what this means because there is not a proper definition. So I want to encourage everybody to participate in this discussion, that we as open source community are in control of the definition of what this means, because this term is just thrown around by a lot of marketing people from big companies and it's not really clear. There's at the moment an initiative from the OSI, the Open Source Initiative, they have a working group, they have lots of meetings to define what open source AI actually means, and I think we all should participate in that. So from my perspective, I'm obviously a bit biased here, but like these 3 requirements from my perspective are maybe a good start. And the good thing is that it's actually sort of in sync with the other definitions for software. So I have here the 4 freedoms from the FSF. Richard Stallman wrote those in the 80s, as most of you might know. It defines what this freedom means regarding software, that you can run it as you want, that you can modify it, which requires the source code, that you can share it with others, and so on. And then there is the open source definition from the OSI, which is longer. This has 10 points, but the meaning is basically the same, I would say. It also comes with the freedom to redistribute it, to look into the source code, to have derived works, and so on. Something's happening. Okay, I can improvise. So it basically has the same requirements. And I think with AI, we should look into something similar, where everybody should have the right to use the model, but also then should have the right to look inside how it works and modify the model, which in the case of AI means access to the training data and the code to train the model. I think that's something that is important. And only then, I think it's a really true, I don't think it's a blackout button. No. Only then it's a true open source AI. So there are some who, for example, call the models from Meta, like the Llama model, for example, open source. And I think, for me, this is more free as in beer and not free as in freedom, because you can actually use it, but you cannot really see how it works, you cannot really reproduce it, and you cannot really, basically look inside, which requires the source code, from my perspective, than the training data. So I'm basically at the end of the talk now anyway, so no problem. The summary from my perspective is that ethical AI is possible, but just we as an open source community have the duty to do it in the right way. It's possible to run it locally. That's something where just a year ago no one thought it's even possible. It is possible to run it locally on normal computers. Right? It is also possible to control the CO2 footprint from my perspective, and it's possible to control the bias if you have access to the training data, which is unfortunately most of the time. Yeah. Didn't touch anything. But it's okay, because I'm actually done. So thanks a lot. This was the presentation, and maybe now we have time for some questions.
First question over there, and then we'll come here.
Hi. You mentioned one of the problems with using a hosted AI is that it could be using your data to retrain itself. Now, with the local deployment on-premise, that might be desirable. Is this possible with Nextcloud?
No. So the way I see it at the moment, but again, the world is changing every week here at the moment. The way we see it, that what you want to have is ready, trained large language models, foundation models that take a lot of resources. This is something we cannot really do efficiently locally. And this is what we already have integrated. Then, what you also might want to do is do fine-tuning on top of those. So fine-tuning is a process where you take a model that's already there and you basically give it additional information, additional data. So this is a project we are doing together with the German government at the moment, where we take an existing model and we adding like specific documents, for example, I don't know, tax return documents or something that government people do, and we're basically adding this on top of an existing model so that it actually knows these kinds of things and can be used. And this is also something that takes quite some resources, and this is something you need to do offline. You definitely need the GPUs for that, for example. And then the next thing that we are doing is that you're adding other custom data via vector databases. This is the assistant feature I mentioned earlier, where you can access your local data in a chat interface, for example. But this is something that is stored in a vector database, which doesn't really require training a model. So at the moment, like Nextcloud itself cannot really train itself. At the moment, I don't think this would be useful or practical, but again, maybe, I don't know what happens next month.
Okay, so my question will be about interaction between the human being and artificial intelligence. So, maybe you know what's Pavlov's dog,
yeah.
And how you think to avoid that artificial intelligence will do or will not do interaction with human in the Pavlov's dog theory?
I have no idea. But I think there will be a panel about AI tomorrow, quite early at 9 o'clock, I think, about exactly these topics. I will be there together with some people who know a lot more about this, and I think maybe you can repeat the question tomorrow.
Sorry, there was a bunch.
So, should I? Okay. A question. I have a question. If I am training my own models, can I integrate them in the Nextcloud?
Yeah. So there's an abstraction. We built an abstraction for that. So we ourselves can also swap out the models below it, because it's also something that changes all the time. At the moment, the most promising ones is the Llama 2, it's the Falcon model, and it's the Mistral model. I think these are the best at the moment, but I'm sure next week there will be another one, and you can swap this out, and you have your own. You can also plug it in. By the way, we don't only have like one model. Maybe it's 10 or something overall for the different things. Right? The image generation is different. The login detection is different. Face detection is different. So there are different models, but they're all swappable. Yeah.
So, a question in the back here. So you mentioned at the beginning one of the core challenges as being the CO2 footprint of the training of these models, and I was wondering what Nextcloud is doing in that respect. Also, just to say thank you for raising that issue. It's often overlooked.
Thanks. Yeah, I mean, obviously we cannot do any miracles there. What I think is the first step, that's for sure, is that it's transparent. So at least with this soft system, you can at least measure it. I mean, with Copilot or ChatGPT, no one knows, right? And if you ask the companies, they don't answer it, and they also don't care, because this all comes from some other magical money sources. But here, at least, we can measure it. And because everything is local, the source code is open source, training code is open source, you can actually improve it over time. For example, if there's a new version of PyTorch available or something that is somehow more efficient, I can put it in and then it's more efficient. We don't have a magic bullet there, but at least this flexibility and the transparency, I think, is a first step.
So it's great to have a pre-trained model, right? And but the problem is that as time elapses, as we get the answers by the model, we want to make it better, right? And sometimes fine-tuning with our own data is not enough, because there are other companies, other people that are doing the same thing that we are doing that could actually contribute to that, to our results being better. Have you done anything, something like in the federated learning stuff, in order to collaborate different companies of the same thing, like different servers of the same thing, different data that could be used as the same thing?
There's a whole movement about this. There is, most people might know Hugging Face, the community. And on Hugging Face, you do not only have like models, but you also have training sets available that people share with each other. And a lot of organizations do, a lot of research people do. They're provided as freely available training sets, maybe Creative Commons or something, and then everybody can build on top of it and it all gets better. So,
yeah, but sometimes this data is private, right? So for example, if I want to train on facial recognition or healthcare data, that's not the case, right? So,
yeah. I mean, yeah, sure. I mean, this project we're doing with the German government, this is then anonymized, for example. It's possible to remove like names and stuff, personalized data, and keep the artist data in. But if it's like really truly private data, like my emails or something, then yeah, I mean, then I don't want to share that, right? Then that's only all I can do. So there's, I don't know what the solution could be.
The answer was federated.
Okay, one more question.
Okay.
Okay, erosion goes on, and we actually don't know how these models works and predict their results. Is any way to be sure what there is no backdoor already in current models in your next code release?
Not sure I understood correctly. The question is if the answers we get from a model is always the best, and there might be another which gives better.
Not. The question is about security. So we don't control models. We already avoided above our level. And are you sure what your next code release don't have backdoor in these models, so our data will go away from organization?
That's very interesting. So at the moment, everything we do is that you basically interact with a model and the model gives you output, like text or images or something. At the moment, these AI systems, they cannot really do anything themselves. This, I think, is a very interesting discussion maybe for next year. There's also other companies also have the same, like Copilot. You can ask questions, but Copilot cannot really do anything themselves, right? You don't wake up in the morning and Copilot says, hey, I finished your program overnight. That's not how it works, right? And then we really have this, then I think the security questions you raised, then it gets really interesting, right? Because once you give these models powers to do something, to send mails in my name, or to order stuff online in my name, then the security questions you raised are really interesting and really important. At the moment, they're passive systems, so I don't think there's a problem yet.
Actually, very active by nature. They do calculation to give us answers.
Yeah, the answers might be wrong and might lead me into a wrong direction. That's true. In a way, this could also be a security thing. Yeah. I think this is a super interesting question. Yeah.
Okay, so other open source projects are also working on integrating AI, such as Home Assistant, and they are designing protocols to allow them to interoperate with other systems. Is this something you've been considering?
Not really, but I find this also another super interesting question, because we will have, just look at emails. it's super easy to write super long emails now that no one can read anymore. And then you have other AI systems that summarizing it back for you. So we will have a world very, very soon where if you don't have these AI features, you can no longer work. Because your coworkers are just spamming you, hey, I have another 100-page document, how to improve our marketing, here, read it. And then no one can process that. You need an AI system summarizing it back. Right? But then if you're then into a world where the actually mails that are sent are no longer read by actually humans, they're created by machines and they're read by machines. Then the question is, maybe at some point they develop some kind of special language they use for that, right? It might be still technically English words, but they're putting some stuff in that is not even usable for humans.
Yeah, but my question was more in the sense of whether we can use Nextcloud to be a backend for the AI of other systems like Home Assistant, which they also are using, and they created this protocol called Wyoming, which allows them to run the containers that actually run the models on other machines and stuff like that. So,
so what we developed, there was a slide, but it was black, sorry for that. What we developed like a special new API, that's a new microservices API that we use to integrate all kinds of AI systems into Nextcloud. Because by itself, it's the normal app system we have. It's PHP based, and if you want to use a different language, that's a problem. So if you want to use Python, for example, or Go or something, you have this new microservices architecture where you can integrate these things. But it's still, everything is in the Nextcloud universe. We don't really do any APIs with other systems. It would maybe be a little bit against our philosophy because it's all about keeping your data private. When stuff is floating to some other machines, I don't know, that's...
Well, it depends. Home Assistant shares the same type of philosophy. So they allow you to run totally locally AI also. You can also choose to not use local. So that's why I thought there are coincidences of philosophies. So maybe there could be an ecosystem that integrates between those two projects.
Yeah, something to look into. Yeah.
Question. So when you talk about ethical AI, it kind of makes sense that the evaluation would be applicable to all of the members of one deployment of Nextcloud, right? But once you're crossing the boundary, you might cross into different decisions. So what one deployment might consider ethical, another one might not, right? Yep. Or what one group of users might think it's okay, for example, sending birthday invitations auto-generated. Another group might think, okay, that's too far. Is there any work on defining an API to exchange that information?
Not at the moment, but it's also very interesting. I mean, that's a fundamental problem you have on the internet always. Right? Like maybe you just look at email again. Right? Let's say you have one Nextcloud which is configured in the most secure way. Everything is local, everything is disabled, and then I can use the local AI to write very nice, super confidential, great emails and sending it to you. And you also use Nextcloud, great, but you activated ChatGPT integration, and then it's all sent to OpenAI, and they can have access to my mails indirectly. Right? And that's the same for chat messages and everything. You sort of need to trust that the other side has the same level of security, otherwise you have a problem. And I think with AI it's probably the same. But yeah.
And last question there. We have 1, 2. We'll have to have maybe for 2 or 3. That's it. So 1, 2, 3.
Hey, great talk. I have a question unrelated to AI. You said you were depressed last December. I hear you. And I want to ask, what was sacrificed in terms of the roadmap for Nextcloud to get you to this? In terms of the product roadmap, not personal, just
yeah. I would say nothing. I mean, Nextcloud is developed by the community and by us as a company. From a company perspective, we were 65 people beginning of the year, and now we are 100. So hired like 35 people over the year. And some of them went into the AI team and other people in other teams. And yeah, nothing was really sacrificed. And community, I don't know. If some community people change priorities here, not really, no. Thanks.
Hello, thanks for Nextcloud. Awesome software. I mean, I'm using it and I'm really, really happy. So with all that new assistant feature and like new AI features that coming more and more, you said you can run a Nextcloud on Raspberry Pi. And you know, we all try to be as efficient as possible, right? With these new features, the system requirements, how much they will change? Thank you.
Yeah. Well, answer is it depends. So there are some features like the whole recommendation of shares, file recommendations, login detection, also the face and object recognition. They are very lightweight, so you probably don't even notice it. So this is no problem. I mean, it gets more interesting about image generation and large language models. They're really also run on weak hardware, as I said, but then they're slower. So I think we did some tests with the latest Stable Diffusion that we also have integrated now. And in some circumstances on the Raspberry Pi, it takes like an hour or something to generate a picture. So the user interface, we actually have developed everything asynchronously, so you don't really have to wait. You can fire up the operation, it works in the background, and once the image or the text or something is done, it gets a notification, and then you're back there. Which we did that you don't really have to, that you're not slowed down. But of course, well then your Raspberry Pi is working 100% CPU load for an hour, right? Yeah. So this is a problem, of course, yeah. If you have a faster machine or put a GPU in it, then it's real time, but of course it also takes more power. So, what was the question? Okay, thanks.
So you sort of touched on this. We have this divide between these like wonderful open source models, which are entirely open, maybe get a green light on your scale, but maybe are smaller, less capable than the models that are built by OpenAI, Facebook, maybe Anthropic, that have huge amounts of funding to make these like large models that are much more capable, but are very disincentivized to make those open source or even free. Do you have thoughts on if there's any path forward to shifting around those incentives or solving this problem of like the good AI is not open source and the open source AI is bad because there's no funding?
Well, I don't know, but this is one of the biggest questions, of course, in this space. It will be very interesting in the next few years, what happens. So all I can say is that a year ago, everybody thought open source can do nothing. Now it seems that it can do a lot. There is a constant arms race. They're even like, I don't know, they're even rating and the scoring system on Hugging Face, where you can compare the models all the time. And there's always something going up and down, and it's a constant arms race. At the moment, there are models that are, the three I mentioned, are nearly as good as GPT-3 or 4. Yeah. So at the moment, it looks like that open source can compete. How this will work out in the future, no one knows.
Thank you. I know that's kind of an impossible question.
Yeah,
I was curious to hear what you thought.
I'm also not really an AI expert, so yeah, thanks.
Brilliant. Well, I think everyone wants probably to go for lunch. So in the meantime, Frank, amazing.
Thanks a lot.
Thank you. Lunch is served on this floor, but also downstairs. So if you can't find space here, there might be space downstairs on the ground floor, which is called first floor in this country, which is obviously confusing. We're coming back here at 2 p.m. for the PenPod presentation.
it's up, game out, feel like going home now. Now. Fails and turns to luck, words aren't making it, it seems. Whip hand and join fire. Cut the ground better, dang, just about out from under one. Now the laugh is up, struck up, I'll grapple up and down. Hip hustle and higher fire. On a cloud, turning round, down a sealed, be all up and out. They don't get on, we all fall down. We don't get up if we all fall down. Get up, get on, we all fall down. We don't get on, we all fall down. Get up, get on, if we all fall down. They don't, we all fall down. Like I'm feeling okay, maybe going out so right. Picking, fixing a fire now. I'm by the hip, standing still, moving up, going round and round. They don't get on, we all fall down. We don't get up if we all fall down. Get up, get on, we all fall down. We don't get on, we all fall down. Get up, get on, if we all fall down. They don't, we all fall down. They don't get on, we all fall down. They don't get up, we all fall down. Get up, get on, we all fall down. We don't get on, we all fall down. Get up, get on, if we all fall down. They don't, we all fall It's opening up, duck forward, get cold. Let go and come down, let go and come down. Let go and come down. Tonight it's your favorite shirt, the wind ain't hot but it's calm. Let go and come down, let go and come down. Let go and come down. It's possible I might miss you. If not, when will it again? I burn, you turn, I learn. Why not? Why? You got to feel it tonight. Blow hot and blow cold, play fast and loose. Take it to head, take it to head. If not, when will it again? I burn, you turn, I learn why not, why? You got to feel it tonight. Wish you could see this. 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 Wish you could see this.
matters, and then do a live demo. Hope it goes well. So what's PenPod? Well, PenPod is a beautiful open source product. It's beautiful in its UI, it's beautiful in its code because you can see it. It's open source, MPL 2.0, and it serves product teams to build UX UI interfaces. So this is just actually this is a prototype UI. This is the UI 2.0 that we are releasing shortly. So what can you do with PemPod? This is a tool for product teams. Of course, you can do all sorts of things. You can do design systems, so you can create components for your UX UI work. You can use different layout systems like Flex Layout using the standard CSS. You can design a prototype, do interactive prototypes, all that sort of stuff. And of course, you can look at the code. Since we are SVG and CSS native, what you see is what you get, like really. Like we are using the DOM to render everything. So pretty cool. If you're interested in what technology we're using to build PemPod, that is Clojure and ClojureScript. And it is a wonderful functional programming language that is actually allowing us to build PemPod super fast. So kudos to Clojure. Why, in a way, what we're trying to achieve with PemPod is that we do believe there is a great disconnect between design and code. Also between designers and developers, but like more broadly, design and code. And this is why we strongly believe that PemPod offers developers in particular something that they can integrate deeply with their workflows. Developers, I am a developer myself, we really treasure flexibility, and this is something that PemPod delivers. Absolute flexibility within a more complex process, which is the design process. So very cool. And how do we do this? Well, first, it is open source. You can use it, you can hack it, you can tinker with it, you can adapt it, you can host it for free. You can do or SaaS, you can go on-premise. Complete freedom there with open source. But also, and very important, we adhere to open standards. So we are SVG native. So that means that everything that you draw or design using PemPod, whether it's a brainstorming session or actually a product UI design, it's using SVG there. So if you inspect the code, you go to the browser and inspect exactly what is being rendered, that is exactly the SVG that you would get if you not export but download the file. We use a bit of metadata to enrich interactions, but basically that's it. And since we are open standards with SVG, it's very easy for us to have the CSS equivalent to everything that we build and we design. But I think most importantly, I mean, if you already have open source and you already have open standards, then really PemPod is about collaboration. Collaboration between designers and developers, between design and code, to share that open source ethos also during the design process. And to do that, we have to make some decisions. So we are very opinionated at PemPod. And one of those decisions is actually bringing from engineering, from the code world, abstractions, vocabulary, best practices into the design process, hoping that designers are going to actually love it because of the non-lost in translation problem anymore. So this is how we are bringing developers into the design process by making a tool that is primarily intended for designers, but actually developers love too. Without collaboration, I would rather think that PemPod is not up to the task. And for that, of course, we are a web-based tool, so you only need a browser. And it's real-time collaboration enabled, so you can do all sort of, synchronous or asynchronous tasks with PemPod. We are actually enjoying the ride. This is just one of the various metrics that we looked, every day. I wake up and look at something like this. This is actually measuring the rate at which new self-host instances are deployed. This is just a fraction because we have optional anonymous telemetry, but this means that there's a compound effect because this is new instances per week, not cumulative. So amazing. We have actually a split demographics. 50% of our users go through our SaaS, which is free, and then 50%, estimated 50% go to self-host their own PemPod server. Now think about this. Finally, for the first time in open source world, you get to have the whole development pipeline 100% controlled by you. It's not that design lives elsewhere in a silo, and then you have to kind of connect that through some pipe. And and duct tape. You actually have full control, so you can integrate everything. Estimated at 100,000 projects, various GitHub stars, and 30 languages that go beyond the 80% threshold. I'm happy to, and I think this will resonate with the audience here, to say that some languages we do sponsor the translation. This is the case for Hausa and Ibu, West African languages, where there is not just that there are hundreds, there are actually dozens of millions of people speaking Hausa and Ibu, but there is a disconnect also there between what technology vocabulary and the language. There is a chasm there. So we are sponsoring that they actually are able to translate technology into other languages, use PenPod, and feel literate using PenPod. So I think in a Ubuntu Summit conference, I think that you would like that we're doing that. Now, for languages like other many languages that hang out their resources, we do expect the community to help us do that. But why? I want to, this is a picture of the team, and I would like to ask you to raise your hand. I'm going to ask 3 questions. The first one is, please raise your hand if, in your work experience, you've been in a company that had a 1-to-2 designer to developer ratio. Like per 10 designers, you would have 20 developers. Raise your hand. That 1-to-2 ratio, okay? 3 hands, so 2 hands and a half. Now, keep your hand raised if you also happen to have all designers use Linux. All right, so for you people watching online, we went from 2.45 to 0. And keep raising your hand if, on top of that, you had roughly split 50-50 male-female relationship across the company, technical, non-technical. Okay, no surprises there. Yeah, that would be, So this is the team that actually built PenPod. They wanted to make sure that at some point this relationship between open source, commitment to open standards, designers and developers, that empathy would become the tool they wanted. So a few years ago, at Kaleidos, the full name of the company is Kaleidos Open Source, so you can see more or less. We had you can only use open source within the company. That's a sacred rule. And that's why designers would only use Linux, but they would be welcoming that. But at some point, designers said, this is too much pain to bear. You developers are privileged citizens in open source world, we are not. And for us to express our talent, our creativity, the same way you do, we will need to break that sacred rule. We will need to go and ask to use Figma. And that was a very kind of breaking moment for the company. Should we allow for that, exception to the rule, or not? And we said, okay, let's do that as a temporary solution. But if we are going to allow for that, we're going to build the open source Figma killer. Deal, deal. And that's PenPod. That's how PenPod began, right? With an extra kind of footnote where we said, yeah, but we don't want to copycat. If you are going to embrace true open source ethos in terms of collaboration, transparency, respect, we need to go beyond simply an open source design tool for designers. We need to build an open source design prototyping tool for both designers and developers, because that's the next thing that's coming. Developers have been collaborating with each other. We've been collaborating with each other for decades. Designers recently have discovered, like when you discover America, like, not really, that they actually could enjoy collaborating with each other using digital tools. Well, what's the next logical step? Okay, you tell me. So that was also part of the deal. A lot of great energy you see in the picture. Yeah, I really believe in that deal. But why, again? Anyone recognize this, which distribution that is? I mean, if you look at the year, you actually know. That was 7.10. Okay. That's actually Angela, my wife. We were in San Francisco for a Lug Radio live event. Anyone here knows about Lug Radio, the podcast? John Bacon, Stuart Langridge, Matthew Revell, okay? So they were very prolific in terms of podcast episodes, and they hosted one in San Francisco. And of course, I've been using open source since 1997. I was there when Mark announced first 4.10, and this is 7.10. And we kept getting free CDs. So what we did is, this is the Gideon's Bible in a hotel room. So we are making fun of a different way of evangelizing, basically. It's like, okay, why not? The next person that actually opens the Bible is going to find Ubuntu there. So that was, but really, this is just a pun to express the way we believed Ubuntu was making accessible open source, to remove the friction. So much great stuff was going on open source, and yet a lot of people would not be able to enjoy it. For us, that's also similar in terms of the friction between designers and developers, between design and code. We think it's broken, and many years later, still this is the energy that we have, like going with Ubuntu CDs or DVDs. This was a DVD, of course. I have to say that after this, Angela went back to Debian, and we had some issues, but we still use both Emacs, so that I think Emacs is keeping the marriage together. But everywhere and then she will go say something gross about GNOME, I will say something gross about KDE, and that is also spicing up the marriage. But yeah, at the time there was no, everything was cool. But now, sorry, but I'm going to turn the mood a bit darker. This is the moment where the lights, I'm not asking for that, but like will go down, because there's another why. And this is a very serious one that should appeal. Oh, thank you. Thank you. Actually, it's a great effect. Yeah. I hear, yeah. So for those of you that don't know those logos, that's Adobe and Figma. And a year ago, they announced that Adobe was acquiring Figma for 20 billion. Okay? I'll pause there. 20 billion. Think what you would do with that money. How many free DVDs we could ship? So why is this so important for us? Yeah, a year ago, we actually, if I go here, you see that first spike. That was the announcement. It is concerning that nobody seemed to see, still today, that this deal is not about designers. It is about developers. I'm here to tell you that you are worth 20 billion, probably more than 20 billion, way more than 20 billion. But 20 billion means that there has to be a market enlargement somewhere. And when you own, like Figma does, 80% of the market in terms of design prototyping, Adobe is quite a monopoly. Where do you find the next blue ocean, like massive blue ocean? It's you. Developers. And I know there are designers in the room, but mostly developers. So this is the secret plan, really, to make sure that you now join the ranks of their dynamic duo here and be monetized savagely to make up for those 20 billion. Not in a year. Adobe is a generational company. They can wait for a few years. But you are the target. So no surprises there when during Figma Config. You see, I don't have any issues mentioning competition. Oh, okay. Figma Config announced dev mode. Of course, they were going to announce something like that. Okay. Are they succeeding in that? Well, you tell me. But so this is also a why. We need to make sure that developers have choice in what the design tool also is, the market, basically. This is a monopoly. Okay, so back to fun stuff. Of course, we design Pempot using Pempot. You know, that's a meta thing in open source. This is an interface designing it itself. And of course, everything we do is public, full transparency, not just the GitHub commits or release notes, but actually the roadmap is there using Taiga or other open source products. So you can actually kind of follow us real time, what we're doing on any given sprint. Yeah. Okay, demo time. So I hope it works, okay? The last time I did this, well, that's a horror story. Of course, I'm using Pempot to do my presentations. Why not, you know? But this is not what the demo is about. So very briefly, we celebrated our first Pempot Fest this year, June, Barcelona. Was really amazing, and we created a website. You see why the demo has to do with this in a minute. This is not like marketing stuff. But this was not done by the team. We had to make this an external arrangement, like a contract. It was good. I mean, the event was amazing, but the website, not so much. So during our week-long hackathon, so we have every 6 months, I created EasyFest with a colleague, Andres, back in Madrid. And EasyFest is, yeah, that toolkit that provides you with a automatic event/festival website thing. So I don't know if you know this summit thing and conferences, but if you're interested, you know, we can have a chat. This is not a talk about Pempot, actually. This is a talk about EasyFest. But EasyFest is basically a backend using Strapi. Anyone here knows Strapi? So this is a API, content-driven, and then the front end uses Svelte. Anyone knows Svelte? And I'm going to also use Pempot Export, which is a community contribution that takes the API, Pempot API, and exports some cool stuff and changes the layouts, not the layout, but the typography and colors of a website. So let's go. This is a local host, okay? So this is like I'm running Svelte locally. And please don't blink because, okay, this is the let's see here. This is code. Yeah. I have configured, this is not the real, but we have the access token and the file ID on the Pempot file. And I'm going to do this. So I'm going to run this command. And please, you know, if you blink, you miss it. What this is going to do is going to connect to a Pempot file. It's going to extract design tokens, variables and typographies. Colors and typographies, and it's going to immediately apply that to my run in Svelte front end, okay? So I do this. I switch here, and it changes, okay? So you could actually automate this. I did this right now, and you can see, you know, I changed colors, etc. So I'll do it again. But this time, I'm going to actually just do that. So I go back to to normal. So this is basically overwriting these 2 files, colors and typographies. But how actually did I manage to do this? Well, first, here, this is my Pempot dashboard. So I would go to my account and just access tokens and create one. I actually created one the other day, right? Ubuntu Summit, and that is what I'm using. And I would read the documentation of the API. And I would actually know that Pempot Export is using getFile. getFile is quite generous in terms of payload. So that is what is going behind the scenes, okay? Now, what is the Pempot? This is the design. This is a design in Pempot. I'm looking here. Here, much better. But this is not exactly what I'm using. What I'm using is a copy of that looks exactly like this, because under assets, I use all these variables. You see? Can you see it? Yeah? So we have colors and body and typographies for various stuff, right? So this is the file, this is the URL that I copied. So it just traverses the colors and typographies and exports it, in this case, as CSS. I can do that with SCSS, CSS, or JSON. The JSON is using the draft W3C design token standard, so also very cool if you're into that. So I'm going to do a change. But before I do a change, I'm going to, again, sync. So this should change again. And I'm going to do a minor change. In this case, I'm going to change the background color of this welcome party tag. So I would go here. I mean, you can do this many different ways. I select that. I see that I'm using primary light. You see, this is the color. So I can go to assets and just look for primary light. So let's do this. Edit. I don't know. What color do you want? Recent colors or file library? Recent colors, like anything could do. I'll pick that one. Select. Of course, immediately everything that is using that variable will change. That's expected, like everywhere. Now that I did that, I can run again, and in this case, only that should change. Okay, let's see how it works. Okay, thank you. The demo worked. So this is kind of Hello World API thing. I know this is, but it's cool because that means that as a developer, you can go to a design. You can actually pick any element of a design. You can go to inspect. You can go to code. All that is, this is actually using Flex layout, Flex CSS layout. So it's really copy and paste. And we are releasing grid layout in a couple of months, something like that. So you will have Flex layout and grid layout as a built-in design layout so that designers and developers don't care about translating anymore. They just have all that creativity and they just perhaps integrating that bit of code there, CSS, directly into whatever they want. You can do that as a developer. This is not a dev mode. This is one mode. This is one mode that you can adjust the way you want, depending on your user persona or your activity. Or you can integrate it with an API and just start taking variables, tokens, or chunks of data and integrating that with your existing development pipeline. Okay, so if I go back to this, I would like to send this message. Like, if you are a designer or if you are a developer that really truly cares about collaboration between designers and developers, you care about open source and open standards, please go and check PenPod and enjoy it and contribute to this amazing project. Thank you very much.
And we might have time for 1 or 2 questions. So,
can you go back to the demo, please? I mean, it was fantastic seeing the color updating, right? But where's the emoji?
What is what?
Where's the emoji? So if you open
what I didn't mention, because that was not part of the demo, is that this is a design that is not being implemented yet on Svelte. So here, what you see is not a direct transposition of the design, of the layout, but actually the variables. That is what the demo is about. The moment we actually implement this Flex layout into the repo, which is a work in progress, then we would be wanting to connect everything. But for this particular demo, it was only about the color and typography, so I don't care about the layout. Okay? But of course, that will be the natural next step. But we need another week-long hackathon this Christmas to do that, and then we have like full duplex connectivity. Actually, why not changing something in the Git repository could have an impact here too. That's very exciting, right, to go both ways. But yeah, so sorry, I didn't mention, it was not, it was a very specific API connection there. Good point.
Hi, can you briefly describe your other tool, Taiga?
Yes, Taiga has been out for a while. It was also part of one of our hackathons. And it's an agile project management tool. So it supports Scrum and Kanban. And it's open source. And it basically gives you, for the team, a very cross-functional friendliness in terms of designers and developers working on agile terms. So yeah, that is, this is Tiger here. Yeah. So Penpot is not the first tool, open source tool that we developed. We've developed many others. Tiger probably being also a very big one. Yeah. And EasyFest perhaps, just perhaps, becoming something. Okay.
I think we're going to have to end the questions, but I'm sure you're available outside for any question anyone had. So thanks a lot. Big round of applause. And the next session, as you see, will start in 3 minutes to talk gaming. This is the moment when you see who's serious and who's not. Serious people go out. Fun people come in.
I wish you could see this. Wish you could see this.
Right, non-serious people coming in. We're going to get started anytime soon. Sorry, gaming people. We're adjusting the microphone. Who's a gamer here? I don't know if that was your first question and if I ruined your presentation, but there you go. You have all the gamers with their hands up. And
hey, everybody.
There you go. Thomas, the floor is yours.
Let's see if we'll go. Okay, we'll go back to the title here. I'll get started because I've only got about 25 minutes here. So how Steam Play Proton makes gaming on Linux awesome. What I want to do here is go over some of the main components involved with Proton that kind of make your gaming experience on Linux work. There's a lot of components involved, and I think it would help a lot of people to have a general idea, especially those in the Linux world who like to tinker, to have an idea of where to look for certain things when trying to maybe troubleshoot some things on gaming on Linux. So, a little intro about me. My name is Tom Kreider. I go by Glorious Eggroll online. I am the developer of Proton GE, which is a fork of Proton. I also have my Nobara project, which is a fork of Fedora. It's gaming oriented. As odd as it may sound, my nickname is Eggy. It's stuck with me for many, many years. So, egg like a chicken egg, E. I'm currently an engineer at Red Hat. I've been there for going on about 5 years now. And my job at Red Hat has nothing to do with gaming. But in my free time, I dedicate most of my free time to these two main projects, which have been a lot of fun for me. Personally, I've been using Linux for probably a little bit over 2 decades, 20 plus years. My goal is to it's not so much to talk about my projects, but rather to go over the main components in Steam Play and Proton that allow Windows games to run and give you a basic overview of what they do. So, first things, a big honking chart. This is the first half of the chart. We're going to go over this first. So you have to have an understanding of what happens on the Windows side first, because a lot of the games most of the games that you're running in Steam Play Proton are they're Windows executables that have been translated through Wine. So we've got the game, and that's where it starts. The game has 3 main components. There are several Windows APIs that are used that Wine does, that Wine translates. But the main 3 are you've got your graphics, your audio, and your controls, your device input. Those on the Windows side generally go through DirectX on Windows. DirectX then separates them into 3 main components, which are Direct3D, which is versions 9, 10, 11, and 12. You do have older versions, but most of the time it's those 4. You've got X audio for your audio, and then you have D input and X input for your controller input. So we're going to break down this chart a little bit with the first part. Yeah, I just explained these, so there you go. You've got those 3 components that I just told you about. I don't know why I did double slide for that, but there you go. More on DirectX. So as I mentioned, the DirectX API breaks down these 3 main components into DirectX compatible subcomponents like so. You've got Direct3D, which handles DirectX 9, 10, 11, 12. X audio handles audio. D input and X input handle the controller input. And then we have an additional note here for graphics. There are some games on Windows that don't use DirectX or don't use Direct3D portion of DirectX. Instead, they use either the older OpenGL or the more current and more popular now, Vulkan. Thank you, Valve. You guys have been awesome with getting that a lot more popular. But for those games that use those directly, Wine does do some minimum translation, but it can pass most things directly to Linux because Linux is able to run those natively as opposed to Direct3D where it cannot. So with specific regards to that, again, OpenGL and Vulkan kind of they don't have to go through DirectX. And now a big honking chart of the Linux stuff, the part that everybody wants to see. This is a much bigger part of the chart, obviously. I'm sorry if people can't see this. I know the chart is kind of small even though it's blown up here. But we'll break it down a little bit more. So we've got Wine, which is where the DirectX stuff gets inputted. And Wine handles a bunch of different Windows APIs. There is a presenter later today, Eric Hiller. I would recommend if you're interested in seeing a lot more detail on the various Windows APIs that Wine handles, to check out his presentation tomorrow. He also has one later today regarding the different branches of Proton, so I would recommend checking that one out as well if you're interested in this kind of thing. But we're going to go over just the 3 main ones that I mentioned before. So we've got WineD3D, right? So legacy, the way that it worked for legacy is Direct3D 9, 10, and 11 originally went through WineD3D. WineD3D is still implemented, but the difference between WineD3D and the newer VKD3D and DXVK is that WineD3D was for OpenGL. So before VKD3D and before DXVK existed, that's how games would get translated. They would translate the DirectX calls to OpenGL through WinD3D. Nowadays, especially with Proton specifically, we use DXVK and VKD3D for translating those DirectX calls to Vulkan. So this is just an explanation here of Wine. Its acronym, Wine, is not an emulator. It's a compatibility layer capable of running Windows applications on several POSIX compliant operating systems. This is pulled from Wikipedia. You can probably bring this up if you need to. I'm trying to get through all my content here because I got quite a few slides. But that is just the definition of Wine and Wine's website. This is the core of what makes up Proton. This is the bread and butter. More on Wine's API translations. In this specific regard, DirectX API is considered a Windows API. In addition to Windows' own API, additional APIs existing outside DirectX, DirectX is therefore handled by Wine the same as those other Windows APIs. For the three main components we discussed, graphics, audio, controls, Wine takes those API calls and translates them and sends the translated calls to native Linux libraries, which then pass those calls onto the Linux systems drivers. Wine translation layers for graphics. So now we're going to go into a little bit more detail on the current gen graphics side. I explained the WinD3D portion, which is number one. That one is not really used in Proton. There are overrides that like there's an environment override that you can use if you want to try it, but generally we want to try to use either DXVK or VKD3D if possible. The WinD3D backend is more of kind of like a fallback to try, and then it also helps with bug reporting. Like if an older game you try runs in WinD3D but doesn't run in DXVK or Proton, that's definitely something that you would want to do a bug report on because it should work in that regard. Again, so just to separate the difference between DXVK and VKD3D, we'll touch on number two first. DXVK is an external translation layer used by Proton for translating Direct3D 9, 10, and 11 on Vulkan. Or to Vulkan, excuse me. DirectX 12 in specific is handled by VKD3D, which is a second portion, and we'll get to that in a moment. Proton uses DXVK as a replacement for WinD3D, as I said, mainly for the advantage of being able to use Vulkan instead of OpenGL. And because DXVK is specifically aimed at gaming performance and optimization, well, I'll tell you a little bit about Damavan in a minute. Damavan, here, let me back up a minute. So Damavan is a work-in-progress replacement for WinD3D that kind of does the same thing that DXVK does, but the difference is DXVK is aimed for gaming, whereas Damavan is aimed more as a traditional WinD3D backend. It's more so meant for if you want a game, but you also want to try and run basic Windows applications, because we know that Wine itself is not just for games. And that's why Proton specifically uses DXVK rather than using the Damavan backend. So yeah, that's what I was explaining there. Now that you know about Damavan, again, that's why we use DXVK instead of Damavan. Let's see, Wine translation for graphics layers continued. Now we'll get into the VKD3D portion. So VKD3D specifically handles the DirectX 12 portion. So an important thing for games in particular is if you are running a game and maybe you're having a problem, maybe it won't load, or maybe you see graphic glitches or something, it's important to know or to try and find out which version of DirectX or Direct3D that it's running, because that can kind of give you an idea of where to report bugs. For example, if the game's an older one or it's running DX 9, 10, 11, then it might be a DXVK bug. But if it's running DirectX 12, then it would be a VKD3D bug. The bottom line, regardless, on the Proton side, is that generally we would want you to report Proton-specific bugs on the Proton tracker, and then Valve does have engineers that can further direct those to the appropriate people that need to take a look. But outside of Proton, which is where stuff that I work on comes in, like not just Proton GE, but also Wine GE, it's helpful for me to know if the game is DirectX 9, 10, or 11, because then we can direct a bug report directly to those projects, because while they are part of Proton, they also have their own individual bug trackers outside of Proton. There's a couple of parts to VKD3D. So that Wine has, or excuse me, Codeweavers, the developers of Wine, they have their own, the original branch of VKD3D. And that has a couple of different components that are part of it. And then Proton specifically has, it includes that, but it also has VKD3D Proton. And VKD3D Proton is actually just one part of the full list of components that make up VKD3D. I feel like I missed a... Okay, so yeah, that's what I was trying to get at. So VKD3D itself has two major parts. There's a couple of other parts, but the two major parts are VKD3D itself, which has the API translation layer, and then VKD3D shader. VKD3D shader is the shader compiler. It's used to compile or recompile shaders between different formats. And once the translation is, the VKD3D is used in combination with VKD3D shader. And so the job of VKD3 Proton is kind of a drop-in replacement for the translation portion of the original VKD3D, specifically aimed for gaming. And again, that's why both of them are, if you look in the GitHub repo for Proton, you'll see both VKD3D Proton and VKD3D are in there. And you know, people who maybe didn't know the difference between the two would wonder why. Well, that's why. It's because VKD3D Proton is just the translation portion. So audio layers. Again, so Wine translates this, and it goes through, now it goes through a project called F-Audio. When SteamPlay Proton first started, originally audio was handled by Wine's own internal API translation layer for X-Audio. Unfortunately, this layer, it had quite a few problems, and we needed a new solution. This is actually kind of what got me started on working on Proton a little bit more, because I wanted Warframe to work, and Warframe had some problems with 64-bit audio. And so I kept reporting issues with it until, I mean, it had problems with DXVK too, but eventually I kept reporting and reporting and reporting and getting those things eventually fixed. And thankfully, F-Audio, once it was in a very good, usable state, many distros picked it up and started finally shipping it, which was great. And then on top of that, Wine implemented it like directly into Wine as a new audio backend replacement. So F-Audio has been awesome since then. We're happy with it. It's been a blessing. Let's see here. So there's a couple of other audio components. The way that the audio portion works is it goes through F-Audio, and then from F-Audio it gets passed on to the system's audio handlers. Well, it gets passed on to SDL first, and then it goes to the system's audio handlers, such as ALSA, Pulse, Pipewire. There are also other components beyond X-Audio that Wine still translates directly and sends directly to those other ALSA, Pulse Audio, or Pipewire. However, X-Audio is the main component that's used in most games. Wine translation layers for controls, controller inputs. Generally, Proton specifically uses SDL as backend. Generally, controller API calls are translated from Wine to the open source SDL library, which then passes the calls to the device and the driver. This is also how the Steam overlay is able to set controls via SDL. In addition to the default SDL backend, Proton has been patched to allow a few specific devices to use high draw rather than SDL for better performance, such as Sony controllers. On top of the input and exput, Windows Gaming Input API has also been implemented into Wine. Native APIs and Wine. We've got, as mentioned, if a game uses a graphics or other API that is native to Linux, Wine has no need to really translate anything, at least nothing major. It does have some code that it uses, but nothing that causes any kind of crazy amount of overhead or anything like that. Open source APIs such as OpenGL, Vulkan, OpenAL, SDL, and so on can have their API calls passed directly from the game through Wine to the libraries that handle the calls without any such major translation layers needed. There, like again, I said, there's some minor stuff that happens there, but nothing too crazy. Gaming-specific features. You know, these are things that a lot of gamers are really, really adamant on having. The new features that come out for various different graphics cards, different companies that have them. FSR, DLSS, XESS. Regarding FSR in particular, I get this question all the time because there's now 3 iterations of FSR. They want to know if the newer versions of FSR can be implemented in Wine, and that's a no. The reason for that is the first version that we had, it allowed to be implemented without being inside the game. With FSR 2 and 3 and further versions, they have to be implemented specifically within the game. Also with FSR 1, the original scaler for FSR 1 was supposed to be a patch for Wine. The original creator of that patch set, he then decided, okay, we're going to move this over to GameScope instead. So that's why GameScope has FSR compatibility. What we did with Proton GE was we kept that patch set because at the time, some people did not want to use GameScope. They wanted to be able to still use FSR, but not use GameScope for whatever reason they had. Maybe they had an older system. Maybe they were afraid of input lag or whatever, or overhead. Regardless of that, there aren't really any input problems now with GameScope. It did have some in its early life, but now it's pretty much had most of that ironed out, and GameScope has been awesome. NVIDIA DLSS is the same issue with FSR 2.0 onward, except for DLSS has never had a specific patch set. It's always been in-game only, but it does work. Intel XESS is, again, the same. It has to be implemented in the game, but it does work. Adaptive sync and variable refresh rate. This is aka FreeSync, VRR. FreeSync currently works on Wayland for AMD and Intel GPUs using the open source Mesa driver stack. For desktop usage, this also depends on what desktop your environment you're using. In KDE, this is implemented. In GNOME, there's a long-standing merge request that is still being worked on. It's a constant work in progress, and it's been pending for like 2 years. But it is something that people have been really, really pushing to try and get into GNOME. Let's see. NVIDIA G-Sync on Wayland. It's currently implemented in their recently released beta driver, if anybody's been trying that. There have been some problems. They're still working on it. I know they're working really hard to actually try and get that working in Wayland. It's been trouble, but it's good to see that they finally at least brought it forward and they're trying to get it working. Resizable bar, smart access memory, that works. That's worked for probably maybe 1.5 to 2 years now. That's been awesome to have, especially with the new, well, not new now, but the Intel GPUs that came out that heavily rely on it. But yes, resizable bar works. Ray tracing. Ray tracing has been a pain point for a lot of people because they have cards, especially, well, not so much on the NVIDIA side. The ray tracing has worked on NVIDIA's GPUs for whatever drivers they're using. But on the Mesa side, it's taken a while to get there, but we are finally getting around to it. We do have games that are performant with ray tracing and generally work pretty well. I personally, Doom Eternal works great for me for ray tracing on any decent end GPU from the AMD stack side. So I'm actually personally really happy to see ray tracing. I know some people don't really care for ray tracing. They'd rather have like the high FPS and the performance rather than seeing the cool graphics, but sometimes you get those games that just look really freaking cool, and you want to see the ray tracing in it. Okay, so the full screen hack. Full screen hack is something that's been in Proton specifically. You won't find this in normal Wine. It's also in WineGE because we base off Proton. What this does is it takes the resolution for some of the older games. Say you have a game, for example, this one is Age of Mythology, and it runs, by default, it runs in 1024 by 768. If you were to open this in normal Wine, or you didn't have a full screen hack, and maybe you weren't using Wayland or something, it would skew the screens, skew the resolution so that it's stretched and look weird. You don't want that. It's going to look weird when you're playing. It messes with the mouse input. So what the full screen hack does is it is able to take those resolutions and properly render them to whatever aspect ratio your screen is, and it just gives you, your black bars on the space that's not used. So that way you can play the game properly, it still functions properly, your mouse is working properly, and the game is displayed as it's originally intended without any weird skewing. I've got 3 minutes here. The Steam runtime. So the last piece of the puzzle is Valve's Soldier and Sniper Steam runtimes. When Proton runs a game, it runs it in a custom container environment that Valve has developed called Pressure Vessel. This is similar to Docker in the fact that you can mount the runtime containers in Docker. The reason this is done is because it allows distro-agnostic experience, meaning the same libraries are used for running Wine and Proton components within the container, preventing breakage that would otherwise be caused by a versioning difference across different distributions. For example, glibc. You might, if you're running maybe Fedora or Arch or a distro that generally keeps glibc up to date, you might have like version 2.34, 2.35, 2.36, which is fine, but if Wine was built on 2.36 and you're running a distro that's running 2.31 glibc, you would hit a problem where Wine can't run because it's expecting a newer version of glibc. Steam Runtime solves that by running it, and it runs a specific glibc translation within the container that Valve have developed. It's really, really cool. We do something similar in WineGE. It's not nearly as advanced as that, but we do build on, well, WineGE, we use a container that's based off of Debian 11, which ships with glibc 2.31, and that allows a lot of the games to Wine itself to basically run on the newer distros that have a version newer than 2.31. It's still kind of a pain point because we're still going to get people that maybe they're running an ancient distro or haven't upgraded them forever and they have a version that's older than 2.31. But for most people, that's how we resolve it outside of Valve's Pressure Vessel runtime. Anti-cheat. Anti-cheat's another big one. So while the anti-cheat has been a consistent pain point for many games, Valve has implemented bridges for 2 of the major anti-cheat technologies, Easy Anti-Cheat and BattleEye. And yes, they spell it like that. I don't know why they took the extra E out of Battle. Ultimately, this is up to the game developer to reach out to EAC and or BattleEye to enable compatibility with the bridge in order for it to work. That's a hit or miss, and it's this is a pain point because now you even think, okay, well, we have the bridges there, it just depends on the developer, and some developers just really, for one reason or another, decide not to turn it on. For any developers that are out there, we hope that you please consider. It would be amazing to be able to get games running like that on Linux. We do have some great examples that are already working. We've got, obviously Apex Legends, Halo, the Master Chief Collection, New World, Arma 3, DayZ, Division 2, lots of them. There is a website, Are We Anti-Cheat Yet? This is basically an anti-cheat tracker to see what kind of anti-cheat different games use and what their status is, if they've enabled it on Linux or not. It's a really good resource for checking that. Game compatibility. Besides the anti-cheat, you can check most games if they're compatible through ProtonDB. For new users, this is really a kind of a useful tool because it'll tell you if a game works out of the box or if it has maybe different, maybe it needs some tweaks, maybe it needs a specific Proton version. It's really, really helpful, especially, again, for new users. And I'm sorry, we're running out of time here. I think these are the last slides I have anyway. We do have different places for bug reports. This is for mostly outside of wine. If you could, if you're interested, again, look into those components, figure out which ones you need, and try to use these different URLs for all the different specific bug reporting. And that's it. That's the end. Wow, right on time. Thank you very, very much. I appreciate you guys' time and appreciate you coming out.
All right, thank you. While the next presenter sets up, I might have time for one question, or one question, quick one.
Hi, Proton maintainer here. It's actually a couple of corrections more than a question. So first thing, I think it's an unfair characterization of Wine D3D that it's application-oriented. That might have been the case back in the days, but now they care about games as well. If you look like the recent version of Crossover, basically the main thing that they advertise is running Diablo 4, running Cyberpunk 2077. Damavand is in really good shape for DirectX 10 and 11, not so much for 9 yet, so maybe when that happens it will be enabled for default, by default. So that has changed, and there's like a different philosophy that comes to the developers, but that's basically it. And also runtimes are using your system glibc if it's newer, so it picks it automatically. That's it.
That's Eric, everyone. Thank you very much.
All right, next on is not. And I'm sure if you have any questions, you know how to find our speaker. Next on, as I was saying earlier on, we're in one of the birthplaces of silicon, even though people don't usually associate Riga with silicon. There's actually a rare thing in Riga. There's actually a foundry. So if you want silicon chip baked, you can come to Riga. There's a factory to do that for you. I don't know if anyone here is from Riga. Can you confirm that? Oh, I looked that up. I didn't go there, but I looked that up. Okay, we'll have to settle that debate. I'll let you search, I'll search, we'll compare notes, and then we'll see. I think we're almost good on this front. Anyone here familiar with RISC-V? Anyone here not familiar with RISC-V? Well, a lot of people have no opinions. So we're going to have to do it again. Let's do it again. Anyone here familiar with RISC-V? Yes. Not familiar with RISC-V? Anyone not opinionated? All right, John, floor is yours.
Okay, can everyone hear me? Yes, great. Good afternoon. It's great to be here in Riga. My name is John Ronco. I lead segment marketing and strategy for Sci-Fi, and I'm going to talk to you about the RISC-V revolution. I have been involved with the RISC-V community for about a year. But before that, I was at ARM for many, many years, and so I was watching RISC-V very carefully from the sidelines, including at one point leading the competitive strategy team at ARM, working out what do we do about RISC-V. And as the saying goes, if you can't beat them, join them. So here I am now. So what is RISC-V? So RISC-V is an open standard instruction set architecture. So the ISA is a critical part of any chip. It's the interface between hardware and software, and so therefore it's a really important part of what you do. Now, today, the dominant ISAs, x86 and ARM, are proprietary, so they're controlled by a single company, and that is holding us back in terms of what we need to do in the computer industry. So as Moore's law has ended, and as the rise of AI is happening, there's more and more innovation that we need to do in terms of, in order to deliver the performance that we need from chips in the future. And the proprietary solutions are holding us back. And so RISC-V is changing all of that in terms of what we're offering with the open standard. Now, Open standard interfaces are an accepted practice within the computing industry. You can see a number of these areas here. There has been, in the past, there's been proprietary solutions, but gradually an open standard has taken over. And that open standard enables both open source implementations and commercial implementations. And it's a range of different possibilities, but all based off that same common open standard. And the fundamental question is, why should an ISA be any different? And the answer is it shouldn't. There's no reason why an ISA should be any different to these other interfaces, and therefore an open standard model is inherently a better way forward. Now, if we look in a little bit more detail of what this means in terms of the business models and in terms of what you can do about it, here are kind of like the three main instruction sets that are out there. So firstly, with x86, it's pretty closed. You can get a chip from a couple of different vendors, but if you want to build your own chip that supports x86, you can't. If you want to build your own CPU, you can't, and you certainly couldn't build something open source based off x86. With ARM, the situation is a little bit better. So the nature of the ARM business model, the fact that they license the CPUs to many, many different chip vendors, means that you have a choice as an end device maker. You can buy chips from lots of different people that support ARM, so that's a good thing. However, if you want to design your own ARM CPU, that's really expensive. And as Qualcomm has recently found out, it's quite restricted in terms of what you can then do with that technology when you've designed it. And if you want to build a chip that supports ARM, then you only have one choice. You have to go to ARM. You have to go license a CPU from them. And if they're not building what you want, that's a problem. You haven't got any other options that you can have. But with an open standard with RISC-V, you can get everything. You can have many different chipset vendors building chips that support the RISC-V standard. If you want to design your own CPU, you can. Effectively, it's an open standard, so it's free and available for everyone to use. If you want to license a commercial core, then you can, and there's multiple different companies that are providing commercial IP that supports RISC-V. If you want to have an open source core, you can. There are also implementations of open source. And if you want to evolve the product, if you want to add instructions, if you want to customize what you're doing, these things are all possible because of the open standard nature of RISC-V. Now, you might be wondering why it's called RISC-V. And the slightly dull and disappointing answer is because it was the fifth design that came out of the University of Berkeley. Berkeley, through Dave Patterson of Patterson and Hennessy fame, pioneered a lot of the work around RISC computing in the early 80s, and they did several iterations of a RISC standard. And then for a couple of decades, they focused their research around commercial available products. But then in about 2010, they decided that that wasn't going to cut it. It wasn't enabling them to do what they needed to do to do research and innovation on the future of computing. And so they decided to develop a clean slate instruction set architecture and then to open it up. And the key people involved, you can see Andrew, Yunsuk, David, and Krista. And then that has then become released and made public in 2014, and it's gone from strength to strength in terms of the adoption and an enthusiasm behind it. And again, it's all based on the fact that it's this open standard model which is driving adoption. So who are Sci-Fi, or who do I work for? So Sci-Fi, the three of the guys, except Dave, so Krista, Andrew, and Yunsuk, once they'd released the open standard RISC-V, formed a company, Sci-Fi, with the goal of developing commercial implementations of RISC-V CPUs. And today, we are the largest vendor of commercial RISC-V CPUs. Our business model is basically the same as ARM, in the sense of we license CPUs, and it's a mix of upfront license fees and then royalties per device shipped. But the critical difference here is that if you don't like what we provide, you can go buy from someone else and be compatible with the software. So you've always got choices. You haven't got that vendor lock-in. In terms of Sci-Fi, we've got over 350 design wins, and that's with some of the biggest semiconductor companies in the world, including Qualcomm, Samsung, Google, Intel, Renesas, Microchip, long list of companies who are working with Sci-Fi. And actually, you probably may not know this, but you're likely already using RISC-V in some way, shape, or form.
if you have a phone that has a Snapdragon processor from Qualcomm that has RISC-V CPUs inside it. It's not the main CPU running Android, but it's one of the CPUs that are sort of controlling the system and managing the overall SoC. And there's lots and lots of devices that are using RISC-V already. We don't actually know for sure because a lot of this is going into different places and different people aren't reporting, but the estimate is there's tens of billions of CPUs, RISC-V CPUs, have shipped in devices. So pretty much anything that's a deeply embedded application, a lot of those have already moved to RISC-V or are moving to RISC-V. And what's exciting is that we're just getting to that phase where RISC-V in CPUs that are user programmable is just starting to happen. And so we're going to see a big increase in that over the next couple of years. From a software ecosystem point of view, there's been a big, big growth in the software ecosystem over the last couple of years, and the support from different vendors for what we're doing for RISC-V. One I'd like to particularly call out here is Android. So Google announced about a year ago that they were going to make RISC-V a first-class citizen, first-class architecture within their releases. And they said that Android 15, which is released next summer, is going to have full support for RISC-V. And they've just published a blog a couple of weeks ago saying that they are on track for that. So it's all going really well, and the support is there, and they've started to release certain builds with it available to developers. Yeah, so it's going according to plan there. And I don't know if you saw, but a couple of weeks ago, Qualcomm and Google announced that they were working on a wearable chip based on RISC-V. So future Wear OS devices using the Snapdragon Wear platform will be running on RISC-V, which is super exciting. But it's not just Android. That's just one example of many different open source projects, many different software, commercial and open source, which is building support for RISC-V. As you guys will know, this is a marathon, not a sprint. These things take a lot of time to mature, but we've seen really kind of rapid increase in adoption over the last couple of years. On that note, actually, I wanted to touch on a new organization that was announced earlier in the year. This was the RISE organization. So this was a new consortium that was established to drive, to accelerate the work on open source software supporting RISC-V. And this wasn't just formed by companies like Sci-Fi that have a vested interest in RISC-V being successful. The founding members included Google, Qualcomm, Samsung, Intel, MediaTek, and NVIDIA, who are all basically saying, right, there is a goal here to make commercial-grade open source software on RISC-V. And this is, and the focus here is very much on the high-end processors. As I said earlier, RISC-V has already established a really strong space in embedded processors and microcontroller type devices. And this is really about saying, okay, devices that run Linux, devices that, the high performance compute devices, how do we make sure that commercial grade software is available for those devices? And that's what we're doing through RISE. RISC-V International, so riscv.org, that is the standard setting body. They are still very much responsible for all of the instruction set, the extensions, all of the standards around RISC-V, are managing the overall community, because there's lots of people involved in RISC-V, from academia through to commercial, from tiny microcontrollers to supercomputers. And the RISC-V International are very much responsible for managing that whole. But RISE is very much saying, okay, how do we make the Linux-based open source software commercially ready to be deployed on RISC-V devices? And so that's super exciting. And there should be an announcement next week about what Canonical is going to do on that one. I don't want to preempt that too much. So that's the organization. Now, one of the great things about RISC-V is it enables innovation. It enables you to create new instructions and to innovate and to do different things. And some of the detractors of RISC-V at this point will turn around and go, aha, that means that you're going to have a fragmented mesh. You're going to have lots of different products, and it's going to become unmanageable. and that's not good. Now, the answer to that is it won't happen, and I'll explain in a minute why we can ensure that fragmentation doesn't happen. But before I get to that, I think it's really important to understand the difference between fragmentation and diversity. So fragmentation is the same thing done in different ways. So nobody benefits from the fact that the British drive on one side of the road and everyone else in Europe drives on the other side of the road. It just adds pain for vehicle manufacturers, it adds confusion for tourists. It's generally not a good thing. It would be better if we were all on the same side. In the same way, in the instruction set domain, there is no benefit in having two different ways of encoding half-precision floating point instructions. That will not help anyone. You have to have a single way of doing these things to make life easier for everyone. So that's an important thing. Diversity, on the other hand, is solving different problems. So a 747 and a bicycle are both forms of transportation, but they both have very different purposes. In the same way, in an instruction set world, you have 32-bit instruction sets, you have 64-bit instruction sets, you have 64-bit instruction sets for real-time processors, you have 64-bit instruction sets for high-performance servers, and having those differences make perfect sense. You get that with the legacy architectures like ARM and x86, and you get that with RISC-V as well. So diversity is a good thing, but avoiding fragmentation is critical. So how are we avoiding fragmentation as RISC-V? Really, there's two fundamental reasons. Firstly, nobody wants it. So everyone realizes what fragmentation will cause. Nobody wants a vendor lock-in. So if Sci-Fi comes up with some unique way of doing something that other people are doing in a different way, our customers are going to tell us they don't want it, because our customers want to have a single software base that they know that they can reuse across different implementations. And that's the second point, which is software. So investment in software is expensive. Nobody can afford to do all of the software themselves. That's why we have the whole open source movement. And in that context, you need to have a common baseline. So all of the open source projects are very clear that they only want to accept and upstream patches that apply to ratified standards. They don't want random extensions being included in the code base. They want to make sure that everything is based on the kind of like the ratified standards. So that's kind of like how fragmentation is going to be stopped. In terms of diversity, in terms of what we're doing there, then with RISC-V, you get a base set of instructions in terms of like the basic things that you need to do in a CPU. And then you have a whole load of extensions that are for specific functions. So maybe vectors or half-precision float or whatever. And then you have also, in addition to that, you have the opportunity to create your own custom extensions to do specific functions. Now, you can combine all of those in many, many different ways, which gives you a huge number of options. And that's great. And for embedded, that's kind of okay, because if you control the whole software and hardware stack, you can do what you like, and it's not a problem. But when you're trying to do something like a Linux distribution, you kind of need a bit more commonality. You need a bit more kind of like a consistent baseline that you're working with. And that's where the ISA profiles come in. So the ISA profiles are basically a standard set of extensions that are being defined by RISC-V and saying, right, these are the baseline that if you want to build a product that's for a Linux distribution, this is what it should look like. And that will evolve over time. So there was an RVA 20 version, there's a 22 version, a 23 version, and so on. So in the same way that others ISAs evolve over time as more capabilities get added, you expect to see the same from RISC-V. So the fact that these instructions are there is a really kind of good kind of common ground for everyone to work to. But then on top of that, you have, it's not just about the instruction set. It's things like how does it boot? How do interrupts work? You need a certain degree of commonality. And that's where the platform standards come in. And that's what work is happening now within the RISC-V community to specify, okay, beyond the ISA, what is it that is important? And this is very, if you're familiar with what ARM's done around System Ready and SBSA and those kind of standards, this is a very similar kind of concept, but for RISC-V. As an aside on this point, actually, I was having a chat to Mark yesterday, and we were talking, actually, wouldn't it be great if Ubuntu just works on every RISC-V platform, but also has the capability to automatically take advantage of any of the extensions that are available, any of the advanced features that are included in the products. And I think that's a really good vision. I think we want to get to the position where Linux distributions and software just work on any RISC-V platform, and you don't have to do a whole lot of a heavy lift just to get the software up and running. But then we also get to the point where we can take advantage of the diversity that exists. I'm not going, in the interest of time, I'm not going to go too much into the details of the ICEs, the extensions that have been ratified recently. This is just a snapshot of some of the things that have been ratified in 23. I think the main takeaway here actually is that RISC-V is now maturing. So the set of extensions that are now available are pretty comparable to what you might get from a legacy ISA in terms of the capabilities in the device. So if you take what's in, say, RVA22, so the RVA22 plus the vectors and the vector crypto, that has been, as an example, that has been defined by Google as the baseline for Android. So they're saying that is what we believe is the competitive baseline that we need in order to be able to do a commercial Android device. And so that is what is now kind of been focused on as a good baseline. And I think the same will happen around the Linux distributions as well in terms of saying, right, what is the baseline that we want to support going forward as a competitive platform? Now, I'm sure some of you at this point are saying, oh, that's all great, this is all nice in theory, but where's my hardware? What can I get hold of? And the simple answer is that there is some hardware available today, and more is coming. On this slide, you've got a couple of different boards. You've got the Hi5 Unmatched from Sci5. That has actually been unavailable for a few months, but we've just got a new batch of them coming in, so that is now going to be available to order again. You've also got the Star 5 Vision 5 and the Polar Fire from Microchip, which also use Sci5 cores. But it's not all about Sci5. You've got the All-Winner core at the chip at the bottom that uses a core from Alibaba. And again, part of the benefit of RISC-V is that there's a diversity of supply and different vendors doing different things. What unites all of these cores, though, is that they all have Ubuntu support. So 2310 is available to download from the Ubuntu website for all 4 of these. So if you want to have a play, then go get a board and download the code. In terms of what's next, we have the Hi5 Pro P550, which we're going to be demoing next week at the RISC-V Summit, running Ubuntu on it, and that will be available in early 24. And then we have 2 more boards coming out from our partners, Eastwin and SoftGo, who are doing chips that will come out later in 24 that are going to be compatible with the Android baseline that I mentioned, so RVA22, and include a vector processing and vector crypto. So we're really excited about both of those. And then lastly, just a note in terms of Ubuntu and RISC-V. This community has been super, super supportive of RISC-V, so thank you to you all for that. It's been great to see what's been committed over the last couple of years. Ubuntu was the first distribution to support RISC-V in 21. As I mentioned, we're going to be shipping the P550 with Ubuntu pre-installed, and there's been a really strong engagement from the Ubuntu team and ourselves, but also with the wider RISC-V community, so that's been great. If you want to know some more technical details about where we are now and how to work with RISC-V on Ubuntu, how to work with Ubuntu on RISC-V rather, then Heinrich is going to be giving a talk in about an hour and a half's time, which I would encourage you to go to. Okay, so yeah, just to wrap up, I mean, the momentum behind RISC-V has really got to the point where I think it's unstoppable. And we will have the best processors, we will have the best ecosystem, and RISC-V will be present in every market that you can imagine over the coming years. The reason this is inevitable is not because the technology is that much better, although in some ways it is. It's fundamentally down to the open standard nature of the business model, which is driving demand from across the industry who really want to see RISC-V widely deployed and successful. So, thank you. Come and join the RISC-V revolution.
Any questions? Microphone is coming this way, and then next question will come here and then over there.
Thanks. So what attitude do you have towards the possibility of whether there is lock-in through diversity. And what I mean by this, if you look at the early IBM compatibles, they all had like different standard modes, and Hercules and CGA were shipped by IBM by default, but if you then went and bought a 10D, then you were able to play on a cheaper machine like the better 10D graphics modes, and you would want to continue buying 10Ds to not downgrade. Is there a danger of this kind of vendor lock-in you're seeing with making extensions so like readily accessible for hardware manufacturers?
I mean, I think it's always a possibility. I mean, the nature of the way RISC-V is working means that there's more things happening, and people are more free to do different things, which means you're not controlling it in that way. I think, as I say, there's powerful forces that mean that people don't want that. And the work that we're doing in RISC-V International to try and sort of define the platform standards and then align the distributions around saying, okay, this is what is supported, I think will help a lot. Google, for instance, have said they're never going to support less than RVA22 vectors and vector crypto. They're saying if you want to go do it yourself and you want to go build a random Android build and hack it onto earlier hardware, then that's fine, you can do that, but it's never going to be supported in mainland Android. And so I think it's that kind of desire to avoid that which will prevent it. But you're right, it's not, because RISC-V is not controlled and managed in a way that others are, there's always risks of that, and I think we just, as a community, we need to be careful to make sure that we don't add unnecessary blockers and barriers to innovation.
Thank you.
There. So, hi, all right. Yeah, so I liked how you mentioned that like RISC-V is kind of making its way from like microcontrollers up into supercomputing. And so one thing that I did want to ask was like, have you seen a lot of demand from like these HPC institutions to use RISC-V? Because I know a lot of places are still, running these traditional big x86 machines. So I'm just kind of wondering, what's the demand look like, and how do we incentivize more institutions to kind of shift towards this architecture?
So we're seeing huge demand, actually. So maybe not necessarily sci-fi, but RISC-V as a whole is seeing huge demand. And I think the reason for this is that a lot of the particularly national sponsored initiatives are very sensitive that they need a long-term strategy. And so that's what RISC-V gives them. It gives them that long-term strategy where they're not going to get locked in, and they're not going to get restricted, and they're not going to run into export control issues. They can control their own destiny. So, I mean, pretty much anyone who's investing in HPC is investing in RISC-V, I would say, and it's just a question of how long that takes and when you're going to start seeing things. But within the RISC-V community, the HPC special interest groups are a really active part of that community.
That was a very politically correct answer.
Over there.
Yeah, come and see me afterwards if you want the unpolitically correct.
Hi. What would you say was or is going to be the tipping point for RISC-V adoption? Is it one of those extensions that were just approved, maybe the crypto or vector? It feels like there were a lot of extensions approved in 2023. Are we in a turmoil right now, and will this stabilize, or how do you see it?
No, I think actually there's a lot of stuff that's been happening over the last couple of years, kind of to catch up. Do you know what I mean? So to make it, as I say, to get to a position where, from an instruction set point of view, what we have is comparable and competitive with the latest from other vendors. I think in terms of a tipping point, I mean, it feels to me like it's very soon. It feels like there's been a big increase in momentum over the last couple of years, and the news flow in terms of people committing to it is getting increasing. I think it's one of those things. As I say, I spent many years at ARM, and I was looking at ARM servers for many, many years. And there was years and years and years where everyone was saying, it's not going to happen, nobody's ever going to do it. And you had these failures, and you go, well, they failed, it's never going to happen. And then suddenly it happens. And now we're in a world where some analysts are saying, right, 50% of the server market's going to ARM. RISC-V in what I would call the apps processor, the Linux market, is going to be the same. Do you know what I mean? It's going to suddenly reach a point where devices are out there that are good, and people go, okay, right, this is now a viable option, we're now going to move. And that, what triggers that is hard to say, but you can certainly see that happening over the next couple of years.
Yeah. So I like RISC-V, but if I was doing my job, I would have never heard of it, because I'm writing Python.
Yep.
At the most, if I'm writing something in lower level language, I just say, oh, cross-compile to this architecture. Should I know about RISC-V, like from the ISA, from the assembly code? Is there something interesting there? I mean, is it fun there to look there? Hey, later on, stop writing Python, directly write the RISC-V assembly?
I think it depends how you like to spend your weekends, whether it's fun or not. I mean, I think that part of the way, so at one level, no, I don't think you need to care. Do you know what I mean? If you're writing Python, other people will care about a lot of these things. But I think back to what I said right at the beginning about the end of Moore's law and the rise of AI means that increasingly we're going to have to think more carefully about how hardware is architected and how software and hardware work together in order to drive performance. So yeah, at a basic level, the RISC-V instruction set, it's just an instruction set. It's not that exciting. But it's what you can do with it and what you can do with it in terms of hardware-software co-design that I think will become very exciting in the future.
So one question at the back there, then go to the front, and then we'll go for break.
Do you know anything about the mainline Linux kernel support? You mentioned Android and Ubuntu from a certain version number, but is that is that on top of mainline Linux? They're doing their own customizations,
yeah.
Or is it?
Yeah, no, it is. I mean, I think so. What you see is that pretty much all major open source packages, including Linux, have increased support for RISC-V over recent years. The finer details of that, you come and have a chat to me afterwards. But yeah, just in principle, it's not something Canonical is doing independently. It's part of a broader move with support across all of the Linux community. And it's just Ubuntu has been really positive in terms of releasing distributions for specific hardware. Hello.
Hi. With profiles building on profiles, what's the balance between leaving old hardware behind and risking that RISC actually becomes CISC?
It's a good question, actually. So I guess in terms of leaving stuff behind, it's always a balance, isn't it? So if you look, say, in the ARM world, ARM adds new instructions every year to their architecture. But from an app developer point of view, app developers are stuck on kind of a 10-year-old ISA because actually you can't migrate across because you can't leave a whole load of apps behind. So it's a delicate balancing act in terms of that. In terms of your question about RISC becoming more CISC-like, yeah, that's an interesting angle because as we add things like vector instructions, matrix instructions, add more capabilities into the device in order to try and drive that performance, these things are getting more complicated, but fundamentally RISC-V starts from a cleaner position and is therefore probably better placed to deal with some of these challenges as we go forward. We haven't already got 20 years of legacy built into what we're doing. In 20 years' time, we will have that legacy problem, but we're in a better starting position for where we are now.
All right, so before I let you go, anyone here who's involved in actually porting Ubuntu or Linux to RISC-V? Heinrich is there, and so there you go. You know who to go and talk to. If you actually, both of you could stand up, maybe so that everyone knows your face and can come and talk to you if you're interested. There we go. You have 3 people there. John, that was amazing.
Thank you.
Nice the break for tea and coffee. You can still go chat with John. We'll start again in 30 minutes. Look forward to it.
days of the early sun, when the world was fresh and young, and the summer was nearly done. The nights were short and the days so long. I can see you in this pitch black night, with my eyes closed and I turned out right. On my knees I clutch my pillow tight, I beg forgiveness from the good and right. Oh, crazy, crazy thing that you once said to me. How would you say you love me and then turn your back and walk away? Many's the day we walked alone, you and I chilled to the bone. Life hung heavy in our tortured souls as we battled to gain control. A crazy, crazy things that you once said to me. How would you say you love me and then turn your back and walk away? All about me, it's changing ways. These old ideas have turned to clay. No damnation, no penance to pay. There will be a judgment day. When the final call would come, nowhere to hide, nowhere to run, I'd stand alone, alone with him, saved by faith or damned in sin. A crazy, crazy thing that you once said to me. How would you say you love me and then turn your back and walk away? How would you say you love me and then turn your back and walk away? Darwin, evolution, Big Bang, strength. Those books are around in the classroom now, and they won't go back in no way, no how. You just might be right by me now. I could see their ways were set, no place where we could have met. A twisted knife or an unpaid debt. I never got to express my regret. Darwin, evolution, Big Bang, string theory. Those books are around in the classroom now, and they won't go back in no way, no how. You just might
Okay, we've assembled everyone. Christopher, the floor is yours.
All right. Greetings, everyone. By the way, let me just start by saying that this is not my joke. Okay, I've asked ChatGPT for it as an icebreaker. I've asked multiple times. This was the best I could get. I know it's not good, but it kind of makes the point. We are going to be talking about security in distroless containers. So before we get to that, just for you to get to know me, my name is Cristóvão Cordeiro. It's quite a mouthful, so you can just call me Chris. I'm an engineering manager at Canonical. I've been doing cloud and edge computing for quite some time now. And for the past few years, I've been doing more and more around containers. And the thing that I got puzzled with and why we are talking about this is that there's like a common shift towards distroless containers. And I don't know how many of you here actually know what distroless containers are. Can I get a raise of hands, like a few people? All right, so that's good. That sets the ground. But there's a sort of misconception around security and distroless, and that's the thing we are going to cover today. And it's mostly because the foundation between what people select, what people think about when selecting a container, like if you are pulling something, or pulling an image from Docker Hub or ECR or ACR, usually people tend to think about security. That's their topmost concern, is that if I'm going to pull something out of there, whether it's distroless or not, I want to make sure that that thing will not compromise my production infrastructure, right? If I run it somewhere, it should not become a liability. So that's the topic today. Let's look at distroless containers and how, if you don't do them right, they can become a sort of security abyss. They can become like a black hole for hidden vulnerabilities. Now, there's this very cool study that, well, it's actually a report, and I'm kind of using a few numbers from that report. It's from Resilient. You will find the link down there. And they have done something quite nice, which is they have performed a study about scanning the scanners. Right? As you know, for container images, it's very common that we will use third-party tools to kind of scan an image to know if there are vulnerabilities inside that image. The thing is, you are trusting a tool to tell you whether your container is secure or not. So these guys they did a whole study. They picked up a few scanners and kind of tried to assess how they behave when scanning images. And one of the cool numbers that I found interesting for people that might be thinking of vulnerabilities, as long as I have the latest and greatest base image, if it is secure, my image will be secure and I can just sleep tight for the next few months or whatever. In 2021, there were more than 20,000 vulnerabilities added to the database. That's a lot. And the study itself, the report, what it did was, first, they cherry-picked 20 of the most popular container images. I think it was in Docker Hub. Then they cherry-picked nameless, to avoid any bias or pointing fingers, but nameless tools, 6 vulnerability scanners, which, by the way, when scanning those 20 images, they all reported different results. That's already a good start. Then they actually found that throughout all the results, there were more than 450 vulnerabilities that were high and critical that were misidentified. Now, misidentified can either mean that the scanners said that there was a CV when there wasn't, or the opposite. They said that everything was okay when it wasn't. So, and the latter is what they call false negatives. One of those tools actually reported more than 16 false negatives per container that it scanned. I mean, this is like, just think about it. It's like if you have a container and the scanner is saying everything is fine, when in fact you have 16 vulnerabilities inside. Putting all together, the report says that 82% average precision for all the scanners, which means 80% of the results were false positives. So 18% of the results were basically saying there's something there when in fact there wasn't. Okay? To be honest, we can live with this, right? It's bad, right? It kind of misrepresents your container image, but you know that your container does not have that CVE, so that's fine. What's worse is a false negative, right? That's the hidden vulnerability. And 70% of the results, around 73% of the results, amounted to the actual reality, which means the rest were unidentified, and that's what's bad. So why did we get these results, or why did the report showcase these results? So their conclusion is that first, there is variance in the scanners. So not all scanners support the same ecosystem. Some scanners might have better support for things like Golang or Rust, and others don't. So right there, you have a discrepancy. Then there's also a question about the surrounding environment. Let's not go too much into this because, yes, it matters where you build and where you run the container. Because since the container is sharing the kernel from the host, if the host is compromised, what does that mean about the container? But let's move on. One important thing is also context, right? Let's say you have an application. Your application most likely will require some sort of configuration. So a CVE sometimes might only exist under certain conditions. And what these tools and scanners will actually say is that, do you have that application? Therefore, you have a CVE. When in fact, the way you are running that application might not actually be exposing your container to anything. Then we have false positives, which are commonly driven by the use of CPE, which is a common notation to identify the software and versions. And they use this as a sole identifier. The thing is that this identifier can be quite limiting. And again, it can cause the scanners to say, oh, do you have that? I can see that package has vulnerabilities, therefore you have vulnerabilities. And again, they are ignoring context and the surrounding environment. But the one I want to talk about is actually the last one, which is the ability to detect software that is not managed by package managers, right? So the thing here is that when we get into Distroless, for those who know it, and for those who don't, I'll just give you a quick definition in a couple of minutes. If you don't have a package manager, you might be missing the necessary metadata and necessary context for some scanners to know what you have inside the image. I know it sounds weird, like what we are saying is that, right, so the scanners are trusting the developers to tell them what to do. Surprisingly enough, that's the case for most scanners. I can give you an example. I could have a container image today that has 10 CVEs, and with a single line, I can make a scanner believe that I have 0 vulnerabilities. How? I'll just massage the depackaged metadata, because those scanners will just look into the depackaged status file to get the list of packages I have installed and infer which ones have CVEs. So I can very easily lie, okay? So the whole thing, and this is why we are talking about Distroless, is that Distroless typically does not use package managers because we want to keep those images super small. So the way we build things is a bit different. So these kind of patterns can be identified. And the same report, well, actually a different report of the same study went through GitHub, actually, not Docker Hub, GitHub, and tried to find Docker files with those patterns. And it actually found over 100,000 Docker files with behaviors that are very, very, very prone to result in hidden vulnerabilities. So the problem here, and the reason I'm focusing on false negatives, is because it gives you a false sense of security. You cannot know what you don't know, and therefore you cannot fix what you don't know, right? And again, this is very common in Distroless. Why? Because the usual practice is that you will go from top down. You will start with a bigger image. Sometimes you are even taking a base image that already has vulnerabilities, and then you add your software from different places, remote places, local folders, whatever, things you cannot really trace, and then you end up cherry-picking certain contents into a scratch image without any package managers. And you do this manually, right? When you cherry-pick something manually, it's a recipe for disaster, because it's very likely that you will forget to copy one file or a configuration file, or the metadata required for the scanners to know what you are packing inside that image. So I like to call this a sort of the fallacy of complacent distroless containers. Like, if it ain't broke, I won't fix it, right? If everything is working just fine, then everything must be fine. And if my container is smaller, then I must have less vulnerabilities. Therefore, if I'm distroless, I'm secure, which is not the case. So for those who actually don't know what Distroless is, and I'm using a quote here from Google's GitHub repository, they have a portfolio of Distroless images. It's basically the concept of building container images with just your application and its runtime dependencies, just that. So you do not have package managers, which is fine. You don't want package managers at runtime, but you might want them to build the image. And you also don't have the utilities at runtime that you would usually find in a distro image. So you don't have things like APT, you don't have Vim, you don't have curl, and so on. You don't need those, so why risk yourself? So Distroless is great. I'm not trying to bash on Distroless, but it's only great if you do it right. And yes, there are an excellent alternative to have, instead of having bloated distro images or even small distro images, it's still better to just only have what you need for your application. But it can become a difficult practice, right? There are specialized tools to help you do Distroless, but they can be hard. Some people use very complex multi-stage builds to do this cherry picking and installing, growing an image and then trimming it down. It's a complex process, and it's top-down, and it might require a lot of distro knowledge. Think about it. If you have an application, you are the expert about that application. However, your application has dependencies. So if you are going to cherry pick those dependencies, you need to know what you are cherry picking, which means you need to know what are the devs you depend on and how are they composed, what libraries you need to fetch and cherry pick. So it becomes a very time-consuming exercise, and you must know a lot about the things you are bringing into your image. So the idea here is trying to make Distroless a sort of distroful experience, right? Making Distroless as if it was from a distro. So combining the best of both worlds, such that we can use a package manager to build the image. That would be nice, because then we can profit from all the metadata that the package manager will bring, and we can use the package manager to abstract all the things we don't know about the packages that we depend on. Keep it simple, keep it familiar, ensure provenance, right? It's Distroless, but I still want to rely on a well-trusted base, right? Not some third-party image that I have found in a dark corner of the world. It's something I trust. So it's also stable and supported, has some SLAs and support commitments. And I want to build it from the ground up. All of these cherry picking and bloating images and trimming them down, it's a bit counterintuitive. But keep it Distroless. So this is where Chisel came to be. This is something that is developed. It's being developed. It already exists. You can use it today. It's from Canonical. And as the name says, it is a tool that you can use to kind of sculpt ultra-small Ubuntu images. The way it works is that it relies on the Ubuntu archives. So when you are using Chisel, you are actually installing things from the archives. And I call them things because you are not actually installing packages, not the whole packages. You are installing slices. Slices are portions of a Debian package that are predefined in a declarative way, and Chisel knows about those definitions. So if the package maintainer has said that, well, for my package foo, I have a set of binaries, I have a set of man pages, I have some configuration files, and he decides to split that into 3 different slices, that means that at build time with Chisel, you can say, I only want that slice, leave everything else out, because I don't need it. It can only bring me problems and vulnerabilities, okay? So the bigger picture kind of looks like this. You can start from the Ubuntu distribution that you know, but the ultimate goal is to use a package manager or some sort of a package manager, in this case Chisel, to get from those necessary packages, from that distro, only the bits and pieces that you actually know, only those slices. And very much like any other package manager, those slices can have dependencies between them. They can have scripts as well to kind of try to reproduce the maintainer scripts from Debian packages. So apt installs Debian packages, Chisel installs Debian package slices. I'll give you an example here. Let's take the base password Debian package. If you don't know it, it's where you would get your etc password and etc group files from if you want to do user management. So the Debian actually has 17 files, 2 dependencies, and when you install it, it is around 250 kilobytes of size. On the right side of the screen, you will see what we call a slice definition file. This is the YAML where the package maintainer or any other contributor, this is a community effort, can go and define slices for that package. So there is the data, we called it the data slice. What's inside the data slice? I only need the group and password files, because for my container, I only need to add a non-root user, and so I just need a way for the system to understand what that user is and what group it belongs to. I don't need anything else, right? So we went from 17 files to a functional slice that has 2 files, 0 dependencies, and 40 kilobytes of size when installed. So yeah, you actually don't need it, but this is depending on your use case. Sometimes you might need more, sometimes you might need less. And that's why slices are kind of ever-growing. You can add as many slices as you want. These are not set in stone. Today we have data, tomorrow you might have another slice called config. Or you might have another slice called just user. You just want the user password file for some reason, okay? So the point here is that we want to achieve that nice experience that we talked about before and do it from the ground up, bottom up, right? And keep it distroless. So we want to use a package manager, in this case, let it be Chisel. Simple and familiar, this is a one-liner, right? If you want to know how to use Chisel, it's just Chisel cuts, you specify an empty folder where to install your stuff from the ground up. There's nothing inside that folder. And then you specify the slices that you want to install. That's it. This will construct a file system in this folder, and then you can just copy that file system into a Scratch image, and you have a Distroless Ubuntu image. So yeah, it's Ubuntu, so provenance is ensured, stable and secured, it's supported, so you get the same SLAs, the same commitments, and from the ground up, as we just saw with the ---- root option, you get to an empty folder. It can have something inside, so you can actually overlay. You can run Chisel twice and keep building your system, which is a nice thing, but typically, you can start from nothing and just start installing slices into that folder. I will leave this, I still have a few minutes, so I actually can go through this right now. I'm just giving an example of how you can do this if you want to try it. I'm doing it with a Docker file. I'm using Jammy as a base. Why as a base? So for now, you will still need to get Chisel into your build, right? Today, we are distributing Chisel as a snap, but also in a GitHub release. You will find the binary there. This is what I'm doing here. I'm basically getting the binary from the GitHub release. This experience can be improved and might be in the future. We might think about shipping Chisel also as a container image, which would be nice, because in this case, you wouldn't need any more to fetch it. You wouldn't need to set CA certificates, because Chisel needs that in order to speak with the archives. So, but this is the same for any Chisel image that you want to do. You need to get Chisel, prepare the ground for it, and then here we are creating that Chisel Ubuntu empty directory. And let's install the hello beans slice. So it's the hello package. I don't need man pages, I just want the binary. And the slice itself already has the dependencies it needs, like libc6, for the binary to be executed. So that's all I need. Then from scratch, I'll copy the entire folder that's my file system basically, into the Scratch image. My entry point will be the hello binary. I'll build it here. Well, this is recorded, so it should not take that long. I'm not using our network here. Thank Lord. This is Chisel running, so I decided to keep the cache, to use no cache, just so you could see the Chisel logs there fetching from the archives. And now that I have that image, I can just run it. The hello world as expected, and it's 5 megabytes, right? This is 5 megabytes decompressed. It's the size on the file system. So if I were to push this image to like Docker Hub, it would be compressed to an even smaller size. So I'm about to wrap up, and I just wanted to say that this is all very pretty. I know, well, I work at Canonical. I've been working in the development and conception of Chisel. I don't want to make it sound like I'm selling snake oil or something. There's no such thing as free lunch, if you were wondering what that meant. You will still need to choose a scanner that fits your purpose, right? There are still things that Chisel will not do for you. Chisel will get you those packages slices, but what about your application? You'll still need to compile your application, maybe bring some additional dependencies from your own repositories. That's fine, but just make sure you choose a scanner that accounts for those. And avoid dead drops. Sometimes it's not possible, but very often you can do it without kind of dropping something from a remote place that has no way for us to keep trace of, and therefore scanners will have no way of knowing whether that specific content has a CVE or not. So just avoid dead drops. Try to build things through the official channels, devs, or packaging processes that have proper provenance and proper tracing that scanners can look into. And if you cannot always avoid dead drops, think about complementing the package manager's metadata such that the scanners know about what's inside your container image, even if it is Distroless. So think about shipping an S-spawn with your image. You can construct an S-spawn. And OCI actually supports OCI artifacts. You can now shift additional files, text files, alongside your image and tell those scanners to use the S-bomb instead of trying to infer what's inside your container from its contents. Otherwise, you can also try to massage the metadata that the build system gave you. Like if you have, again, deep package status metadata or some other stuff, try to see if it is complete enough for the scanning tools to pick up on what's inside. Because you cannot always control the scanning tools. Nowadays, for example, things like Docker Hub, they already have embedded security scanning. So it's not you who's running those tools. You cannot choose those tools. They have chose that for you, right? So try to be as complete as you can. While being Distroless, try not to forget about security. So if you have to compromise a few kilobytes of data just to make sure that scanners are compatible with your Distroless image, just do it. So yeah, if you have any questions, I think we are like 40 seconds. We might have time for one question, I don't know, but if not, you can just find me around or just ping me on social. I don't know if there are any questions. 30 seconds. Yes. 31 seconds.
What kind of metadata the Chisel tool produces?
Yeah, so Chisel, right now, if you want metadata, you would need to use a sort of additional, let's call it a wrapper that we have created for it. But we are actually working on a dedicated format. It will create something which is what we call a JSON wall. And we will need scanners to be compatible with that. But we believe that our new format will provide much more detailed information to scanners than your legacy the package status. It will provide actually at the file level instead of package level information. So yeah, for now, if you want something, there's a link here. You can use this, it's a wrapper tool that will generate the package status for you. But in the future, there will be a dedicated format.
Maybe a quick one. All right.
Is Chisel compatible with other other images like Debian, for example?
So you can run Chisel in pretty much anywhere. I don't want to say anywhere, but yeah, Chisel is just a Golang binary. However, you can only install slices from the Ubuntu archives. So Chisel itself only supports packages and slices from the Ubuntu archives. So yeah, running it anywhere, but it only installs stuff from Ubuntu. Right?
I think that's about it. If you have more questions, you'll be around for a question.
I'll be around, yeah.
There you go.
Thank you.
Awesome, thank you.
On a state line, the lights turning red again. You're in your head, sitting next to me. I thought nighttime would make us feel permanent, but then came the sun unexpectedly. In the day, standing tall, we got your mother's call. She said she needed you at home, and you just stared at your hand, holding a grain of sand. You let it fall to your feet, then you said, dance with me, and I did so willingly. There's lights on the radar screen, keep pulling away. Just stay and dance with me. Darling, how in the hell will we work this out when I need to go but don't wanna leave? I don't know, but I'll turn the car back around if that's what you're asking me. At the edge of the fall, we still don't know it all, what we were setting out.
All right, we're going to get started just about now. Christian,
okay.
it's yours.
Okay, good, cool. So, welcome. We were actually debating if we should just do the session with, hi, I'm Christian from Intel, we're bad guys, thank you very much. But I think actually we have something to tell here, and Thibaut was just saying this is about hardware, but it actually is not. So we're trying to talk about software and a little bit of hardware here. So I'm actually joined by Apoorv, who's hiding away. He's going to join me on stage for the IoT topics. But let me just give you an update what Intel is about. And I have to say I'm a newbie to Intel myself. I joined about 1.5 years ago. I've been a software guy for 20 years and an Ubuntu user for almost 15 of those. So, and I'm drinking a little bit from the fire hose myself. And it's interesting to be here at the summit and listening to all the developers that are around and just take the enablement of hardware features somewhat for granted as it comes through Ubuntu or other distros, but there's actually a lot of plumbing that happens in the back end. And if you look at Intel as a company right now, of course we have a lot of hardware engineers, but we also have 20,000 software engineers at this point. And a lot of the obvious things like hardware enablement, drivers and so on, that's been built by Intel, but you will also see there's a lot of contribution into open source that we actually do. And we've been, if you look since 2007, we've been the #1 kernel contributor to the Linux community. So there's really a lot of stuff that we do and a lot of change actually also that happens inside of Intel. Really embracing openness, open source, open ecosystems with the new leadership that came in place 1.5 years ago. And that's basically what we really want to focus on in this session. So really not that much hardware, I guess. So as I said before, a lot of this is about open ecosystem. That's a new theme that we have inside of Intel that we embrace from the leadership down to the various levels. And it obviously starts with open source, right? It's Linux, but it's also runtimes. So our CTO was actually telling a story last week in an internal employee meeting where he was saying he was meeting one of the big hyperscalers, senior guy, and they were talking about, optimization of runtimes, and the guy was very proud of all the work they are putting into the Java runtime. And our CTO was like, oh, that's cool. Let's really do something together in the spirit of open source. Let's meet, and would be great to get introduced to your team so we can actually work together. So they pulled the manager of the Java team in, and our CTO was asking, like, what are you doing? What can we do together? The guy was saying, well, we take the stuff that you guys put upstream. So found this kind of interesting, but I think it's not very well known, the effort that Intel is actually putting into the community, optimizing runtimes like Java, Python, contributions to Kubernetes. But then if you look at it further, it's also about hardware, openness in hardware. You might have heard the RISC-V talk. Intel also joined that. So we're also embracing open hardware architectures. And that's, I think, a big change. Also PCIe, other standards, and it really goes along also to open APIs, open data models. So very, very broadly, big change. And if you go to the GitHub repositories that we do, there's really a lot of projects that are open source. Honestly, it's the same as in other open source projects. Some of them get deprecated, let's be honest about that, but others are becoming really successful and broadly adopted, right? So big change here from an Intel perspective. As we are at the Ubuntu Developer Summit, let me just point you back to Intel innovation. That was probably a good, well-kept secret. So Intel started to do a developer conference again. That was 4 weeks ago, 5 weeks ago in San Jose. And we actually got Mark Shuttleworth on the keynote of Greg Lavender. So both keynotes from our CEO, Pat Gelsinger, and Greg Lavender, the CTO, are still available on YouTube. I found it quite interesting to really see what is cooking, what's happening from a technology side, and what we announced from the software side in Greg's keynote is actually a broader effort to collaborate with Ubuntu and really make it easy for end users in a very broad sense to get the innovation, the open source, early into the Ubuntu distribution and just be able to use it and get also support from the community. So we're working on this. We're trying to flesh out the details, but we really want to drive adoption, make it easier, and not everybody, I mean, we're developers here. A lot of us can compile a kernel. Not everybody who's using Ubuntu can do that. So they want performance, and they want the latest features that a silicon offers, and that is really what we're trying to do in this collaboration. And there's also aspects of looking into newer ISAs and so on. And there was also a discussion like, where do we find the right balance in the earlier RISC-V discussion. So we're working through it, stay tuned, and if you have a little bit of time, I would just recommend go and watch the keynotes. It's on the Intel YouTube channel, and you will see what happens. Couple of topics here. AI, obviously, I'm going to touch this a little later. Scalability, so there are a couple of new features that we bring into the CPUs that are coming out. Security is going to be a big topic. I also touched that a little later in this presentation. So very broad set of features, of topics that we're trying to cover, and that we will cover. So let me take you a little bit through the three main business units and what's cooking here. So the Intel business, very easily you can split into data center and AI, client compute, and IoT. So when we look at data center from a CPU perspective, the next generation, the 5th generation of Xeon, and you've heard the DreamWorks presenter talking about how they render on Xeons, for example. Next generation is going to be announced in December. So that's coming, couple of interesting features on that. But there's also a new CPU, and Pat was announcing that at Innovation, called Sierra Forest. And that gives you 288 cores on one CPU, which is quite interesting. So that's really, of course, with that CPU count not tailored for you as a desktop user. I think there are a lot of developers here that will have to have that under their desk and enjoy that, but it's actually really going towards the CSPs. Then there is a set of GPUs. Obviously, if we talk AI, there is the question of GPUs and what can we offer there. So there are a couple of data centers cards that we're working on, and just to call something else out, and that's a little bit more of my own background and heritage. So I've done a lot of work in enterprise deployments and enterprise Linux for the longest time. CXL, which is some of you might have heard about Optane, persistent memory. CXL is basically a standard that will be able to give you an expansion of DRAM on the large servers. And in my old environment and my old work area, which was in memory databases, I saw systems that went up to 32, 48 terabyte per one machine. And if you see the DRAM prices associated to it, it's getting pretty expensive pretty quickly. So CXL is an interesting way here to give the machine more memory and accelerate that. From the developer perspective, there's a lot of collaboration with Canonical on the CPU updates that happens. So there is magic for you as an end user, but actually there's enablement towards the kernel to enable the latest generation of CPUs. It works okay-ish if you just put an old Ubuntu version on a new server, but you're not getting the latest performance. And it's pretty easy. If you think about this, you need a later GCC version, for example, to really address the new features that the CPU gives you, and it's not coming by magic if you throw an old kernel on it. Right? So there's work there. Confidential computing is a pretty hot topic if you think about cloud and data sovereignty. So I'm from Germany. We're very crazy about data protection. And from that perspective, there is confidential computing. Canonical posted a blog post 2 days ago on it, on the first prototype, embracing a technology called TDX, which basically encrypts a whole VM in memory. So it's getting intransparent to the admin of the host, and you get an additional level of protection. It's especially interesting if you think about CSP use cases, public clouds, where you move data. AI is one of these examples. You trained a model. It's very valuable. You can move it into the cloud, additional level of protection. We're working on that. And then there's a set of accelerators that we built into the latest server CPUs. QAT is one that accelerates crypto operations that we're looking into to enable. Some of them are, some of them are not. And obviously higher core counts. If we go to 288 cores, as an engineer, you will understand that needs a little bit more of coordination, and it's a little bigger problem than if you have like 60 cores. Okay, let's talk about desktop. The new generation of the Intel Core on the desktop is also coming in December. It's the 14th generation. It will be called Intel Core Ultra. Pat talks in this innovation keynote about it as the AI PC, because besides the usual things you would expect, like more hybrid cores, we introduced that with Raptor Lake, that you have performance cores and efficiency cores on the CPU. We also integrate the NPU, so if you've seen the WSL presentation this morning, the neural processor, that's also on Meteor Lake. And that will give you some of the magic that we've seen this morning. But from a Linux perspective, we're actually debating with Canonical and the community what are the interesting use cases, because the Teams client, I think, still doesn't run very well on Linux. There's room for improvement, and that's one of the use cases that Microsoft has on the desktop CPU. From the developer and software side, same thing here, kernel updates, the NPU drivers are upstream accepted, that's fine. The SDKs are available on Intel.com at this point. We work to get them integrated. We're having an interesting discussion with Canonical on MIPI cameras, so find us if you suffer from that, and we can have a discussion on that. There is a new graphic driver underway, so the i95 driver is basically going to be revamped next year. That's at least the idea that we're working towards, and there is a public beta, if you haven't seen it, of Chromium, that actually has hardware acceleration on Linux. So that was also, I think, on the Canonical blog. So that's also one deliverable that we actually worked on together as a team in the last couple of weeks. Okay, and that gets us to the last business unit, which is the Network and Edge group. Basically, we don't have specific CPUs. It's the same, literally the same design with a few variations, but the cores are the same. So Meteor Lake and the 5th generation Xeon called Emerald Rapids, they will also be available for edge workloads. But obviously, there are specific edge use cases, one of which that's really interesting at this point is telco use cases. It's about liberation of the telco stack. So if you think about your cell phone provider, they basically go to one supplier and buy a whole stack. And there is a technology, Apurv is going to talk this a little more, called FlexRun, that is giving you some flexibility, and there are dedicated CPUs with this whole idea of chiplets as a basic idea and a concept that accelerates telco and network workloads and addresses the needs that people have there in terms of network latency, network speed, compression, and so on. So that's all built in hardware, back to what I said before, right? Everything works somewhat in software. The question is, where is it more efficient? Am I building it in software? Am I using something that's built in hardware and I offload it from the CPU into an accelerator? That really depends on the use case and what the customer, the end user really needs. And as we're talking about network here, there are also several network cards that are out there. Interesting things that we're looking into is time-coordinated computing. So we were actually hoping to have a demo, but it got shipped through Charles de Gaulle, and everybody who's taken a flight through Charles de Gaulle, there's a tendency of luggage getting lost, and that happened to our demo as well. So, that was a nice thing of showing time-coordinated computing here and basically making sure that real-time use cases are also supported by hardware and not only by pinning a process on one core on the CPU. And then there is a new interesting family of NICs arising, which is IPUs, intelligent NICs, that have their own ARM core on it, basically, and you can run your own Linux distribution and influence the network routing right on the network card instead of doing this in the OS. So optimization, it's something that CSPs rely heavily on, but that's also a discussion we're having. Apoorv, come up.
So thank you, Christian. So I hope you guys haven't yet got bored by listening to all the hardware updates that Christian was giving. So I'm here all the way from a tropical country, from an island called Penang. Took 30-hour flight to reach to Riga. And I'm here to acknowledge our partners, our ecosystem partners. So we have Cindy, VP of Silicon Alliance. Over here, we have Stefan, architect. So all of you know about Ubuntu, but do you know there is a IoT-optimized Ubuntu as well? So there is an IoT-optimized Ubuntu, which is essentially being optimized for Intel IoT platforms, which is sufficing certain use cases, which is very specific to our IoT customers, be it industrial, healthcare, retail. So I would really like to call out and acknowledge our ecosystem partners, Canonical, in helping us come up with something which is very optimized for IoT use cases, like real-time, time-coordinated computing, time-sensitive network, which is gaining more and more traction within the industrial world. We are further working with Canonical to enable other features like graphics virtualization and Intel AMT technologies. I would like to specifically call out two softwares over here. One is FlexRAN, which is essentially helping change the way telco industry works. We are trying to move telco, which is essentially a fixed function hardware technology, towards more virtualized technology where telco workloads can be run on normal hardware, not essentially a fixed function hardware, which right now is happening. So that's a big shift in the telco industry that is coming with the Intel FlexRAN technology. And last but not the least, I would like to introduce Project Strata. So this is a edge-native software platform which will have end-to-end capability in terms of scaling any AI applications running at the edge. So it will have a hardware layer which will have enablement of all latest Intel hardware and technologies. It will have an infrastructure layer which will deliver fleet management, telemetry, observability, onboarding, so which will really help our customers scale at scale. It will have a edge AI runtime supported by OpenVINO. So OpenVINO is an AI toolkit by Intel. It is public. It is open. It supports right now x86, but we are going to extend it to support ARM as well. So it is going to support multiple architecture. So if you haven't yet checked out OpenVINO, I would strongly urge all of you to go ahead and see OpenVINO and its capabilities. It provides a lot of good capability when it comes to creating your AI applications. On top of it, there is going to be a vertical solutions layer. So Intel has a lot of solutions which are catered to different verticals. It could be industrial, it could be healthcare, it could be commercial. There are a lot of vertical solutions. So that vertical solutions will also be bundled up as part of this Project Strata. So with this offering, our customers, our partners, developers, you don't have to go and try to figure out which piece to get from where on. You can just go ahead with this particular one solution, everything would be there. And I think I don't need to mention, but all of this will be supported on Ubuntu. So again, thank you to our partners, and thank you for having me here.
Okay, thanks, Apoorv. So let's drive this up. So I started with, we have 20,000 developers. And this is just a non-complete list of the projects that actually we contribute to from an Intel perspective. And when I saw the slide for the first time, I found it actually very impressive. So there is a lot of the various projects that I think most of you are using when you develop that actually Intel contributors are around, or we have a driving position in these different projects. So it starts from video codecs, firmware BIOSes, but as I referenced before in the earlier discussion, there's optimized versions of Java, Python, and so on. A lot of this available through the Intel website, but as I said, we're really working with Canonical to make as much of that available as part of the base distro and give you an easy way to get it and have it integrated and completely tested. So Apurv mentioned OpenVINO is one thing in the AI space. PyTorch is one thing where we're a leading contributor. And then obviously also projects like DPDK that we're really deep into and where we do a lot of the optimization for the hardware in the end, besides just contributing code. So you get really good performance. And it's not only running, but it's running as best as it can. One big topic going back to Intel innovation that we talked about there was liberation of AI. So that is something where we're really trying to drive, and there is a Linux Foundation announcement recently of the companies at the bottom right of the slide joining forces to really opening up the ecosystem, the APIs, how it's being consumed. There are projects that we've been talking about to bring AI directly into the browser and make it accessible from even a web application. And I was actually talking to one of the Canonical developers earlier, getting it out of generating funny pictures. I feel a little embarrassed not having funny pictures on my CPU and developer slides, but we were trying to generate a few pictures for the CPU code names that Intel had, and we should have just put that on. That would have been pretty interesting and funny. But now actually taking it from that use case into really broader adoption, and we'll see where it goes, and let's see how it develops. But as I said, PyTorch is one of the key projects that we're driving. A lot of the Intel optimizations are upstream accepted for PyTorch, and that is also, I should say that, upstream first is what we're doing from an Intel perspective. As you all know, there's sometimes a lot of discussions and it's slowing down, and that's all good. I'm not criticizing that. But I think, and I was saying that in another discussion, right, if you have something that works and you can get it out for people to try, I'd rather have you guys coming at me and tell me where we fail than just building something that's completely going in the wrong direction. So again, a lot of it is open source. It's out in the wild, and you can go try it out, pull it from GitHub, and ultimately we want it to be easy to adapt for Linux users through the distribution, and just give people also the opportunity to have support around it, because I think that's critical, especially if you go out of your personal use into a commercial use and you think about large corporations like DreamWorks running production systems on it. I think you don't want to be in that person's shoes if you have a bug in the kernel and everything crashes like 5 seconds before the movie is finished rendering. So that's probably an unpleasant discussion to have. Anyway, to wrap this up, I spoke about the new CPU innovations, Emerald, Rapids, Meteor Lake, and so on. So we've launched during Intel Innovation also a new kind of initiative called Intel Developer Cloud. That's available under cloud.intel.com, and it basically gives developer an early access to the latest generations of CPUs, GPUs in a closed environment. If you go there, it's all Ubuntu based. So you should all be very familiar with getting a VM, for example, that's on 2204 and start deploying things on it. So it's available. I think there are ways to get going. There are free tiers for it. There is no intention from Intel to compete with the hyperscalers. Let me put this out as well. So we were trying to set up a ML Ops workshop, and there was a lot of back and forth with Intel IT to open firewall ports. So that's not the intention of it to run production workloads, but it is there. Check it out if you want to, and we just wanted to close with that. So I think it's almost on time.
We might have time for 1 or 2 questions.
We are around, find us, and there is also Ali behind there. Just wave your hand. So he's the 3rd Intel person. Find us around. You might see us at the party. We'll see.
Quick question up there. Mike is going from behind.
You mentioned IoT applications. Is Intel doing anything with the Matter specification?
Do you know that? You could probably answer.
Can you elaborate a bit? What do you mean by Matter specification?
Yeah, so the Matter specification is a new protocol for IoT devices. I'm just wondering if Intel has any open source work going into that open source specification.
So I personally am not aware about this specification. Probably we can meet afterwards and then can talk more about it, what exactly it is. It's such a wide field and there are so many things. So it's difficult to keep track of everything out there. But I'm pretty sure there should be something as part of our portfolio.
Thank you.
If you're interested in Matter, there are a few people who are in this space here. So I'm sure we can introduce you to someone who does.
And I vaguely remember a discussion around it. So I think Apurv is right.
The additional question, well, I think our Cindy.
Hey, Christian.
This is getting scary now.
I know all your secrets. You should be worried. You talked briefly about Meteor Lake. There's some super interesting power management that's coming that's quite new there. I don't know if you want to comment on it for people who are not so familiar about what's going to be in Meteor Lake.
So Intel has Intel Energy Efficiency Architecture, which is an AI-based implementation that is going to be introduced with Meteor Lake. So it's going to be able to deliver 20 to 25% higher performance comparative to previous generation. And when we run workloads, we should be able to intelligently power up as well as get into low power state. So that is where the overall efficiency going to come in with Meteor Lake. Processor will be able to get into the higher efficiency state, higher power state, and then quickly get into the lower power state, delivering overall better power management across multiple use cases and multiple workloads. So that's what Intel Energy Efficiency Architecture does for Meteor Lake.
Brilliant. Thank you both. Thank you both with the microphone. Looks like, yes, perfect, thank you. And we'll move on to back to gaming and Steam. Look at that. The best hardware for presentation so far. We'll get maybe 1 minute or so to get ready, and then we'll get things going. I think that was a good teaser. What I'll do is a backstage picture. If you
dance with me, and I did so willingly. Just lights on a radar screen, keep pulling away.
I guess let's do that. And if everything goes fine, we should see a presentation running on a Steam Deck. That's right here. So I'm Arek. You may also know me as Ival. And basically, I maintain Proton, and I work on it for Codeweavers. And here's the history of gaming on Linux. So the ancient times, Windows 3.0, it started getting a little bit popular, and big Unix players started being a little bit afraid what will happen, because like all those new applications for productivity and games were being released for it. So Sun Microsystems tried to do something called WABI, Windows Application Binary Interface for Windows, which was like a Wine predecessor, which was proprietary. And they also tried to standardize parts of Windows APIs. So that was public Windows interface, and they were working with IBM, HP, and Novell. And at some point, it was even proposed by ECMA as ISO standard, but that has never really materialized. So then the summer of 1993 has came, and Wine has emerged from discussions on Comp OS, Linux, and in 1994, Alexandre Julliard became the maintainer of the project and is our BDFL to this moment. So originally, the project was licensed as MIT, but later got relicensed to LGPL 2.1, and the idea was to just run Windows application as best as we can on Linux, and without any extra specs. So we haven't tried to standardize Windows API. We haven't tried to force it on Microsoft through ISO. The idea was to just run stuff and treat Windows as the ground truth. So if you tried to game on Wine back in those days, you know that it was kind of hit and miss. So there was a huge variability when it comes what games were running from a game to from release to release. Games were regressing quite often. There was AppDB, which is still up to this day, which was messy but very helpful way of figuring out what's the golden working configuration. So you could see, oh yeah, there's a Platinum report for a given game from Wine 0.7. And this is probably you should have to use. AAA games rarely did work, and usually when they worked, that was years down the line, so you had to play something back from the past. And a bunch of downstreams and ad hoc community patches have appeared. So if you think about launches like Lutris, basically you have a huge list of Wine versions that are supported, because yeah, this version works with this game, but that version works with a different game, and basically you had to have projects to maintain all that mess. There was no proper QA done by anything in professional setting to focus on games, to run the games, because it's very different when you run unit tests that we have in Wine and when you actually run real software, which is not really easy to automate. So I have experienced that firsthand when I was in high school. I was playing Guild Wars on Wine in early 2010s. And that has changed a little bit in 2000s because there was something called WineX, later renamed to Sedega, which was a proprietary fork of Wine, which tried to focus on gaming. So they were doing a lot of changes to DirectX implementation we had in Wine, but none of that really has been contributed back because it was a proprietary fork. So this has contributed to relicensing of Wine from MIT or X11 license to LGPL 2.1. So we have something copyleft, and we can enforce the license on any downstreams. And there's a fear that more downstreams like WineX will pop up. So within a few years, it fell behind upstream by a huge margin, and the product is no more. If you look for the company that was making it, I think it was called Transgaming. It was publicly traded on Toronto Exchange, and the husk of the company was made into some real estate holding thing. It's a really weird story, so maybe you want to look that up if you want to be entertained. But all of that has changed with Proton. So this is a Valve project that was first released in 2018. That was 3.7, and the number corresponds to the baseline Wine we use. And it's like a distribution of Wine in the same sense as Linux distribution. So Wine is like the core that runs the Windows stuff and translates it, but there's also another projects that accompany it, like the XVK, and we also ship GStreamer, we ship a bunch of different things that contribute to the whole experience. So the work started a few years back, before August 2018. I think it was like 2016 or 17 when it began. The difference from upstream Wine was that it has included the XVK for running DirectX 10 and 11 at first. We also had the bridges for Steam API. So if you think about games, especially the games on Steam, they run them on the Windows environment, and they expect Windows Steam to be present. And they do Windows API calls to that Steam. And we had provided open source bridges that actually translate the native Windows 32 calls into something that's understandable by the Linux native Steam client. So basically you could just run the games without having to run Windows Steam inside of Wine, which was a huge improvement over what was done in the past, because people try to run Steam in Wine. The same goes for OpenVR. We just bridged to the native version. And the focus was on the game compatibility, which was a huge thing. So it was also the first time when there was someone backing it like with money and providing a proper QA where we were testing games. And the biggest thing is that it's regularly based on top of Wine, so we are not a fork. We are like a friendly downstream. So basically, we contribute whatever we can upstream, and the developers working on Proton are primarily, especially the Wine part, are primarily considered to be Wine developers, and they expected to upstream everything they can. So when we launched Proton, there was 27 supported games that we have whitelisted for use. And it was working pretty well for those games. Those were tested. Those were like promised some degree of support. And I highlighted Nier Automata because that was like before my times working on Proton. And I think this is the first game I've played using Proton Linux. So and it was a really good experience. Then we kept on developing things. So more of games started coming out that use DirectX 12 as the API, so we started shipping Wiki2D, and later we switched to a Wiki2D Proton, which is a fork. Also, D9VK, that was a separate project that tried to do the same things that the XVK does, but for Direct3D 9. Got merged into the XVK, and we also started shipping that. We had to implement Media Foundation, which is API for media playback, and it's like very complex, very large API set. And we implemented it on top of GStreamers. You can use like the Linux encoders and decoders through Media Foundation, and it just works. Also, one of the biggest developments is that NVIDIA has jumped with help, and there was a community project started by Jens, the XVK and the API, and he was developing that by himself, and at some point, NVIDIA was interested and started contributing to it as well. And basically, they contributed DLSS support, loading some DLLs that they provide with their Linux driver. So they ship DLLs for consumption of Proton with the Linux driver that the XVK and the API understands, knows how to talk to them, and basically you get all the newest and shiny feature from NVIDIA on Proton. Before that, we had to fake some old AMD card. I think I have a little bit more on that later. So things have changed. We started with 27 supported games 5 years ago, and now we have over 4,000 games that are DECT verified. So that means that they run on Steam Deck and the experience is good. That means text is eligible, it displays correct glyphs, and overall, like, you can play it and there's really nothing to complain. Then on top of that, we have 8,000 other games that are marked as DECT playable. So that means that they run, you can play through the whole game. The experience is decent, but like maybe some text is a little bit too small on the built-in screen, so you might have a little bit better experience plugged into TV. And those are just like the official Valve classifications of games. If you look at ProtonDB and look at the top 1,000 of the games that are played by people mostly on desktops, because this is where Steam started. Steam Deck is like last year's invention. 77 of the top 100 games are rated either gold or platinum. That means they're also playable. Like, they just work. We started with a single Proton based on Wine 3.7, and now we ship 4 flavors. So the Proton stable is probably the one that most of people use. Its current version is 8.0-4. It gets extensive QA testing, public RC phase, so we post an issue on the GitHub tracker, and a lot of media outlets pick up on that, and we get advertisements saying, hey, if you want to test the new stable release, please hop in. We get user reports, we make sure that it works. Usually there are a couple of RCs, and then we release new stable. Then there's Proton Experimental, which we use to crowdsource a little bit of testing on features that are not really ready for prime time. Something like Media Foundation, for example, first shipped through Proton Experimental. And it gets a little bit of QA, so whenever we are merging something that we know is risky, like for example for windowing integration, then we test that. But also there's a bunch of games, if you check changelogs, that are playable only with Proton Experimental. So we always test those for regressions to make sure that they are still playable. And on Steam Deck, it's smart enough to know what games are pinned to, and you don't have to really care about different flavors. You just run the game and it will work, whether that's experimental, stable, or whatever. Another flavor is Proton Hotfix. So Proton started getting some traction, and people want to play their games, and there's a lot of AAAs coming. And usually games release on Friday. And that means we have very short time to create fixes and deploy them for the end users. And you don't want to start a proper Proton release on Friday afternoon. So what we do instead, we merge the fixes in. We release something called Proton Hotfix. We pin that game, the new hotness that's on the market, to that version of Proton, and it just runs. So this is not for desktop users. It's mostly for Steam Deck. But as a desktop user, you can select that version manually. And the idea is that this is a very short-lived branch. So usually we give that fix a little bit of time and a little bit more polish, and then it gets merged into experimental proper releases, and we retire that branch completely. Currently we have 2 games pinned to it. I think it's the Metal Gear Solid Collection, especially the third one, the new remasters, and the Lords of the Fallen 2. So, and next week I am going to make a Proton Experimental release that will retire that branch. There's also Proton Bleeding Edge, which is for automated integration of all the components that build Proton. That means the XVK NV API, VKD2D Proton, and all the wine changes that were staged for inclusion in the next build, but haven't been released in any form yet. So this is the most risky stuff, and it's mostly meant for users who know what they're doing and want to contribute to testing ahead of time, but it shouldn't be used by general public. Also, VKD2D Proton and the XVK developers are using this as their baseline. So basically, this is what they develop against. So you have no idea about Proton, but how all of that started. You probably remember those guys. Those are called Steam machines. And that was an interesting attempt. So this predates me by a long margin. I have no insights into what was the idea and what they're trying to push. But my conjecture is that this was to create a market for game developers to port the games onto Linux. Because those machines were supposed to be easily dual bootable. They were running SteamOS based on Debian, and they were supposed to entice game developers to actually port their games to that platform. The problem was that most of the game developers wanted to use DirectX or some other that was basically the only API back in the days, and not OpenGL. And porting your core of the engine to a different graphics APIs is a huge investment, and the market for that was pretty small. So eventually they were phased out. I think they haven't managed to create any kind of market. But then when Proton came out and you were just running Windows games without any modifications, and they were just working fine, that was the first step. The second step is that we are not always perfect with Windows support. So there are some quirks. We also often find bugs in Windows games that are also bugs on Windows, but due to scheduling subtleties or like some small differences, don't happen on Windows as often. So, you know, some crash that happens 1 in 50 times, that's okay, that makes it through the QA. But because of Linux scheduler, suddenly it crashes like 8 out of 9 times. So, which is much worse experience. So the good thing would be to get the developers, game developers, to get their games tested on Proton and make that run. And I think that Steam Deck has achieved that really well, because it created a lot of buzz around Proton, a lot of buzz around gaming, created a new form factor for PC gaming, basically, because the previous experience on handhelds was not as good as when you run SteamOS. And I think that shows because a lot of game developers are actually releasing games saying that, yeah, it runs on Steam Deck. So that means that the game studio have Steam Decks in-house, and they test against it. And we sometimes see like games creating Proton-specific workarounds, but I think more often than not, they just test against that target, make sure that the game settings, like the detail level, can scale low enough to run on the deck and look good and run well. And whenever there's something not quite working, they just figure it out and ship it, both for Windows and for Proton without specific workarounds, which is great. So the other thing compared to the bad times of WineX and Sedega is that Proton is completely open source. Like DXVK, VKD2D Proton, all the changes to Wine are just available for everyone. And that has created a very vibrant ecosystem around us. So we are primarily concerned with Steam and running via Steam, and Proton is shipped and packaged in a way that it contains a lot of Steamisms, in a way that we expect environment variables that Steam provides. But there are other downstreams that have built on top of our work. So this is just a reminder for everyone. If you see an issue with, please don't report it to Wine upstream unless you are sure it also reproducible with Wine upstream. And the same goes for our downstream. So if you use like a Glorious Egg Rolls Proton, please report it to him instead of us, unless you have tested that on Proton proper and you are sure that the issue is there. Because like if you don't want to test that, please report it to the correct downstream anyway. It will finally make its way to us. So one of the downstreams is something that predates Wine by a long time. That's Wine staging. It's a collection of patches that are kind of in flight, so they haven't made it into upstream yet, but the idea is that everything there will be upstreamed. It's maintained by Wine developers, including people working on Proton, so there's a lot of overlap there. And currently we have 78 patches of that used by Proton included directly. I think it's actually more than this, because some of the Proton patches feed into staging. And I don't think we have accounted for those yet. We haven't tagged them yet. So hello? OK, now it works. So I will do a recount next rebase. One of the examples is WineTKG, which ships their own Proton build and also standalone Wine, so you don't have to use it as a Proton through Steam. That just works. So, and contains the patches that we ship with Proton and plus some community contributions on top of it. Then there's Proton GE Custom and Wine GE, which is used, for example, by Lutris, the Wine part. So this also ships with some extra app bits and pieces that we don't ship in the Proton proper, and has a slightly different audience as well. And many, many more than that. There's also a few launchers. So as I mentioned, back in the days, you had to manage a lot of versions of Wine. So one of the launchers that uses Protonified versions of Wine nowadays is Lutris, and they actually are hoping for getting rid of some of those older versions and limiting it to only the latest and the greatest, because the latest and the greatest just works. So that's the thing. Like most of the games, we don't regress as often as Wine used to in the days, because we have the QA, we have the resources, there's a lot of people testing the games, there's a lot of community eyes on Proton releases, so it's much more stable, especially if you use Proton stable. Then there's also Heroic Launcher. that you probably know from the presentation earlier today. It also uses Protonified versions of Wine with all the patches to make the games run well. And there's crossover, which comes with its own Wine downstream. This is how I would call it. So basically, it's the best way of running games on macOS, especially if those are like AAA games that haven't had ports. Historically, it was used mostly for productivity apps, and historically, it was the only way of funding work on Wine. Now that has changed with some other things like ports and Proton. But basically, if you want to see Wine running on macOS well, like this is the way to go, because this way you show your support. And it runs Cyberpunk, it runs Diablo 4, and it runs Quicken if you are into that sort of thing. Over the years, the technologies that we have been developing for Wine, for Proton, have made their way into some unexpected places. So the previous talk was from Intel, and Intel actually ships DXVK in their Windows drivers. So the ARC GPUs don't have native support for D3D9. Instead, they use something called D3D9 on 12, which is like Microsoft's provided compatibility layer. And that was like hit and miss. Some games were running very poorly. And I think they released the driver in December of 2022 that included DXVK. So if you run strings on the binary, you actually find DXVK strings there. They just bundle it in and use it for games where it provides performance uplift. So it's not enabled globally, just on a game-by-game basis, as far as I understand. But yeah, they ship the DXVK. The same goes with Apple Game Porting Toolkit. So they shipped it to evaluate your games for making a proper native port onto their hardware. And under the hood, it uses sources of Crossover, which is another Wine downstream, and the license for D2D Metal, which is the compatibility layer to run DirectX 3 on top of Metal. Shouts out DXVK as an inspiration. If you look into the readable license file, I don't remember which one was that. And also VirtualBox. So if you install Windows inside of VirtualBox and you install the guest editions and you want DirectX support, it replaces the DLLs for D3D with a Wine D3D based build. And also, VirtualBox has now a support for acceleration on the host side, so all the UI and rendering is getting accelerated. And that uses DXVK native, which allows you to write DirectX and compile it natively on Linux. So instead of like having to implement another API backend for the acceleration, on non-Windows hosts, they just use DXVK native. And that's it. I'm with Codeweavers, and if you want to program like some system level C and work on Wine, we are hiring. Any questions?
Thank you. We should have time for a couple of questions. Except everyone was just too tired, which is a possibility always.
Yeah, being the last talk of the day, right? Before there's lightning talks.
Lightning talks after.
Yeah.
So.
Yeah, no questions. I guess that's it.
Going once, going twice. That's it. So
thank you.
Thank you. Richard, if you're around. Knows where Richard is. In the meantime, I'll do the very important announcements about what's going to happen next. What's happening next after the lightning talks, which are first of all going to be amazing. So lightning talks is no one introduces the speakers. They have 5 minutes. If they go over 5 minutes, there's a cuckoo clock. If they continue too long after the cuckoo clock, I'm in charge of tackling them, even though, frankly, I think they probably have a chance of withstanding my tackles. So it's probably not very fun. So that's going to be the, but you can boo them, if they go over 5 minutes, so that works as well. Shame is probably better than a tackle. That's for the lightning talks. Afterwards, we'll finish the day, except that at 8, everyone can be back for gaming night in the beta rooms. The beta rooms, by now everyone's so aware of where you are here. So beta rooms are over there on the other side. And from here 8 to 11, gaming night. 9:30 is swim with robots. Well, actually, no, you don't want to swim with robots, because if you didn't bring your swimsuits, then that'd be particularly... No, you'll be fighting with robots in the water. Well, the robots will be fighting, you'll be outside the water. I hope that was kind of clear. Not really clear? We'll try again later. Do we have our last speaker? Otherwise, I have to do entertainment. So if you were here in the debate earlier on about the fact that there's a foundry doing chipset in Riga, the answer is yes, there is, even though they're not particularly evolved chipset. We'll agree on that. So we settled that debate. And just to say, well, we're still looking for a speaker. That has been a pleasure to moderate here today. Move on, move on. What does that mean? Please start. Okay, it's been a pleasure. We'll get started. Off you go.
Hello, hello. My name is... I'm too eager, aren't I? So yeah, my name is Mike. I'm probably many things. One thing I'm not is affiliated with the project I'm going to be talking about, but I am a very enthusiastic user. So it's not my project, but the enthusiasm is my own. So in my job, I sift through moderate quantities of disparate data, and I use spreadsheets, and I run them mostly in the terminal. Now, why? What the F am I thinking, right? Why would I do such thing? Well, laziness, that's a very good reason to do anything. You get very far in life with laziness, I found out. And impatience. If you ever saw my poor, abused mouse, the human interface kind, not a rodent, it's abused because when things are not loading, I'm basically doing this, right? So if I could use GUI spreadsheets, they are fantastic. I don't want to, diss them. They are amazing. They enable people to do myriad things. But they also require me constantly changing between the home row and the rodent, and back and forth, back and forth. They tend to be slow to load. If you have like 200,000 rows, 200 columns, and you want to filter the thing, things can get a bit lengthy. And then there are the formulas. Like, for goodness sake, we have Python. Why do we need to use that? I am okay with Python. I do a lot of data wrangling with Python. I don't like spreadsheet formulas. So that all kind of spells for me a big trouble with GUI spreadsheets. Luckily, there is an alternative. There is a project that has Python for formulas, or uses Python for formulas. You can move around and do anything with your fingers comfortably on the home row, using Vim shortcuts to move around. Those are the best shortcuts, as everybody knows, and it's fast. So that project is called Visidata. It's a play on words. There was a spreadsheet once called Visicalc, and this is now Visidata. I know Visicalc for the age of data, I'd imagine. The creator describes it as a multi-tool for data work. So if you ever looked at a Smith Army knife and thought to yourself, I wish my spreadsheet was like that, that's what Visidata is. So I have to go through this very quickly because I have only 2 minutes left. So this is when you start the Visidata spreadsheet with that command. This is what you see, mostly. You have columns, you have rows. One of the rows is selected. And one of the columns is selected. You can clearly see it. You can move it out with HJKL, or you can use mouse, the arrows. And you can also use the mouse if you wanted to. If you, for example, from this want to see what columns you have, so it will give you some metadata. It will show you the data that's selected for the row. And you can use, for example, that width column with a simple shortcut to set in bulk the width or even completely hide the columns. If you, for example, from this screen, wanted to see how many different reviews there are. Oh, I think I'm lost in this now. Right. Well, anyway, so if you wanted to see how many different review categories there are from the spreadsheet, you just press a single F on the selected column, and it will give you a histogram and a frequency table. If you wanted to do this in Excel, you probably need to spend about a minute clicking around, inserting a pivot table, but this is just a single keystroke. And that's basically what Visidata is all about. Another amazing thing about Visidata, and Excel doesn't do that, is you can use regular expressions. I know people don't like them, but they are amazing. Let's say that you have that column with prices, but somebody helpfully added the dollar signs, and you want to get rid of the dollar signs because you can't add strings. So you can just type a semicolon and then your regular expression. It will create a new column with just dots and digits, or any other regular expression will work. It's all Python regexes. Thank you very much.
I'm already connected. Hello, everyone. So, I need to find out the end of these super cool things. Right. So, and my time is started. Hello, community. Hi, team. I'm Alex from Canonical Data team. And today we'll talk about Charmed MySQL. Now it's important. The following video will be highly compressed in time. So stay with me at least on the beginning before falling asleep. And let the party begin. I hope the font is good enough. So the goal is to deploy database in Kubernetes. What can be easier, right? Just type my command, juju deploy MySQL. And in a couple of seconds, literally 10 here, but 2 minutes in reality, you have database running in Kubernetes. Nice. Let's use it. Let's, for example, create our own super-pooper website, deploy it, integrate with MySQL, and now they are exchanging data and can store database, WordPress can store database inside. Additionally, we dropped ingress in front of WordPress to have access, and waiting a couple of seconds more to deploy. As you can see, database is being initialized, WordPress is already happy, and above we are requesting the credentials to access our web interface. The last piece is getting IP from ingress, and we have one. So we have credentials, we have IP address, let's try it. We open in browser, voila, we have a WordPress, it's running. We have a data which is stored in database. Let's start filling our super-pooper website. Let's go to admin interface, we're using credential, that works. That's surprise, but that's good. Going inside, changing the data, let's put something really truly superb, like Charmed MySQL is super. Let's don't forget about Juju, Juju is the best. Save that, let's go to web interface, let's see that that really works, and voila, that works. Let's drop it in the corner. And wow, we have website. What should we do next? We need to care about our data. Let's back up that scenes, right? So let's drop S3 integrator. It's a tool which helps database to store all the data in all the compatible S3 storage. In this case, we deploy it on Amazon, but it can be Ceph, behind Rados gateway, whatever you want. And we integrated it with MySQL. So they exchange, and MySQL immediately have access to the storage. For example, there is already some database backup stored. Let's create another one with our super data, right? And it's done, slightly speed up. We have Lightning Talk. And as soon as this thing's over, you see the last item is just recently created one. We need to damage our data. What can be more funny, right? So open a website, again, go into admin interface, and changing our data. Oops, data has gone. Oops. Saved, checking that it's gone. You see in the corner, its data is gone. Drop it again in the corner, and let's restore our data, right? What can be easier? Just one command, juju restore backup ID, specifying ID we just created recently. Couple seconds gone. What we want really to check that database is gone from WordPress, database restored, data restored. As simple as that. Wow. What can be simpler, right? Couple commands. But that's not all. That's great. Our site became popular. What should we do the next? Let's scale our database. Let's scale our website. So it's as simple as Juju scale application, specifying what you want, how big you want, and the Juju start doing magic for you. Meanwhile, what is more important, your website is fully functional, so you can scale up or scale down to save your money whenever you want, and no one will notice that. Wow, that's cool. Juju is doing some magic. You see some peers are joining the cluster. Data is copied over all of them. That's all Juju magic. We need to wait a couple more seconds until all the tools are active, happy, and this is that moment. Right, so we're going further. Great, while we're working on that, the big CV has been released, zero-day vulnerability. We need to fix that. How to do that? As simple as run juju refresh, specifying where you want to jump, and checking pre-upgrade check before to make sure that your database is okay, your cluster is okay, make some tuning to make the upgrade better, or block it if it's not compatible. And what we did, we upgraded the only one unit and give you a chance to test it as a sacrificial unit. And if you like it, continue upgrade using resume upgrade. If you don't like it, you can roll back, you can stay in that position to test it a bit longer, etc. More options are in documentation, but what we did, we resume upgrade, and you can see it start propagating for other units, and website is still reachable, but that all running on my laptop. By the way, framework, thank you for the superb hardware. I've been loving it. And you see, we reached the moment when switchover faced a cluster down. That's not a problem. Juju will detect that. You see WordPress on the bottom start dealing, and it will automatically fix that things. Superb. Can that all be done without downtimes? Sure. Just deploy MySQL router, integrate it properly, using examples before. But we are on Lightning Talks, 5 minutes only, and we are jumping. We'll learn today a couple of commands. You can use all of them for databases above, deploying them on all appliances below. And there are way more on Charm Hub. So please check the list there, and see you there.
Amazing. Thank you. Do you want the clicker? Or you don't want the clicker?
Okay. Hi, everybody. My name's Lawrence from Typest. And to start off, I would like to ask the developers among you, or silently ask yourselves, don't really respond, but about how do your editing cycles look like? So for me, it's basically edit, run, and then look what the results are. I'm maybe inspecting this with my editor on the left side. The font embedding completely failed here, probably because I did this presentation with our homegrown software. Anyway, so I print the results, and then I run on the right-hand side my script. And yeah, but basically, always running the script again and again is a hassle for me. I really only care about the behavior of my program. I don't want to run it. I just want to see how it behaves. And the goal here today is to find out how can we have a live view of program's behavior without running it ourselves. Ideally, by having the computer figure out what's changed without actually rerunning the computer program from scratch. And the solution is to remember things that didn't change. So let's look at the simple example. OK, this looks terrible. You can see what's going on. We have a recursive function. It runs in exponential time because we're calling fib twice. But actually, for fixed n, this function always returns the same value. So we can simply, whenever we call fib for the first time with a specific n, we can just store that in some data structure. And then when we reach that n again, just look it up. And by this simple trick, we gain linear time for this algorithm. And yeah, but this only works because fib is a pure function. That means it does not have side effects. It does not read global variables, write global variables, God forbid, open a socket or something. So that's a restriction I'm going to put on the scripting language we're talking about today, but it's a quite sane one for lots of algorithmic tasks. So are we done? Just memorize stuff and somehow do things incrementally? Unfortunately, it's not quite that simple, because think about what else happens while you code. Quite often, the code is changing. So if we add something into this function, its result also changes, but we still want to have some way to remember the results. And what even worse would be if we have this function that reads a file. Now, imagine a file changing in your system affects this behavior, the behavior of this function. So in the end, whenever anything on your system changes, any file changes, potentially the results we cached are invalidated. So the whole program, your whole program is input to a memorization, the whole hard disk state. Basically, anything can change anything. So let's not even talk about what happens if this function throws an error. And this is the problem we faced at Types. And we solved this with a technique we call constrained memorization, where we add an additional type of input to functions, a tracked input. And for this input, we observe at runtime what parts of it were observed. So going back to the file system example, if a function does not read any files, then we generate no constraints on the file system, so any file system is fine. But if the function reads 1.txt, then we generate a constraint that says 1.txt needs to have this specific checksum for our memorization to be valid. And in this way, we can basically memorize stuff while a lot of stuff is changing, and only if something affected a function, we have to throw away the memorized results. And I could talk a lot more about this, but as you all know, I have 5 minutes, so let's instead talk about the cool things we can do with this. For example, we can have these cool hover tooltips, where when we hover over a variable, so the cursor used to be above val, then we can see val takes on the values 0, 4, 8, and 12. And you can also hover over the for loop and see it produces the string 0 and 4 and 8 and 12 end. And the same thing applied to autocompletion is seen here. We have code that at runtime decodes a string written in YAML, and the autocompletion picks up on the string, the strings in the, so the keys in the string and the values in the string completely dynamically. There's no type hints or anything. And of course, we could also do this without the incremental part, just running the code over and over again and observing the values. But the cool part is that incremental execution makes this so cheap that we can actually do it for IDE tooling. And yeah, so how did we get here? I did this for Types. We built the system because Types is a modern LaTeX alternative that aims to provide incremental preview of your documents. And as it happens, it also has a full integrated scripting language. So we kind of were stuck with having to deal with this. How do we increment these, evaluate these incrementally? And that's why we built this system. And yeah, that's it.
Mike. Okay, thank you. We just need a few seconds to just get things back on track.
You have to turn it on again.
While Richard gets ready, the slides get ready, and we'll be able to get going. That's just the rewinding everything. All the action is happening on this screen. Obviously, none of you can see it, but I can tell you it's really entertaining. But I can't really comment. It's be dead boring. We ready to go? Almost.
Okay, that sounds better. Okay. Yeah, so I'm Rich from the .NET team at Microsoft. And so we're kind of like a new entrant in the Ubuntu community. Our product was added to Ubuntu in 2204, and so that's been really exciting for us. And so our next version is going to be shipping, I think, next week on the 14th, and it will soon be available in Ubuntu. Okay, and we've also been working on chiseled container images with the fine folks at Canonical, and those are GA this month. Okay, So this is just like 4 or 5 slides about what we've been working on. So we're super big into performance. So you can see each release we've put even more effort into performance. So we have apparently 1,250 improvements related to performance in this release. And all of our releases are 1 year. Like that's how long we work on them. We have this third-party performance benchmark that we work against called Tech Empower. They're basically benchmarks from like tons of different programming languages. And we've put a lot of effort into this over the past almost 10 years. And so one of the benchmarks is called JSON, another one's called Fortunes. And yeah, you can see that .NET has continued to get better, and you can see some programming languages are less good at this. So .NET works on both the client and the server, but these days we're super focused on the cloud. You might know that Microsoft happens to own a cloud, so that's part of our motivation there. So one of the things, I'll just focus on 2 things from this slide. We added a non-root user to all of our container images, to our entire fleet. And so it means that we wanted to make it a 1-line change for any .NET developer who builds containers to make them non-root. And our goal is to make .NET among the most secure, basically container platforms in the industry. And then the other thing that we did was worked with Canonical on chiseled images and make those super small and have very few components in them so that they're easy to maintain over time. Okay, very related to that, we have been working on making our container images like way smaller. So I'll just basically talk about the start and the end of the journey. So if you like basically take your app and do nothing to it and just deploy it on regular Jammy, your container image compressed will be 86 megabytes, so that might be more than that you want. On the complete other end of the spectrum, we have some tools that you can use to trim your apps down. And we also have native AOT. What that does is it compiles your app to native code, and the runtime we use for that is quite a bit smaller. And so if you basically put all of these tools together, your app goes from 86 megabytes down to 8. So that's basically 1/10. You're more than capable of doing the math. So we're pretty excited about that. This is new, and we think a lot of developers will be interested in that. And so before we had native AOT, basically these were our numbers for our product on both Linux and Windows. We're super big into Linux. And this is our numbers after. So you can see that we've kept the rightmost numbers pretty high, which is requests per second. That's all good. But all the other numbers are way lower. And you can see, other than one of the numbers, I think, yeah, basically you can see the Linux numbers are really excellent, particularly for startup. And that's it. So I made it with 20 seconds to go. Anyway.
Brilliant. Thanks, Rich. I think this one works now. Thanks, Rich, and thanks to all our speakers. I wanted to have a big round of applause for people who are watching live, because we really appreciate it. So thanks a lot for bearing with us. Now you remember, very easy time to remember. 8 p.m., games over there. 9:30, games in the pool. If you're not a fun person and you don't like gaming, you can come back here at 9 a.m. That will be very happy to see you again. Someone else will be on stage, so on my side, thank you for the day.